Hey, hello there. My name is Jeff Fritz, and welcome to .NET Conf Focus on Microservices. We have a full day of terrific content for you all about .NET, microservices, containers, Kubernetes, and we've even got some new tools that we want to show you along the way here throughout the day, live as part of another one of our .NET Conf Focus events. Now, there are all kinds of speakers that you're going to hear from throughout the day today, and it's your chance to speak to them, whether it's here on Learn TV, it's over on the Focus.net Conf website. Maybe you're watching us on Twitch or even on YouTube. We're going to be streaming to all of those sources concurrently so that you can catch up and see what's going on and talk to the speakers and learn a little bit along the way. So if you want to ask questions, if you want to catch up and mention anything, you want to talk about what's happening right here on .NET Conf, head out to Twitter and use the hashtag .NETConf. And we'll pick those up. We've got a tag board. We're going to review and show and share your questions with some of our speakers so we can get answers for you and you can get that great feedback that you're looking forward to. Now, we have digital swag available for you as well. Check it out. Head out to aka.ms/.NETConfSwag. And we've got some fun mouse cursors, phone and desktop backgrounds there for you. All right. Now, we've got just a few seconds more before I bring in our keynote speakers. We're going to be talking to them throughout the day today. Well, for at least this first hour, we're going to hear from them. But we want to hear from you right there on Twitter. Make sure you use that hashtag so that we can relay your questions. Pick them up on our tag board and share it with our speakers. So grab a beverage. Make sure you have some water. Make sure you have maybe a nice cup of coffee or a cup of tea, whatever time it is in your time zone, so that you can join us and enjoy all of the great content we have for you. Now, our first speakers, our keynote, we're going to bring on, we have Scott Hunter and David Fowler. They're going to introduce the day for us, and I'm going to send it over to them right now. Scott and David, you're up.
Awesome. Thanks, Jeff.
Hey, Jeff. Thanks.
So welcome to .NET Conf, focus on microservices. I'm Scott Hunter. I'm the Director of Program Management at Microsoft on .NET. You can follow me at @CoolCSH. And David?
I'm David Feller. I'm an architect on .NET. I'm going to talk to David about microservices.
Okay, so let's get going. We always start .NET Talks with, when I joined Microsoft in 2007, .NET was primarily about desktop and web. And today we've added cloud, mobile, gaming, IoT, and AI. We think .NET is a platform for building any app you want to build. It's great for all those types of apps. We've had a lot of awesome momentum in .NET. We shipped .NET Core technically around the beginning of March of 2017. So we're about 3 years into the journey, a little bit over 3 years. We have over 1.5 million .NET Core developers today. We've been the most loved framework in Stack Overflow's developer survey in both 2019 and 2020.
Scott, you know what? That is really awesome. Can you do me a favor and share your screen?
Oh, that would be nice, wouldn't it?
I was like, where are the slides?
I always start these things off with a little entertainment here. How are we doing, Jeff? Slides?
Awesome.
Okay. Let's make Fowler go away. So back to that momentum. 1.5 million .NET Core developers in the first 3 years of the product shipping. 2 years in a row, most loved framework on Stack Overflow developer survey. And as I said, we open sourced around 2014. And since then, we've become one of the top 30 highest velocity OSS projects. Top 5 language on GitHub. And we take part of this performance benchmark, a public one that we don't run it here. It's actually run in the cloud by some other folks. And we are 7 times faster than Node.js. So it's, performance is a huge part of .NET for us. And when we look at the people that actually come and download our product for the first time, we're finding that a lot of those are students that are learning to program and using .NET as their the first choice. Some other amazing things is, .NET adoption. We have 5 million .NET developers today. We've been growing at about 1 million developers a year for the last couple of years. And in the last year, we added 600,000 brand new .NET Core developers. And even more amazing is, as I said, we've only been on this .NET Core journey since about 2017. And that's the version of .NET that actually, opened .NET to Windows, Mac, and Linux, and many other platforms. And we already have 2 million people, or 2 million publishes to Linux from our tool chains. So it's showing that people are adopting .NET on Linux, which makes us very excited. .NET Core 3, which we shipped at the end of in November, or just or technically September of 2019. We shipped our LTS in December of 2019. It's the fastest version of .NET that's ever been adopted. I mean, what I mean by that is roughly 2/3 of our developers at all tried .NET Core 3 in the first 6 weeks of its shipping dates, which is amazing. We want our developers to be on the latest tech, and that was a tenet of .NET Core, was you could install the latest one without breaking anything else. And so we're seeing that adoption. I mentioned before, performance is key to our platform. We want to make sure that no matter what you're building in .NET, you get the best performance no matter what technology you use. So if you look here, you can see as we look at .NET 5, which is the version that's going to ship this November, 30% socket performance improvements on Linux over .NET Core 3.1. We're always working on trying to get JSON serialization to be faster. You can see 20% improvement over .NET Core 3.1. For large collections and arrays, 3 times improvement and 0 allocation of memory in the process here. And then one of the things that David and I are going to talk about today is a technology called gRPC, which is a great way of doing contract-based RPC calls. You can see here that when it comes to the client, we have a super performant client, more performant than gRPC on Go. And you can see on the server, we are super performant as well, just a little bit over the performance of Go. And I think that's amazing. We just shipped gRPC support in .NET Core in the 3-wave. So it's pretty new.
And that isn't all. We actually had a blog post that Stephen Tobe wrote on the .NET blog that actually shows a ton of performance improvements around regular expressions and other things. So this is just a few of those a snapshot of those changes.
So .NET Core 3.1 LTS, it shipped, as I said, December of 2019. And our ask to our developers is build all your new .NET apps on this today. It's the stack to build if you're building new applications. And we have preview 7 of .NET 5 that's out there right now. Once again, you can install these side by side. So installing .NET 5 preview 7 will not break anything, and you'll be still good to go. But if you want to try some of the new stuff, please download and try that. I want to quickly talk about how we ship .NET. We used to ship .NETs kind of on some random cadence of whenever we were done working on some features or something like that, and it made our support story kind of complicated. So we want to be very clear to our customers. We're going to ship .NET every November, and then every other year it's going to be what we call an LTS release, or a long-term support release. So it means if you want to stay on 3.1 or 6.0 or 8.0, each of those comes with 3 years of support. If you want to be on the bleeding edge all the time, just grab the yearly release whenever you want. But the hope is that this makes it very predictable when the next release is going to come out, and you don't have to guess. We have our big launch event, .NET Conf 2020, which is going to happen November 10th through the 12th. We're going to launch .NET 5 there. It's a 3-day virtual event, and you're going to see here, call for content is going to be open. It's not just us talking at .NET Conf 2020. It's also a bunch of the .NET community. So please mark your calendar for that. And I want to call out, we have some amazing speakers over the next 2 days. We've got Brendan, Kelsey, Julie, David, all speaking today. That's going to be amazing. And so after David and I are done, please stay on the line so you can actually hear from these folks. And with that, let's talk about what are microservices.
What are they? So microservices is an architectural pattern, and it's mostly about scaling teams as your app grows in complexity what you want to do is figure out how to split your application into loosely coupled components so you can deliver value to the business more quickly. And the reason for splitting it across boundaries is to have teams run independently so they can deploy their services without having to worry about each other. So traditionally, Scott, if you were to hit the slide, you see deploying a monolith would require deploying the same service to all of your servers. With a microservice, teams can run individually, deploy their services, and scale them independently.
Yeah, to me, the way I think of this is, when I first started building software, we'd have one huge monolithic team that built an application, and we all had to synchronize and ship it all at the same point. The idea of microservices is really to break your project up into groups of stuff, and each of those teams can actually ship their thing on their rate of speed,
on their own cadence, right?
Not waiting for that huge monolith to happen. So it's a faster, more modern way of doing development.
Right. Let's talk about containers. And why they're important for this technology. So historically, your app definition and dependencies were kind of split across your application tier and the VM itself. So if you want to install some software, you have to combine your application configuration with something like Chef or Puppet for deployments. With containers, Scott, if you were to hit the slide, containers let you describe your application dependencies from the app down to the actual OS dependencies in a single immutable format. So I can describe my application and its dependencies in a simple way that has now become a standard across the industry.
Yeah, what I was going to say, my take on this, David, is the on the left, virtual machines. That really is take a machine you have in the office and basically kind of copy it as it is to the cloud somewhere. Right. The problem with that is you have to actually manually configure the host OS or the guest OS yourself, and then you put your applications on top of it. I'm a really big fan of containers because I in a single file, which David said is kind of standardized, I can actually declare how to build my OS and my dependencies on top of that without having to manually do that. So that's a lot of work that disappears. It also means I can share my Docker file or my container file with David, and he can run it on his machine, and he'll magically have the same environment in just a few minutes.
That's awesome. Yep. So traditionally, you'd have operators deploying apps to VMs manually. So you'd have a load balancer set up between your applications. You would deploy the applications to every virtual machine manually. Scott, keep going with the slide.
Yeah, I was going to say, look, if I look at that big gap, David.
Right. So having a human having to schedule or deploy applications to machines means you may end up with low resource utilization in some cases. With containers, we have a standard format and standard controls for resource management and for packing applications onto machines. So you can kind of move your app and make it more modern where it can support other container platforms. And you can use standard controls to limit resource usage and potentially push applications onto more VMs, or I guess less VMs, to take advantage of the space you have.
Yeah, you can more tightly pack that VM. Today, on that previous slide, we were showing you've got this app in this virtual machine. Let's say it's a huge virtual machine, but you don't have a lot of requests. Well, you've only got one app per virtual machine. That's kind of a waste of resources. And then over here, we're showing I can kind of start filling that virtual machine with container tech with more applications.
Right. Great animation. These slides are awesome. Yep, and potentially I could remove other resources that are unused, so I can better use my cores, save money.
And you see here by 2022, over 75% of organizations will be running some form of containerized applications in production. So we're seeing those benefits that David just showed you. People are seeing those benefits and using them to actually improve their applications and use less resources. What's behind this growth? This is kind of interesting. Kubernetes, once again, is an orchestration engine. As David was going through the slides, and we showed those virtual machines running your applications. Well, as soon as you moved all that work into that single box, well, what did that? That's an orchestration engine. And there's the most popular orchestration engine today is Kubernetes. And you can see here that huge companies like Capital One, eBay, SAP, Spotify are all using Kubernetes today. And why? Well, one of the main reasons is it's vendor neutral. You can see here, it works in the Azure cloud, it works in AWS, it works with Red Hat, VMware. It is not tied to any particular provider, which means as a company, you can use that technology and not worry about where your app's going to be hosted. And it's also, there's a huge active community around Kubernetes as well. And so you can see the number of contributors and contributions to it since it was built. And that's why we're seeing this become popular. Now, I want to scare you a little bit here. And this is a crazy slide kind of showing how Kubernetes works. And you're going to see lots of boxes and lots of arrows and lots of stuff. Wow. I'm kind of like David. I just like to work on my code and get my code in the cloud. And this honestly scares me a whole bunch. And so when I see this, I'm like, eek. And one of the cool features we're going to show you today is, one of our goals with .NET is to basically give the best developer productivity. You can build the best application and you can do it with the least amount of hassle. And so we're going to show you some of our technology called Thai, which will let you develop locally and do all this stuff you see in this crazy slide, but not have to worry about it. That's David and my's job, is to go and take the hard parts of building cloud applications and simplify them down with .NET. So let's talk a little bit about the investments in .NET in the microservice and containerized app space. First off, REST APIs. The world runs on APIs. We all have smartphones, and you're checking your sports scores or the news or whatever. And when that happens, your device is out there pulling some API somewhere in the world. And we have amazing tech in .NET around this. We're going to show some demos of it later today. One is we support the Open API standard, and that is a way of describing a REST API. And that allows tools to work, client generation to work, and so it's an important part of this. I have something called the API REPL, and what that is that's an environment. Traditionally, .NET applications were client applications, whether it was a desktop app or a web app. Starting your debugger and having it show you a blank web page isn't very useful. And so we have an awesome feature in .NET called the REPL, where you can actually launch your API into a command line interface where you can see all the list of your APIs, you can call them and debug them live in our tooling chain. Client generation, that's another part of this. If you've been using .NET or you come from using .NET Framework, you might be used to things like WCF, where you could basically write a service, and then you could just right-click on that service and say, generate me a client, and you could easily call that service. We want to make that same capability available to REST. And so we'll demo a little bit later on. I can right-click on an API and generate a .NET client. Now, the cool thing about Open API, because we're using Open API, if you needed to, you could take that same Open API spec from your API and generate a client for Java or Node or any other technology. And so it truly lets you build clients across all the platforms. And then finally, there's some pretty awesome capabilities in Azure for hosting APIs. And we're adding support in Visual Studio to let you publish directly to Azure API management. The next thing in cloud-native investments is gRPC. I think of REST as being, this kind of standard. It's been open up for a long time. It's kind of text-based. It's meant where you can actually change the API over time and not have to update the client. But that said, a lot of our customers actually like having tightly bound clients. You're coming from WCF or one of our remoting technologies, and gRPC does that. But gRPC is a little different in that it actually is supported across all the tech. So you can have a gRPC service in .NET and call it from Java, call it from Python, call it from language of your choice.
And one big difference between the two is that you'll see gRPC be used intra-firewall, so intra-cluster, and you'll see REST APIs being used as your public API service as a big thing.
And once again, we're going to offer the same features for gRPC that we offer for REST, meaning that we're going to let you, in gRPC, there's a file called a proto file. It's where you define what your service looks like, and it has to be its own format because this is cross-language technology. And then from that, we can generate the server for you. So you just have to override some methods, and we can generate a client for you. So you can just easily call that service. And then once again, because it's .NET, you've got world-class performance. I mentioned earlier, one of the missions of .NET Core was to let you build cross-platform applications. And there's been some pretty amazing technology that we've released inside of Windows earlier this year, something called WSL2, which is the Windows subsystem for Linux. And what that enables me to do, I can be on my Windows machine, and inside of Visual Studio or Visual Studio Code, I can compile and run my application on Linux just as fast as if I was on a Linux machine. So you can stay in the familiar Windows environment you're used to and develop on Linux, and you're running native Linux. And we'll demo that in a little bit. Microservices. David and I both hear this all the time, that customers are telling us, especially on public social networks, that .NET's too big for building microservices. And I always laugh, what is too big? Like we're going to show today, a microservice written in .NET Core using ASP.NET, we can shrink that down to 30 megs or less. Is 30 megs too big? The notion that .NET is some like 1 gig huge framework, is that those days are over. .NET Core, you only ship and use what you actually need. We can take that microservice, we can crank it down to a single exe, so you don't have to have .NET on the machine. You can just deploy the single exe to the machine, and using a new C# feature in C# 9 called top-level programs, we can get rid of all the ceremony of building a C# program and just have your actual microservice code there and nothing else. We also find that with all that work we've done in performance, we've started building a high-performance reverse proxy called YARP, yet another reverse proxy in .NET to support many of our internal teams. It's once again, it's a show that .NET is fast and performant and good in this space. And then I think the coolest demo is going to be later today, and this is something called TIE. And when I showed that Kubernetes slide with all those boxes and all those diagrams, the whole point of TIE is to enable you to build microservices, which is, for a .NET developer, that means you're going to have more than one application. You might have two back-end applications. You might have a front-end application. You might have a service that's not even any of your code, whether it's, it could be like a Redis cache. How do you run all those things locally? Do you have to write Docker files and all the goop to do that? And we're going to show you that with .NET, we can push some of that stuff away and enable you just to build your apps and run them and debug them locally, and easily deploy them to the cloud. And so I'm super excited about that.
Yeah,
and I'm going to let David talk to the slide about TIE here.
So TIE aims to be a tool chain to simplify microservice development and deployment. And the idea is to basically add some veneer over things like service discovery. Scott, can you keep going? The slides. Yeah, support things like adding dependencies, Redis and SQL. So the idea is that if you want to run and test your microservice locally, you have dependencies on databases, caches, other services. So you want to be able to describe your entire topology, or at least for your one service, in some kind of format. So I can describe my service dependencies for my applications, my dependencies on SQL and Redis, et cetera, without having to learn Docker file support or Docker syntax, I should say. And I can run a debug locally on the machine or in the container. And I can also run in Kubernetes running locally. And then as a final step, I can actually deploy that up. Oh yeah, dashboard. The local dashboard shows logs and metrics and shows me my application topology. So I can see my services all running locally, what ports they're running on. And then as a final step, I can take my application definition that I have locally and then deploy it as a whole to Kubernetes, right? Running either locally or AKS or in any cloud that runs this thing.
Yeah, so to go back to these again, the way I think of these is when service discovery via configuration conventions. How many developers have actually, built a front end and a back end and got confused when, oh, I forgot to put something in a config file somewhere, and so the front end can't find the IP address and the port of the back end.
Right.
TIE will do all that for you. Add dependencies. Historically, if you were going to build a .NET application, I know David and I have both done this. Hey, let's go install a copy of SQL on our developer box. let's go see if there's a Windows version of Redis we can install in our developer box. Yuck. I love Tide because I just say, a couple lines of text and I have a Redis cache. A couple lines of text, I've got a SQL. By the way, that same SQL will work on my Mac.
Right.
So that's super cool. I can do inner loop development, running and debugging outside of containers, inside of Kubernetes, all without really thinking about all the mechanics to do that. The dashboard thing is something I don't know why we haven't done this, David, in like the whole existence of .NET Core. Being able to actually run your app locally and see the logs.
See logs.
Once you run more than one app, David, in .NET it's damn near impossible to see the logs without having windows all over the place.
4 consoles up to see things. Yeah.
And then I love the final one. You just type, Tide deploy, and your containers go up into your container registry so they can be run in Kubernetes or whatever. So super exciting stuff. Now, of course, you don't want to hear David and I just sit there and rumble against slides all day. So let's do some demos. Ooh. And so first demo I want to do today is I'm going to drop down here. Hey, Jeff. And we will do a web API. So what I've got here is I'm in Visual Studio and I've built a default API project. And we give you a simple get method that returns the weather. This version of the app is a little different than the stock one. We're going to fix that later this year. But if under my dependencies here, you're going to see I've got a package and I've added Swashbuckle. And Swashbuckle is a package you can grab today. Just grab swashbuckle.ASP.NET Core. And what that will do is that will add support for OpenAPI to your application. And that's going to enable some of the things that I'm going to show today. So if I just took this app as it is here and I run it inside of Visual Studio, we will do the right thing. We'll open a browser tab and we'll show you the results of the API, which is good. If you have one API, if I had 25 APIs, this is not so good. But we have a couple of cool techs here. I can take the app here, and I'll just take the URL because I've added Swashbuckle. I can come here and say Swagger. And because Swashbuckle is installed, I get this awesome web interface where I can go look at my APIs. Once again, simple app, so I just got one. I can click weather forecast, and I can try it out, and I can run it right there and see the results. So this is not bad. Just by taking that app, and if I had more than one API, I can launch a web window here, and I can try the API out. Now, I can also click this link here, and this brings up a Swagger definition or an OpenAPI definition. This is a JSON file that describes my API. It enables that UI that you just saw to happen, but it also enables more things. I can right-click on this, and I'm going to save this over here because I'm going to want to use this a little bit later on. So I can take this definition, save it. It's exposed as an API you can see as well. And what can I do with that? So I'm going to close the browsers out here. And what I'll do now is I'm going to go up here and change my ICE Express to the HTTP REPL. And so there was that web interface that I showed before. This is going to give me more of a command line kind of interface. And so let's put a breakpoint in my API. And I'm going to F5 the application. And now notice command prompt comes up here. And now I can just type regular commands like give me a dir. I'm in the weather forecast folder. I can jump back up to the top if I wanted to. I can run a get. When I run the get, notice my breakpoint hit. So I can run this step through my API, all in our tool chain. And you see I've got a great inner loop right here where there's the results of the API. So whether it's going to a web interface, which requires a lot of clicking, or I can go to the REPL, which I can just easily just type get commands, post commands, stuff like that to easily exercise my API. Our goal here is to make building APIs in .NET even better.
That's super cool.
let's stop debugging and let's build a client. So I'm going to go to my solution, and I'm going to right click here, and I'm going to say add new project. And we'll build a console application here, and we'll call this client. I want to show how easy it is to call that API from .NET. So I've got a just regular console application here. And what I would do next here is I'm going to right click on my app. I'm going to add, and I'll go to service reference. And this is new tech that we built in .NET Core 3 timeframe. Notice I've got this service references Open API or gRPC. I can click add, select Open API. I can give it a file or a URL. In this case, we'll give it a file. We'll take that same Swagger I saved before, open it up here, click finish. And now what's going to happen is our tool chain is going to go out and grab any of the NuGet packages required to use that API, stick them in my project. And so now if I wanted to, I can click these ellipses, view generated code, and you can see all the goop that we wrote for you to call that API to make it super simple. You don't have to write this. Is that awesome, David?
Yeah, looks super efficient too.
So now what I've done is I quickly put some stuff here to write a client. Got to fix a few things. We'll add that. Wants my method to be async. We'll do that. And so if you look at this code, all I really do here is I new up an HP client to call something. I then new up the generated Swagger client, giving it the HTTP that I just did, so you could set some options on there and have that ready to go. And then I just call client.weatherForecastAsync, and then I can just loop through the results. So you saw I have an API. I want to write a client to call it. Super, super simple, super fast to get it to run. And now I'll show you one of the frictions that Dave is going to show in a little bit that we fixed. So if I run my API again, there we go.
I love that hard-coded port, Scott, in your,
I'm going to turn the
program
off here. Yeah, that hard-coded port, that's going to come back and haunt me in a little bit. So that's not a good thing. Let's do that. There we go. So I ran the API, but Visual Studio is not great today. We're going to fix this at running lots of projects. So I'm going to right-click over here, and I'll say debug, and we'll say step into a new instance.
It's kind of painful, right? Running two applications to test the client server.
Every time I do that, starting one, starting the other one, clicking through here, and now I can actually just kind of come through here, and we can write the results of that out.
Nice.
Which is still pretty cool. I mean, if you look at my output window there, you can see the weather coming out of there. So I was able to easily build an API in .NET, debug and test it, and build a client. All awesome. A little friction at the end, as I started trying to run multiple projects. And I said, in a few minutes, Dave is going to show us how we can easily do that with Thai. So let's close that out, and let's switch over to gRPC. And so for gRPC, same kind of scenario. I've got an application, and we'll just run it real quick. And you can see it starts up. It's running once again on a port, but it's a little different because it's gRPC. And I mentioned before, gRPC is kind of platform neutral RPC. I have to define my API in a format that's not C# or C++ or Java. It needs to be something that we can generate all those different texts from. And so here you are. I've got a weather response. You can see it's got a date. It's got two temperatures and a summary of what the weather is. And I've got a method here that's basically get me a weather stream. And you can see I call it with no parameters, and it returns a stream of this type. Now, once I've done that, what I would do is I would right-click in my project again, like I showed before. I would do add service reference. In this case, I've already done this for myself. And notice that it says here, let me just zoom in, weather-server. And so what this has done for me is it's actually generated the server code. And if I look here, I can once again view that generated code. Here's a bunch of gRPC goop that we don't want you to have to write. All we want you to write is this method right here. Notice public virtual get weather stream, and it's abstract. This means you have to write the code for this. We just write the shell of it. So this file, which you never have to look at, writes all that goop for you. And then all you have to do is go in for your service, and basically you're going to see here I override that one method, and then write my code to return the weather. So you build your proto file, you generate the server code, and then you override the class and write your method. Great. So I've got my service. Now, once again, let's go do the same thing we did before, and let's write a client for this. So I'll do add new project, and we'll do a console application again. We'll call it client. Do a create. There we go. And I'm going to do the exact same steps again. I'll right click. I'm going to do add. And by the way, everything I'm showing here, you can do from command line as well. So this is not limited to a Visual Studio experience. If you want to use Visual Studio Code, you want to use Writer, you want to use a command line, all of those are supported. I'll do add. This time we'll select gRPC. And I'm going to say, let's go find that proto file that we had before. It's in here. Unlike the Swagger file we had before, this is a proto file. And you'll see on the dropdown, I can say, build me a client, a server, both, or messages only. I'm going to say I want a client. And once again, we're going to do the same thing. We're going to go out to the internet, grab the right NuGet packages for you, and we're going to generate some code for you again. There we go. We're done. And this one, once again, if you want to see the code that we generated, here you go. You don't want to write any of this. Go back to my program CS, and what I'll do here is the same thing I did before. There you go. It's going to complain here. Let's fix a few of these. And it's going to want this to be async again.
More hard-coded ports.
More hard-coded ports.
I love it.
Yeah, that's going to work. That's going to work great in production, isn't it, David? When I go and take this thing and go, let's go put this in the cloud. Okay, so I fixed a few things here. I'll quickly just kind of describe the code. It's pretty simple. I create a channel, and that's kind of where I define the IP address and the port that I want to call on. I new up a client, just like I did before in the REST case. I just called a method on the client, client.getWeatherStream. That took an empty parameter, so I passed nothing into it. And then I basically can loop through and run the application. So let's try that. Okay, you got the server running. And once again, this is kind of clunky. I'm going to go here and take the second project and say step into a new instance. And now I can basically F10 through the app. And you'll see the same stuff before. Very simply, I was able to go build an app. It's displaying the weather the same way. That's the productivity we give you with .NET.
Awesome.
Let me stop that. I'm going to do 2 more quick demos, and then we're going to jump over to David and let him do an awesome tie demo. So I'm going to close this window out as well. Let's see if we can see Fritz again. Hey, Fritz.
Hey, Jeff.
Okay, let's talk about microservices and .NET. And once again, we talked in the earlier slides. David and I talked about .NET has this history of being this large framework and building huge applications. Take a look at this. This is a .NET microservice written in about 10 lines of code. The actual microservice itself is 1 line of code. It's kind of like, hey, when I'm called, do this. It's a hello world, but David's going to show a much better example of this with more functionality in a little bit. But the point we want to make here, if you've never seen .NET or used .NET, you don't have to write lots of code or use huge frameworks. You can, .NET's amazing in that you can use as much or as little of the framework as you want. If I run this application, it's going to complain. I don't know why it complained, David.
That is strange.
Not right now. Thank you. Let's try one more time.
Try running.
I'm going to cheat. I'm going to use Kestrel.
Let's use Kestrel, yeah.
And we'll run it again.
Boom.
Cool thing about .NET, I can use the built-in web server. I can use .NET's web server. There's my Hello World application. Super, super fast, super simple. But I want to show something. You know, before we were asking that question, David, what's the right size for a microservice? What would you say, David?
30 megs.
So I switched to a command prompt over here, and you can see I ran .NET publish. I said make a release version for Windows Windows x64, and I passed two flags. Make a single file. This is a new feature that shipped in .NET Core 3, where you basically can pass a flag, and we'll take .NET and your app and shove them into a single file. And then I added another switch here called publish trimmed, and that's where we go through and figure out what parts of .NET you're not really using, and we remove it. And this lets you actually build pretty small applications. So if I jump over here, I happen to have a Explorer open up in this window, and there is my 29 meg .NET microservice. I showed this at build, and I showed even smaller. I was sub 20 megs, and I want to show it is real. I double clicked it, it runs. I can grab that. The app works. So if you thought you had to build, 100 meg or 1 gig microservices with .NET, that's just not true.
Right.
One final demo, and we'll switch to David. This is how I want to show a feature that how fast you can build applications that run on Linux. So I'm going to run this again. Now look at this. Boom, that was very, very fast. This is running a simple web application in .NET, and it's showing what it prints out here is the environment.os version. So you can see that I'm running this on Windows, and so it's going to show Windows. Now what's cool here is my machine has WSL2, Windows Subsystem for Linux 2, installed on it. Because of that, I've got an extension added to my VS. Notice here, WSL2, I can change my run environment to that. Now what that means is when I run my application now, it's not going to run on IS on Windows, it's going to run on the Windows Subsystem for Linux. So let's run this. And look at that. Now my app is running on Unix on my same machine. And the startup perf is really, really good. Almost as fast as the Windows startup perf. Now that I've got it loaded once, boom, just comes right up. And it's not just that you can do that. Notice I have a breakpoint here. I can run the debugger, and now I'm actually debugging on Linux on Windows. There's the breakpoint hitting. I run the breakpoint. There I am again. And that's just, we're showing you that, you can build awesome REST APIs. You can build awesome gRPC APIs. You can develop on Linux on Windows. And now I'm going to switch over to David and let him show some containers.
Scott, before you switch, can you show the slide?
Yeah, happy to do that.
All right, so we're going to show a very simple microservice application. It's the weather application. And it's funny because service and application get used interchangeably. But by service, I mean an individual application, an individual thing that runs. An application is the overall end-to-end microservice. So I have a Blazor server front end that's going to be my UI that will show weather updates from the weather service. The weather service is going to pump updates over a gRPC stream to the Blazor server front end. And in the background, it will also send updates to Raspberry Pi climate control service. And the idea here is that .NET can run in multiple environments and places on Raspberry Pis, in the cloud, and locally. Let me switch to my machine now to show you this application. Start sharing. Can you see that? Minimize everyone. All right, so if I open up Visual Studio, you'll see the 3 applications that I had earlier in the diagram. Blazor Weather Server is the Blazor Server application. Climate Control is my fake Raspberry Pi that will become real as we go on further, and Weather. All right, so let's start with the Weather application because this is actually where the data is being created. So the Weather has a background service called Weather Worker. And Weather Worker is a background service that runs when the application boots up. And the goal of the Weather service is to ping a backend service called AccuWeather, which gives us weather information, and read the forecast and get the first object from that forecast. Now, since we're doing a keynote and we can't have failures, what we do is we use fake data. So we'll create a random value between 50 and 100 as our temperature. And here's the code that pings the Raspberry Pi Climate Control, giving it that weather information over a post on a background timer. And then we store the value in a cache locally on this machine. And the intent of that is to avoid having the clients, as a result of pinging us, having us hammer the background service. So we don't want to hammer AccuWeather so we can cache the results here. And that's done on some fixed interval. So every 5 seconds, you should see an update for the weather information.
Yeah, the way I think of that, David, is imagine you're paying to call that service, so that service can only handle so much load.
Right.
By caching it locally, you could have millions of clients call your application, but you're only calling that REST API, AccuWeather, once every 10 minutes or something like that.
So you're self-throttled, basically.
Yeah.
All right, so now we can go to the protocol, with the goal being that I want people to call me, so I want to expose a contract for my application. So here's the gRPC contract for the weather service. It has a get weather stream streaming API, so that this stream weather response returns a stream of responses in a long-lived connection, and get weather returns the latest value. And this is the actual weather schema. So I've defined my schema, I've defined my services, and now I can share this with anyone who wants to call me as a client. And if I look at the same tooling that Scott showed before, you'll see I have this wired up in the add connected service dialog. And you can see the weather profile is configured. It understands it. I can view the generated source code as before to see the goop that got created by adding that file. And if we look at the weather service under services, you'll see I have a derived weather service from Weatherbase. Getting the cache via dependency injection. And I'm going to implement get weather stream by doing an infinite loop, essentially, and waiting for the client to disconnect, because this is an infinite stream. And every 2 seconds, it'll pump out the latest cache value. And we basically do some work to translate the forecast coming from AccuWeather into the gRPC model. That's some code here. All right, so now we have our background service, we have our gRPC endpoint, and we have the data. So now the next part of this is to go to the client that calls that backend to figure out what it's doing. So here's Blazor Weather. It is a server-side Blazor application. And let's start by looking at the dependencies first. So the first thing I want to do is to be able to connect to that service. I have to add the same gRPC protocol, but instead of generating the server, I care about the client. And Scott showed this in his previous demo. So I can do the same thing, see the code that was created by that tool, which isn't that important. And if I look at the core page, the forecast page, what it does is it's a Blazor application. So here's some HTML, and here's some UI that isn't that important right now, but here's the meat. When the page starts off, we call into the gRPC backend to get the first value for the weather, to get the snapshot. And then after render completes, we start a stream that is long-lived, that runs on this interval. So we call the get gRPC stream method, passing in empty and a cancellation token. And we use C#8, await for each to loop over the asynchronous stream. And every time there's a weather update, it'll update the current weather, and it will fire state change. State has changed. What it does, it'll make the UI change after seeing the update. So we can actually view the changes live in the UI.
This is
The
really
last,
cool, David. I love the fact that stream, the
yep,
server is really pushing the data to the client, not the client's
yeah,
pulling the data. So whenever
exactly.
the server updates, the client updates.
Yep, that's one of the key features of gRPC actually. The end-to-end streaming between client and server in a standard way. It's a very nice feature. And there's some goop here to make it reconnect if it fails. So if I kill the backend or it dies, it has this back off where it kind of delays and retries. That isn't that important right now. And then the last service is our fake Raspberry Pi that we'll see later. So here's a simple top-level C#9 program that kind of has the same thing that Scott had, where he showed his simple microservice, but it's doing a little bit more. This application is going to run on the Raspberry Pi, and it's going to get temperature updates, and it's going to print out either the temperature is too cold, too hot, or just right, based on the information passed to it. So it supports a simple route that's posed. It gets a variable. I parse out the value into a temporary variable, and I print out. Actually, I'm not sure if this is temporary or temperature, but it prints out the temperature and some sentiment. Is it too hot, too cold, or whatever? There's also a very fancy ML model being run on the server side, the weather classifier that classifies the weather based on the image passed in, and the default implementation is super advanced. There it is. Accurate, I say. All right, so let's say I want to run this now. So as we saw before, what Scott did is I want to run the front end. So I'll go to my console window and type in the Blazor weather server. I'll run this with .NET Run. It should start the application on port 56919. That port is always free.
Write that down.
I know. And I'll run it, and then didn't work. So the issue is I need to run the front end and the back end because this is a microservice, right? I have more than one that's required to run. So I could open up a second window, find the weather backend in .NET Run, or what if I told you that like magic, I could just run a command called, and by the way, ls, there's nothing here. There's no files. There's just a solution and nothing else, right? Just random stuff here in the root. If I run this, it'll do some magic behind the scenes. And it tells me that there's a dashboard running on port 8000. So let's go there and see what it's doing. It's building projects. So I'll boot up the dashboard, and it's showing me now all my projects that I have in my solution running without any configuration at all. I can click on the Blazor weather server application, and it shows me the application running. So here's the application. It has the temperature and it has both. Oh, this feels better. This feels at home. Okay, good. So it has both Celsius and Fahrenheit, and it shows an update every 5 seconds from the background weather service. So the gRPC stream is pumping changes to the client, and the client is changing the UI based on what temperature it is.
Yeah,
and
I can see the updated changing just dynamically there, Dave. It's amazing.
Yeah, it's pretty cool, right? So see, it's cold now, so it went blue. And if you look at our ML model, it's working pretty well. So it's looking at this image and trying to figure out what the weather is, the sentiment. All right, so that works. And the other part of it, the dashboard shows me logs for every service. So I can look at my Blazor weather server and see logs in real time, see it update logs. So you see it's printing a debug call to get gRPC message. And then I can look at the weather service itself to see calls coming into it and calls going out of it. So I can see it posting to the Raspberry Pi the temperature on this fixed 5-second interval. And I can look at that device and see, it printing out blah is too hot, blah is too cold, blah is just right. All right, so I can see in my overall service running, all 3 services running, seeing logs. I can also see metrics. So I can look here and see counters. I can look to see if my application is performing properly. That's a pretty cool feature as well. And there's some more hidden stuff. And if you want to learn more about this, you can see the talk that Justin and Glenn are doing later today. But let me show you how this actually works. So I said I didn't have to make any changes. That was a little bit of a lie. I had to make one change. So I ran 3 applications, and I had to tell the Blazor front end about the back end. So how did that happen? So in startup, I'm using very standard APIs. There's nothing up my sleeve. And this is the old code. The old code was hard coding the address very carefully, handcrafted 5039 because that port is always free on every machine. And here I can instead call a help that Ty had, which is get service URI, weather. So weather is the name of the service defined in the dashboard that I have here. It's based off the project name by default. I can say, give me the URI for weather. And it doesn't matter where that comes from, right? It will be passed into the application on boot up, and it can discover where that is. So the port can change on every run, and it doesn't matter because the application isn't tied to that specific port. It's tied to a configuration value that Ty will pass into it.
And David, that port and IPs is going to change when you publish the cloud as well. So this is resilient to publishing as well, right?
That's right. It works both locally and when you deploy. I want to show that as well. So weather, let's look at the weather. The weather does the same thing for climate control. So it talks to the Raspberry Pi by getting the climate control address and then publishing to it, right? So that all works great. Now, what if I told you I want to run this in a container? Well, what you would do is you would install Docker, you would learn the syntax, you would author Docker files for every single project, you would copy the content from the CS proj into Docker files. Basically, and there is great support in VS for like adding Docker support, right? So I could do this for my projects and then figure it out. Or I could Ty run -- Docker. And Ty will basically, Ty understands .NET and understands what it means to build a container from a .NET application. So it can automate doing all the manual Docker file things for you. And you can see my application here is a project if you see in the faded UI. And if I refresh it now, it should change to, did it run? Okay. It should change to container. So there it is. So now I have my applications running locally. 3 of them still working with the same service discovery, running in Linux-based containers, no longer on my physical machine directly. And this is the same application with the same configuration, no code changes, running on a Linux container on my machine, right? I didn't have to configure a compose file. I didn't have to write any container file, Docker files. All I did was have a solution file with a bunch of services, and it ran.
Amazing. That's awesome. Just one command line switch, and the whole app is running in containers.
Dashboard still works. Logs still work the same way. So it's the same feature set, just within containers now, right?
That's awesome.
So that's cool, but that isn't all. So what if I wanted to actually push this somewhere live, like on the internet, so everyone can hit it and destroy my demo in the keynote? So there's a command called Ty deploy that I won't run here now because it takes a little bit to run, but I can run it and it will load my application and it will ask me for where I want to push my containers. But I have a console app up here that has a previous deployment. So I ran Ty deploy, I passed in my Docker Hub account, and it found my services, it containerized them, it pushed them to Docker Hub, it created the Kubernetes manifest, and it pushed them to my active Kubernetes, which I have a cluster configured on Azure right now. And if I do a port forward, and the idea here is that I'm trying to basically show you my application running in the cloud, but I haven't exposed my application to the internet. So I can port forward a single service, the Blazor front end, to show you the application running remotely. Just to prove it, I can run kube control get pods. And here's the Blazor server application running in Kubernetes and Azure, all 3 services. And I port forwarded the Blazor server application to port 8006. And I made no code changes. So I have the same call to get service URI in my application. And Ty understands how to produce the right configuration for deployment. So you don't have to change the application when you run locally or when you deploy to Kubernetes. So here's the same app running live in Kubernetes, in Azure. And just to prove it a little bit more, I can show the logs of one of our containers running. So here's the climate control, it's too hot, it's too cold, logs running directly in Kubernetes on Azure. And then for the finale, see, we're going pretty well here, right? I have one more thing to show you. So there is a Raspberry Pi running somewhere on someone's machine, somewhere in the clouds. and I can run Ty in it. So normally Ty can work off a solution file, but if you need more control, I can run Ty in it and produce a Ty YAML. A Ty YAML just describes what services I want to define in my application. And I'm going to make one small change. So here I have my Ty YAML. It has the weather service, which points to the weather project. Same for Blazor, same for climate control. So I have a Raspberry Pi running somewhere else in the cloud, and I can say, you know what? Swap out that one service for this external address. And this is to make that call to get service URI continue to work. So I'm defining this service, but I'm not defining how it's run. And if I Ty run this, Ty run, and I pop the dashboard again, it'll show 2 projects and 1 external. So now I have the app running, and it's going to this other random ngrok URL for the Raspberry Pi. So it's posting updates from the weather service to the ngrok URL, and that should show me, is it on the stream? Is it live?
It's live.
Oh, awesome. Is it updating? So now we should see the
updating.
weather being synchronized on the Raspberry Pi with the weather in the Blazor application. And it's Celsius because that's what decent people use. No offense. And that's the final demo. So Ty can orchestrate services running both locally and remotely without you having to change your code in either situation.
Can we show the Pi?
Yeah. Is it not? Oops, my bad. Is it on the stream?
I think Brady has to share, right?
It is currently it's running, and that is my camera that you see. I don't know if Jeff can make it bigger.
Jeff, can you make that bigger?
We have the camera up, and folks can see the Pi there on screen.
Oh, cool. Also, we can't see it, but it's on the screen. Okay, good. That's awesome.
Cool.
It's still too
Can
hot.
I take back over David for a second?
Yeah. Yep. Go ahead.
Okay. So I'll share real quick. Is that back up, Fritz?
Yes, sir.
Okay. Just to recap really quick, we showed a lot of stuff today. .NET's awesome performance, great for microservices. We have awesome support for REST and gRPC. We can make small single file exes that are small and use little less memory. With Ty, David just showed some amazing tech, building multi-part .NET applications, running them locally, running them in the cloud, running them on containers, running them on Raspberry Pis. You can just imagine the possibilities with Ty. And then with top-level C# programs, we showed you can build APIs with a minimal amount of code. We'd like to say, enjoy the conference. There's a whole bunch of talks here on the screen. Please watch these. As we called out today, if you want to really deep dive in Ty, some of the folks in the team are doing that later today. And finally, if you have any questions, ping us on Twitter. And with that, I think Brendan Burns is next.
Thanks.
And thank you.
Thank you, guys. Really appreciate you kicking us off with this keynote. There's a whole bunch of questions out there on Twitter already. We're going to take a quick break as we bring on Brendan, and I'm going to ask Scott and David if they can just check in with some of those questions that we have over on Twitter as we get Brendan ready to come on and start our next session. Thanks so much, guys.
Thank you.
You're live.
All right, cool. Hey, everybody, welcome. I'm really excited to be here. I'm Brendan Burns. I'm going to be talking about why you should care about microservices. And I've been working on various microservices for a long time and thinking about, more importantly, thinking about sort of the motivations for why we're interested in this sort of approach to designing our distributed systems. So hopefully this talk is interesting. This is a first time, really, that I'm giving this talk. I've given variants of it in the past, but this is the first one for this deck. That's always an exciting experience. So we'll see how it goes, but hopefully it will go well. All right, so why do I care about microservices? I actually don't think this is the important question, because really, I hope that you're not necessarily interested in why I like things or in why I'm interested in things, but rather I think it's more important for you to say, why do you care about microservices? Because ultimately, this is about how you and your teams build your services and build your products. And so I'm going to really hopefully turn the question around and not talk about why I care about them, but why I think you should care about them. And so why should you care about microservices? Well, I think you don't, actually. And in addition, if you maybe thought, well, I actually do care about microservices, I would say you shouldn't care about microservices. And so with that, I think my talk is done. So thanks, and we'll give you the 50 minutes back. No, I'm kidding actually about that. But I am serious about the fact that I don't actually think that you should care about microservices in and of themselves, right? I think too often we get hung up on the hip ideas about how to build something, or the new technology, or the new approach, or the thing that someone else was talking about when we were talking to them at a conference. Back when we talked to people when they were at conferences. I think, and those are really ultimately bad reasons for choosing a technology or choosing an approach to building your software. Just because everybody is talking about microservices as being better than monoliths, if you're happy with your monolith and it's working for you, you shouldn't change, right? I mean, there's no reason to, if everything is going well, there's no reason to change, and yet people are changing, and I think there's a reason for that, and there's a lot of reasons for that. So there are good reasons to go to microservices, but they're not microservices in and of themselves, right? We don't want to go and do things just to be buzzword compliant, or to dress up our resumes, or to make our CTO happy. We want to be grounded in what we actually care about. So the question then is, what do you care about? Right? If we are going to talk about microservices, and I do promise I'm going to spend the rest of the hour talking about microservices, what is the thing that you actually do care about, and what are the things that you actually care about that are then going to motivate an interest in microservices and an interest in taking your existing applications or building new applications in this paradigm? Well, for starters, I think you care about your product, right? Ultimately, at the end of the day, we are building software because we're excited about the software that we're building, right? We're excited about the characteristics, the features, the pieces of the product that we want to get out to people, right? And we care about agility, we care about ability to fix bugs, we care about ability to take this idea that is in our heads and turn it into a reality that people can use, right? So you care about your product. I hope also that you care about your users, right? Because it's one thing to build a product that matches up with your expectations and your desires and what you think should be out there. But ultimately, if it's not delighting someone, if it's not being useful for someone, I mean, it's fun, I guess, to build stuff, and I do actually like to build stuff. But ultimately, what I really like to do is build stuff that other people find useful. Right, so I hope, in addition to caring about your product and caring about getting all the features that are in your head out into the market, you care a lot about your users, and you want to make sure that the product that you're developing is reliable, doesn't have downtime, doesn't get hacked and spend 4 days down like my watch did recently. You care deeply about not just delivering this thing into the world, but delivering it in a way that is useful to your end users, and also probably iterating along the way as you pay attention to what they need and the features that you need to help develop in order to continue to delight them along the way. Similarly, there's a ton of user expectations around multiple screens, around automatic data saving. We live in a world now where the expectations of what you need to deliver when you're delivering a piece of software are extremely high, right? And those are user-driven expectations, right? They are not sort of an inherent characteristic. They are something that users come and demand, right? That data be the same when I'm on my laptop as well as I'm on my phone, when I switch computers, when I go to a different network, and that I get to access that data, 24/7, every single day of the week, and all throughout the year. So all of these features are things that I hope that you care about deeply. But in addition to your product and your users, I hope also that you care about your team, right? Because at the end of the day, we're working together to build this software, and oftentimes when we're delivering it out into the real world at 24/7, we're actually monitoring and paying attention to that software. And there's a lot of human process that goes into both the process of building as well as the process of maintaining this software. And I hope that you actually care about those teams that are doing that. I think that we've all been in situations where we spend 80% of our day not feeling productive because of rote busy work that we have to do, or bugs that we just can't have the right tools to sort out, or processes that are bloated and heavy and difficult to use, bureaucracies around ticketing systems and waiting for approvals and coordinating with a bunch of teams and attending countless meetings on Teams. I hope that you care about your teams. You want them to be happy. You want them to be productive. And you want them to interact well together. And I would say that, again, all of this comes as motivation for why there's an interest in caring about microservices, right? So I said at the beginning, you shouldn't care about the tech or you shouldn't care about the design, but I hope that you do care about your product. I hope you do care about your users. I hope you do care about your teams. And I believe strongly that a microservices architecture is going to help you with those things that you actually do care about. And so instead of just tech or design for design's sake, actually we're going to walk through, I hope, some explanations about how I think this is really useful for addressing all of those things that you actually do care about. I wanted to take this moment to say this has actually happened before, right? Repeatedly, actually, as it turns out. Throughout the history of software development, we have come and we have taken time and said, hey, actually, the software development that we're doing is too hard. Our teams are frustrated. They can't work well together. They're doing repetitive things. Whatever it is, we need to change tech, right? And I think one of the first moments that I kind of personally experienced was the growth of object-oriented programming in the mid-'80s, which I think you can see, and the growth of really software engineering as a discipline. And I think you can really see that as a reflection of the fact that, in some ways, it's kind of the original microservice, right? Saying, hey, I'm going to take this, monolithic C program and break it up into a bunch of classes and a bunch of interfaces and use libraries and shared code and a bunch of other things. It wasn't a microservice in the sense of like distributed system or doing networking, but really object-oriented programming is microservices in the scale of an individual executable. And of course, over time, things have happened, and all those objects kind of got a little bit out of control and became fairly heavy themselves. And then we started saying, oh, actually, we're going to break up those executables, use network APIs and things like that. But really, the same ideas that motivated that original sort of destructuring of code in the early to mid '80s is in some ways exactly what's happening now. And it actually in some ways also happened earlier in the service-oriented architecture of the sort of early 2000s. It was that's sort of a precursor to a lot of this, I think. So I think this is a repetitive pattern. I don't actually think I think we give it a new name every once in a while. But really, it's a reflection of the fact that building software is hard, right? And so microservices are just another reflection on the fact that building software is hard. Except for it actually turns out that building software isn't hard. I mean, obviously, you have to learn how to write code. You have to get some degree of sense of how to design things, put them together, learn libraries and all that sort of thing. But the actual act of building software, I think, for each of us individually is actually not that challenging anymore, right? It was at one point. But tooling has gotten a ton better. We've spent a lot of time in the industry. We've gotten actually quite good at building software individually. The challenge is actually that building software as a team is very hard, right? And so it's not that the act of writing the code is particularly hard. I mean, sometimes there's a hard problem or a hard bug, but the act of writing the code is really not the hard part. The fact that you have to get a whole bunch of people to work together efficiently in different locations, with different expectations, with different approaches, different design aesthetics, different levels of confidence that the unit test is working correctly, and possibly even different skill levels, means that it's extremely challenging to build software, right? But it isn't actually the coding part, I don't think. It is, in fact, actually the team part. And so I would actually argue that microservices aren't really an architecture for delivering software, although there are arguments you can make about reliability and things like that. But I think ultimately what they come down to is the fact that microservices are about scaling teams, right? And so this is really, I think, what we're trying to get at every time we talk about, when we talked about object-oriented, when we talked about service-oriented architectures, when we talk about microservices, when we talk about whatever the next thing that we talk about is. What we're really talking about is the fact that scaling teams is hard, like really hard. And so like at some level, I always, one of the things I'd like to say to people is that technology changes all the time, right? Technology changes, every year, even newer. .NET 5 has just come out, so tech continues to change and evolve. Humans change on a much, much longer scale, right? And so I think one of the things to reflect on is that as we keep changing this tech, we're actually just continuing to try and solve some of the inherent problems in humans, because we can't really change humans with the same pace that we can change tech, right? And so I think in general, we look back, we can see the same patterns emerging sort of over and over again, because ultimately it's about the humans, not about the technologies. There's a ton of research and anecdotal evidence and my own personal experience that the ideal team size is 5 to 6 people. Right, and this has sort of been characterized as the 2-pizza team, or the single room startup, or the garage startup, or whatever it happens to be. But I think whatever your favorite sort of metaphor or analogy for it is, this feels very real to people, right? So taking a look at why this is the case, well, you can all sit in one room, right? Well, not anymore apparently, as it turns out, but you can at least sit in a virtual room. Where you can, communicate with each other and kind of have that daily experience of like, hey, how's it going? Talk about the weekend, talk about your pets, talk about your kids, talk about your, spouses. Have that kind of relationship where you actually have a personal relationship. It's not just a relationship that's based on the fact that, I have to work with that team over there. I have to work with that team in that other office. Similarly, if the amount of code that 5 to 6 people can spit out, like you can actually pretty much keep it all in your head, right? There's just not like the volume of code. I mean, over time, I guess eventually, you're gonna not be able to keep it all in your head. But like the amount of code that 5 to 6 people can churn out, basically most people can keep all that code in their head all the time, right? And that's really, really valuable because, of course, it means that you don't have to swap in every time, so code reviews are faster. It means that you don't do things like just kind of like rubber stamp a code review and not really understand the implications. So, the ability to understand all of the code that's going into your project is a huge benefit of sort of these small team sizes. Additionally, you can understand your product, right? So I think, when you look at really large scale products, let's say a PowerPoint or a Windows or even a Kubernetes, it's hard to keep every single, piece in your head or even necessarily know about stuff. Like, people are constantly saying, oh, what about this, sort of esoteric Kubernetes feature over here, and assuming that sort of I have deep understanding. And I'm like, well, I didn't have anything to do with the development of that feature, and I haven't used it, so I don't necessarily understand it, right? So past a certain scale, it is actually hard to keep, the focus, the product in your head. Right, but at a small scale, you can keep the product in your head, and that's essential because, like, if your developers don't understand the product, then they're just kind of doing what they're told. They're not actually investigating. They're not actually understanding why they're doing what they're told. They're just doing it, right? And that's not a good place to be. I think the other thing that happens in these small teams is you understand each other, right? Like your motivations are sort of largely shared. You have the same kind of aesthetics. There can obviously be differences within teams, but they tend to get resolved at the small scale, right? Like it's very hard in a small group to kind of spend your entire life in an antagonistic relationship with someone who, you're spending most of your time with, right? And so these small teams tend to work better together because they all understand each other. They're like, oh yeah, that's Bob. He really cares about, code review. Oh, that's Alice. She really wants to see product velocity. And they understand that aspect of things with each other. And they don't get as frustrated, right? So like all of the kind of interpersonal dynamics are just smoother. Whereas if like you only interact with another team once every month, you're more likely to get frustrated, right? And you're more likely to see each other as the enemy, which brings you to sort of the last part, which is you're all on the same team at this size, right? In a small scale team, everybody more or less feels like they're on the same team. Right, and I can guarantee you, having been on some very big projects, in a big project, you don't necessarily, you sort of feel like you're all on the same team, but it's kind of more like, we're all roughly headed in the same direction, but within that team, there's rivalries and there's differences and there's all kinds of, different focuses, different interests, lots of different things going on, right? So I think the notion that this 5 to 6 person team is the ideal team size is pretty well founded. And I've certainly felt it for all of these reasons. But there's this problem, right, which is that most projects require an army eventually. Right? So there's this challenge of the fact that like if everybody had just ever tried to build stuff with 5 to 6 person teams, something like Kubernetes, something like .NET, something like Windows, it just wouldn't happen. You can't with the volume of work that is needed for projects like this. It just exceeds the amount of work that 5 to 6 people, no matter how efficiently and happily and understandingly they are working together, can generate, right? So we're stuck with this challenge of the fact that we need to be able to, or we want to be able to build software systems that require thousands of people to build. But at the same time, we are struck with the fact that these large-scale armies are just not super agile, right? Like if we look at sort of the classical army, it's a hierarchy and everybody has their role. And and to take the chess analogy forward, the pawns move in one way, knights move in another way, the king and queen and all of the different pieces, they have their roles to play. There's not a lot of agility beyond those roles, right? And so, I said earlier that you care about your users and you care about your product. There's an inherent agility needed in the development of all of these products that requires that you move in a way that a large scale, that the traditional way of organizing a large group of people just is not compatible. Right? Traditionally, to organize a large group of people, you establish a really big hierarchy. One person makes a decision, it ripples out, and yeah, you lose a little bit of detail along the way. But like, that is the sort of hierarchical pyramid is the traditional way of organizing large-scale people. But it just doesn't work for software, right? In part because there's all of these requirements around agility, and also, honestly, because in my experience, engineers are really bad at following orders. And actually, frankly, as an engineering leader, I don't want people to follow orders. Because as I said earlier, when you get down, you have to give people flexibility and freedom to both bubble ideas up, because they're the ones who sort of really understand what's going on, as well as to change orders on the fly, right? Because it could be that at the 30,000 view, it seems like one thing should happen. But down at the low level, it's actually like, well, I understand what you're trying to say with that. We need our reliability to be up. But the biggest problem with reliability isn't what you think it is. It's some other area. And if you don't give people the flexibility to make those sort of local adaptations, ultimately you're not going to be successful, right? Because if people are just sort of following what you are asking them to do, they're not going to do a good job. They're just going to do what you ask them, and you're becoming a single point of failure effectively because you have to be right 100% of the time. If you allow for flexibility and you allow engineers to sort of make their own decisions, you don't have to be right. You just have to be almost right. and then the people who are in charge of implementing them, those decisions can actually adapt to make it work. All right. Well, okay. So we sort of have this challenge, right? Which is that 5 to 6 person teams on one side, armies on the other. How do we get in the middle? And the answer comes back again in some ways to what I was mentioning earlier about object-oriented programming, which is that fortunately, software is modular, right? And so when we have thought about building software in the past, what we've realized is we can actually build pieces and widgets and then compose them together. And each one of those individual pieces can actually be based on, a contract and an interface. And if you look actually out into the world in general, this is sort of the way that people solve this problem out in the world as well, right? Like if you look, there's all sorts of interface standards out there, from things like outlets to things like fuel pumps to, many other pieces where people have said, actually, we're going to introduce an interface and a contract, and that way, effectively, we can separate ourselves from one another and yet achieve great things together. Right? It requires the outlet manufacturers and the appliance manufacturers to, create power outlets and plugs that work together. But they don't actually have to coordinate other than that. They don't, if I'm building some great new appliance, I don't need to go talk to the outlet manufacturers and be like, hey, I have a dependency on your outlet. I need you to launch some new outlet so that I can launch my new appliance. It's like, no, there's one interface. As long as we build to that interface. And similarly, the outlet people don't have to go and ask all of the appliance people to refactor all of their appliances just because we're going to launch, a GFCI outlet or anything else like that, right? So this idea of modularity is crucial to achieving this balance of, on the one hand, small team sizes, and on the other hand, achieving big things. And so, as I said, microservices really is all about modularity and finding the right pieces in order to break up into these 5 to 6 person teams. All right, so what are the pieces that we need as we go along this journey? I think one of the most important things to think about going forward is thinking about how we plan, right? Because I think most of the time when we get stuck in these giant monoliths or when we get stuck in these giant organizations, it's not that we set out to build a 500-person team with deep dependencies and 3 days of dependency review every quarter in order to coordinate our work. It's actually that we just did a bad job planning to scale, right? And so I think that at this point, we have some degree of sense for how you plan to scale a service, right? We didn't used to. People didn't used to. They would go and take a web server and put it on a database and put it on a single machine and say, hey, look, or single container, and they'd say, hey, look, beautiful, my application's ready to go. And then they would say, and then you'd say, okay, well, but what happens when you need to scale? And they'd say, well, I just create another one. And then you say, well, but you have 2 databases at this point. And they say, oh, that's a problem, right? Because I can't have 2 databases, 2 sources of truth. I want 2 web servers because I need to handle extra load. But I can't scale my database. And because I chose the wrong atom at the beginning, my life is now actually hard, right? Because maybe I took dependencies on the fact that the database is on localhost, and so I didn't do, really strict auth because I knew that nobody except for someone on the machine could do something. I'm not even using encryption, possibly. I could have made a whole bunch of decisions back when I was here that actually make scaling really a challenging thing for me to accomplish, right? And so I didn't plan to scale, although, as I said, I think this is better understood now that you have to plan to scale your service. And when you start out, you're far better off if you say, okay, well, we have a web server in a container and a database in a container, and they're separate. And that way, if I need to scale, I just clone out a few more containers and I'm ready to go, right? We're good at doing this, relatively speaking. But I think I would argue that we're actually quite bad at planning to scale our teams, right? And so I would say that if there's one sort of message I want people to think about is when you're starting in a project, and obviously I understand that not everybody gets the luxury of starting a new project all the time, but when you're starting that project, great that you're thinking about planning to scale your service. Are you thinking about planning to scale your teams? And this goes beyond just, the software layout, although we're going to talk a lot about the software layout. But it comes to things like, are you building leaders? Are you helping people learn how to be better code reviewers? Are you helping people learn how to be better at operating the software? Right? Like all of the aspects of scaling, how do you go from a 5-person team to a 10-person team to a 100-person team to a 1,000-person team? That is just as important. That planning to scale like that is just as important as planning to scale your server architecture. And in fact, actually, I would argue that they're deeply intertwined. Right? That you can't build a scalable server architecture without building scalable teams. And if you do build scalable teams, you'll kind of inherently build a scalable server architecture. All right. What does this mean in terms of the actual characteristics for how we scale our teams? Well, I think that what this means I think that what this means at first is to really revisit how we think about our applications. I mentioned earlier that customers have all of these expectations about multi-screen experiences, about seamless data transfer from one device to another device across different networks. And I think that fundamentally then what we have to say is that products are a UX on top of APIs. Right? And so when we think about building, if we think about planning to scale our teams, we have to think about one of the very first separations, one of the first decouplings that we would do is separating from a back-end team and a UX team. Right? And having a crisp API that is the contract between the UX and the back-end. And if you're starting out and you're building a startup or you're building a new product, you actually probably don't have a UX team and you don't have a back-end team. But if you design your system so that the API is there in the middle, just like designing your system so that there's a web server and database that are separate, you've set yourself up to scale your team when you do want to have or you do need to have a UX team. Or alternately, if you've built that separation into your product from the beginning, you have the capability necessary when you decide, oh, we're going to not just do web, we're going to do mobile web and mobile devices. Potentially, set-top devices or wherever else it happens to be, right? So just like separating that web server and the database, if you say, hey, a product is a UX on top of an API, you've inherently set yourself up to scale your teams to having multiple different UXs, all living off of the same APIs, providing the same user experience. If you're tightly coupled between product and UX, between backend and UX, it's very difficult then to take the web UI and turn it into a mobile UI. Because the coupling is just way too hard. And similarly, so not only is it challenging from a product development perspective, but it's also challenging from a team perspective, because if that line is messy, then your teams are hard to separate as well. Right? And so again, these things are tied together. It's not just about scaling your product, it's also about scaling your team, and they're one and the same. All right. So how do we actually achieve this sort of separation, right? One of the most important things in general is the establishment of these boundaries, right? I mentioned earlier things like the outlets, but I spent a long time talking about how a product is a UX on top of an API. The API itself is a boundary, right? And obviously with something like a web UI and a RESTful API, the boundary is very obvious. So it's an easy boundary to make, but it's not the only boundary that we would talk about. The database, if there's a database, a data service, NoSQL service, that may be a boundary as well. And then within that architecture, there's also a bunch of microservices. Maybe there's a background garbage collection task. We have to define all of these interfaces, and we have to kind of define them up front. Right? There was a lot of time when we were doing object-oriented programming when people talked about object design. Right? That was a thing that people spent a lot of time on, and I think it was because it wasn't just that it was a useful part of object-oriented. It was actually a different way of thinking than programmers had been doing. Right? So we spent a lot of time sort of re-educating ourselves to think about boundaries and to think about interfaces and to think about encapsulation and what should be private and what should be protected and what should be public. right? And so I think that we actually, in some ways, sadly, didn't take those learnings forward into the designing of these distributed systems, right? And so I would encourage you, as you think about building scalable products and scalable teams, think about designing all those boundaries, right? Now, of course, the challenge is, and this is one of those other challenges, that like you can overdo it, right? I've gone into situations where I've talked to people and they're like, we've got 80 microservices. And I'm like, how many people do you have in your team? And you're like, we got 6 people on our team. And I'm like, well, that might be a little overdoing it. 10 services per person, maybe not the right ratio, right? So, again, we have to make sure that the complexity is warranted. And, sometimes you're going to have to refactor, right? You're never going to get it right up front, but you should try. And you should at least anticipate the first few cut points that you're going to need going out over time. In addition to defining boundaries, but maybe sort of inherent from defining boundaries, is this idea of decoupling. Right. So in general, if there's a theme of microservices and the theme of these small teams, it's decoupling, right? So, it's not just a question of having different teams. You need to have different levels of access. Every team should have its own little workspace where you deploy the software, and only that team should have access to that workspace, right? Teams shouldn't all have access to the same database, because if everybody's partying in the same database, you're not decoupled, right? Everybody's deeply coupled through that database, and the shared resources that are within it, the shared schema that's within it. So I think you have to think a lot about not just breaking up, teams in terms of responsibility, but actually breaking up teams in terms of access, in terms of even technology, right? So that if you want to have different teams, they have the ability to make their own individual decisions. And I think that leads to that sort of decoupling leads to the corollary, which is you have to empower, right? So like it's not okay to just have an architect come in, define a whole bunch of boundaries and say, okay, you get this API, you get this API, you get this API, here's your keys to the cluster, and you should do this now. We have to, as part of the microservices and as part of the scaling of teams, we have to actually empower our teams to make their own local choices, to make their own local decisions, right? And so if we don't, if all we do is break things apart but we don't actually empower our teams, we're actually just making things more complicated, right? Because the whole idea is of microservices and of building scalable teams is to encourage local autonomy. And local autonomy requires trust, which is scary, right? It's scary to delegate trust to a service. It's scary to say to somebody like, yeah, okay, I'm actually not going to pay any attention to what you're doing except for your APIs. But it is ultimately actually also way more agile, way more resilient, and way more performant, because that local level of empowerment enables people to move much more quickly and independently and achieve all those positive things that we talked about earlier that you get when you have that small team. But there's obviously, some corollaries. We can't just all run off and do our own thing, because it would be anarchy, right? And so there's a reason. I mean, Hamilton came out recently on Disney Plus, and I watched Hamilton again, and I thought, about early stages of the country. There's a reason that in the early days when all the states were largely independent, there was a push towards a federal government. And the reason for that was because if you have all the different states making different commerce rules, it's very, very difficult to have interstate commerce, right? And so if we're saying ultimately all of these microservices are working together to build some product, we can't just have a bunch of massively heterogeneous microservices running out there with different interfaces potentially, or with different kinds of quality. There has to be some amount of consistency, or else building a product that is holistic on top of that becomes extremely challenging. So in addition, I talk a lot about separation and a lot about decoupling, but we actually also have to have some things that bring us together. So for a starter, so these are sort of the ground rules that I think you need to establish for all of these microservice APIs as we go forward. One of the most important things to think about is the deprecation policy, right? Like, and I think it's kind of shocking sometimes how few people have thought about this. I think everybody who's working on a programming language like .NET think about things like deprecation policies. When is it okay to remove an API? What's the cost of removing an API? But I think that we as people who build distributed systems don't necessarily think of that. Obviously, in the public cloud, we think about that with our public APIs. But I would say it's not just about your public APIs. If you really want to encourage microservices, you have to have deprecation policies for your internal APIs too. You have to have deprecation policies for data schemas, and you have to have deprecation policies for every service you provide, because if you don't, then you're introducing coupling, right? If you don't have a deprecation policy, then in order for one team to do something, another team has to move. And that sort of connection of hey, we're about to take out this API. Oh, we can't. Now suddenly I have to change my code because you're taking out an API, and I have to change it on your schedule, not on my schedule. Means that I've coupled my teams together, right? So every single service that you have has to have a deprecation policy. This really is something, again, you need to put in up front. Similarly, you have to have documentation, right? I mean, in general, I guess I would say that you need to treat every single microservice API that you build like it's an externally public API, or like your customers are, your internal customers are the same as your external customers, right? There is a sort of notion of first party equals third party that is a critical aspect of delivering on microservices, because if you don't do this kind of thing, then you're introducing, again, coupling between the teams, because in order for me to go and learn about what your API is like, I have to actually go and talk to you. And I'm not saying that talking to people is bad necessarily, but it is sort of a form of coupling that limits my ability to move independently, limits my ability to move agilely. And also I think in general, just forcing people to document their APIs means that you're actually treating it like it's a product, right? Because again, one of the most important things that 5 to 6 person team can do in delivering that microservice is to truly believe that their microservice is their product, something that they're proud of, something that they put out there into the world that they have customers of, and documentation is a part of that. And then the other part of being proud of it is quality of service, right? So if I'm taking a dependency on you, of course I want to know that the application is going to work well, but actually I need more than that, right? I need someone to stand up and say, this is my SLO. At the 99th percentile, this is what my latency is going to look like. This is the level of reliability that you can expect, right? Because if I don't do that, there's two problems with it. One is, as a developer, I don't know how to plan then, because if I don't know how high quality, if I don't know the quality of service that you're going to deliver in your API, it's hard for me to build against it and build a reliable service against it, because I just don't know what to expect. Is it going to fail half the time? Is it going to never fail? I can build against either of those APIs, but the way that I build against them is going to be different. Where I put my energy is going to be different. But I think the other really important part about quality of service is actually has more to do with debugging and figuring out what happens when things go wrong, right? Because one of the real problems that happens in a lot of these microservice architectures is that if there's a problem that is at the intersection of two microservices, there tends to be a lot of finger pointing, and the customer experience falls into the chasm between the microservices, right? So if I can point at you and say, hey, it's your fault, and you can point at me and say, hey, it's your fault, the customer doesn't care at the end of the day because it doesn't work for them. But the two teams can play blame games for weeks and not try and actually resolve the issue. If you have quality of service as a metric and you say, look, we're going to deliver 99.9 availability, and then you monitor that on both sides, right? So the service provider monitors it, the service receiver monitors it. You can actually look at the monitoring and say, well, did you deliver on your SLO? And if you did, then it's the client's fault, and if you didn't, then it's the service's fault, right? So the arguments about whose fault it is really go away if you really crisp and formally define the quality of service for your APIs. It's a critical thing to get right. And then in general, this idea that you need to push teams to interact via APIs, right? So teams need to interact with each other just like a customer, an external customer would, and not have backdoors and not have, we all just uploaded something to this storage bucket and then somebody else downloads it from that storage bucket. I mean, that could be an API, I guess, but it has to be formalized, right? There can't be any backdoors. And this leads to a lot of different important consequences. The first is this idea of don't ask, don't tell, right? Which means I'm not going to ask you about how you implemented your thing. I'm going to ask you what your API is, where your documentation is, and what your SLO is. but I'm not going to ask you how you achieve that SLO, and I'm not going to even care. And this is actually quite hard for engineers, right? Because engineers kind of really want to understand, how the sausage is made, how the thing works together. And so telling an engineer, like, I'm actually not going to tell you how I did it. I'm just going to tell you that I'm going to deliver this SLO is not an answer that engineers like to hear. But it is actually a really important aspect of the decoupling. Because if I understand how you're delivering on an SLO, I will understand that, I can actually take a dependency on specific behaviors of your API that may not actually be public, right? I can take very strong dependencies on implementation details effectively. And at that point, I'm tightly coupled to your service implementation, and I have made it impossible for you to evolve that implementation over time. So I'm really not supposed to ask you anything except for the characteristics of your API as defined by the formal API in the documentation and the quality of service metrics. And similarly, as an API owner, I cannot tell you. As much as I would love to share with you the details of how awesome I built my API, I shouldn't tell you because now I'm also enabling you to take deep dependencies that don't allow for coupling or that produce coupling. Similarly, I think this idea of trusting no one, right? It's really important that when you deliver these APIs, you deliver them in a way that you anticipate a hostile user. Because the truth is that people are going to be hostile, even if accidentally so. They will, DOS your API. They will call with bad certs. They'll call into production from a debug environment. If you really treat every single microservice API as if the public is on the other side, first of all, you'll build a more secure system because you'll encrypt everything everywhere. You'll ensure that there's proper authentication and authorization everywhere. But you also build a more resilient system because you'll have rate limiting and you'll have all of the and you'll have, the ability to ensure that debug traffic doesn't go talk to production in ways that if everybody kind of trusts each other, don't work out, right? And so in some ways, this is the same reason that we don't do cooperative multitasking in operating systems because even though it's all one operating system and even though it's one program, it's really much better if the programs don't trust each other. And then I think also it's really important to dog food your own APIs, right? So as you build these microservices, it's extremely important that you maintain the same sort of hygiene that you expect of your end users and the expect of other service teams of yourself. So just as I said, don't have backdoors, don't have leak implementation details to your customers or to your users. You really have to have the same hygiene for yourself because every backdoor that you leave open is something that someone else will take a dependency on. Even if you really say, we're only going to let internal teams do these kind of things, or internal people close to my team do these sort of things, it's just not going to, it won't stay that way for long, right? And so there's all of this sort of isolation that is an essential part of delivering on these APIs, delivering on these microservices. But there's also one last problem, which is that actually if you allow for all of this hiding and encapsulation, you actually allow for a ton of heterogeneity, right? And so you're going to have a bunch of different developers choosing a bunch of different programming languages. Some of them might even choose Java, although we try and avoid that in most cases. And this heterogeneity means that you don't have portability between your teams, right? If somebody wants to change their job for whatever reason, move to a different country, move to a different team, just have a different experience, it's difficult if there's this kind of heterogeneity, if there's this sort of polyglot nature. I'm not suggesting necessarily that you have to standardize on a single language, but standardizing on one or two, three or four is probably a good practice, right? Similarly, you could have people arguing about YAML and JSON and someone off in the corner still arguing that XML is a good idea. You have to, again, establish consistency in data formats. And also in things like front-end development, right? Like, you don't want to have your one UX written in Angular, another in React, another in, somebody still using jQuery, and God forbid somebody still using PHP. We have to establish core infrastructure, right? So it's not just the case that in microservices we want to say, okay, it's just the Wild West. We don't trust anybody. We establish these hard boundaries. We treat everybody like they're external. We do our own thing. We have to establish core infrastructure. We have to choose things like languages. We're going to say, hey, we're going to choose 3 languages. Those are the only things we're ever going to use. We're going to make choices around packaging and development. So, at this point, I'd say containers and container images are the choice for packaging and deployment. There's no reason to do anything else. Standardize on that, standardize on a way of building these containers, standardize on a base image so that if you have security challenge, or if there's a security issue, it's very easy to patch all of your images moving forward. Standardize on core infrastructure, like continuous testing and delivery, right? There's no reason for anybody to, for one team to use GitHub Actions, another team to use Travis, and another team to run their own Jenkins box, right? Standardize on one thing. I'd argue for GitHub Actions, but that's just me. But standardize on one thing as a piece of core infrastructure so that, again, there's consistency for your teams across. Similarly, for monitoring and logging and alerting, you don't want to have 14 different ways of sending pages to people because you're going to have different apps and different, APIs and all sorts of problems where teams, can't, forward an alert from one system to another. So standardizing on everything having to do with the operations of your software is a critical component, right? And there should only be one, right? So we make this big argument about lots of microservices and all sorts of heterogeneity. But there's places where actually just deciding and saying, hey, look, we're going to use Grafana and Prometheus and PagerDuty or whatever it happens to be to do your monitoring, logging, and alerting. That's a requirement. You just can't have teams make their own decisions in this place. Similarly, there's a lot of core infrastructure, I think, especially around how you deliver these APIs, that is essential to be shared. Right, so it's not okay to just say like, well, everybody puts on a JSON HTTP service and go nuts, right? You actually need to have deeper. You need to have a shared implementation of what that web server is. That's going to include things like shared implementations of authorization and authentication, shared implementations of rate limiting. I've gone through this recently where we discovered that multiple teams have different implementations of rate limiting, not even just that the implementations are different, but sometimes even that the algorithms are different. And it's a horrible customer experience, right? Because when I talk to one API, I get throttling information back in one way with one algorithm, and if I talk to a different API, I get throttling information with different headers and different status codes, and possibly even a different implementation that affects how I respond to being throttled. It's very, very difficult for me. I'm constantly putting in special cases, and the knowledge that I learned in one area doesn't translate to another area. So having that core shared infrastructure, not to mention having to do things like certificate rotation and things like that, those are problems that really you don't want each individual team solving because they're going to do a poor job, and also it's just going to be inconsistent and frustrating. And I sort of talked about this already, about how secrets and things like that also need to be, right? If you have certificates anywhere, think about how hard it would be to turn on auto rotation. If you can do it once, then you're in the right place. If you're thinking, oh my God, if I had to get every team that I work on to do auto rotation of certificates and it would take months or years, I would say you don't have the right kind of shared infrastructure in place. Similarly, for storage, you have to have a team. I mean, I would argue that storage is a microservice unto itself, whether you're using a cloud-based storage, in which case you've sort of delegated the microservice out to a cloud, or you're developing teams that are responsible for running your databases or running your NoSQL stores or running even just block storage. Treating storage like it's a microservice and not letting each team do storage both builds better patterns because the teams are going to build stateless instead of stateful applications, but also builds better consistency because you're not going to end up with 14 different versions of SQL Server running around. You'll have one consistent database that everybody, or at least one consistent database version that everybody uses. And again, that helps with performance tuning, that helps with security, that helps with any number of these really important aspects of delivering on a good application. And then finally, building out shared infrastructure for analytics and experiments. This is one of these things that people don't ever do in the beginning and always regret at some level. Like, you're going to get to a place where you need to do experiments, A/B experiments, where you need to understand, like, why are my users churning? And if you don't have shared experiment infrastructure built into every piece of your API, if you don't have the ability to do request tracing from the browser all the way down to the database, it's going to hurt you ultimately, right? So this is a key aspect of the shared core technology to deliver into the middle. All right, so we've gotten to the end. Hopefully that was entertaining, and hopefully my network didn't fail 2 minutes in, because whenever I do these virtual presentations, I'm always terrified that I'm only speaking to my cat and my neighbors who can hear me through the walls. But looking back, talking about and hopefully looking forward to the rest of the microservices day that you have in this .NET Conf, I want to encourage everybody to focus on scaling their teams. I think that if you focus on scaling your teams, you'll inherently be able to scale your service. But I think that the opposite is not always true, right? If you focus tightly on scaling your service but not on scaling your teams, you're not going to do the human things and possibly not even the API design things necessary to scale your teams. Think in APIs. This is kind of like that object-oriented revolution in the 80s where people started saying think in classes. Think in terms of APIs, think in terms of rate limiting, think in terms of authentication, think in terms of API design. Everything has to be done through an API. That will really help you get to microservice architecture. Focus a lot on empowering individuals, right? Because getting to this level of microservice really has a lot to do with enabling independence and enabling people to do the right thing in the right places without having to check in with some astronaut architect or some central board governing that tells people how to deploy software. And that's an incredibly important part of the microservices revolution. But also at the same time, build on shared infrastructure, right? So it's not just all about everybody being a cowboy coder out by themselves. There is also a ton of this shared infrastructure that is an essential characteristic and is also a huge accelerator, as well as something that is important from a human perspective, because while it's great to build these 5 to 6 person teams, the truth is that over time, as people's career evolves, you're going to need portability of people across those teams. And if you have shared infrastructure, people's career portability will be a lot better. They'll be able to jump from one team to another and hit the ground running. So I'm done. Thank you so much for listening. I hope it was entertaining. You can find me out on Twitter at Brendan D. Burns anytime. I'm always eager to chat. And I hope you have a great .NET Conf, and I look forward to speaking to you again. Thanks. I guess I actually have 2 minutes for questions.
Yeah. Thank you so much, Brendan. Really appreciate you. I got to put the headphones on. There we go. Can you hear me now?
I can hear you now.
Fantastic. So there were some really good questions that came through. Folks on Twitch and on Twitter, really excited, and I see some folks saying that they're halfway through building some microservice architectures, and they're inspired now to finish and move forward with some of those projects that they're working on. But I want to go to, there's a question here that came through on Twitter. Let me grab the tag board here and start sharing that so we can take a look. There's a question here from Nilesh that you might be able to help them out with. Can you mention some points on how to think towards migration from monolithic apps to your microservice-based application?
Yeah, for sure. I mean, I think there's 2 pieces to this. One is, as I said at the beginning, like if you're happy, like don't do it for tech. You got to have a reason. So make sure you understand like why, because I think that helps. Understanding why you would want to break up a monolith helps you understand how you want to break up the monolith. Right? Because maybe there's just like 2 services that are part of the monolith that, need a different kind of scaling, right? So you need to break it apart because you don't want to scale in monolithic chunks. You want to scale another service different from the monolith. And so then it makes sense to just break out that one service, right? Or break out those 2 services. Or maybe, you need more agility or experiments. And so in a particular area of your app, so it makes sense to break out that part of your app. I think my one high level general advice is, the V2 never works, right? So if you say, hey, like we're going to create a wholly separate team, got the monolith team here, they're delivering features, keep on going. We're going to create our new Tiger team of V2 people, and they're going to go and spend 9 months building the V2 and then launch it, and then we'll turn off the monolith and launch the V2. That never, ever, ever, ever works, right? So you're going to have to evolve in place. You're going to have to evolve over time. You're going to have to evolve with the same team, right? Because no team likes to be like the legacy team. Right, that's death. Right, so like you'll lose. Not only will you have a hard time, but actually all your best developers, will immediately leave the legacy team, and that's very, very problematic. Right, so that's my failure story, which is don't do the V2. That means you're going to evolve your monolith in place, and then looking at kind of what you want to achieve, what your motivations are for going to microservices, helps you figure out what pieces of the monolith to break up. And if you only break off like 50% of them, but you achieve 95% of the value that you need, that's great. Stop, right? And then just have like the 50% monolith, and it just lives on, and that's not a problem because you've achieved the goals that you needed to do. The goal isn't to get to perfect or perfect microservice architectures. It's to, empower your users and your product and your teams.
Very cool. Oh, thank you so much for joining us today, Brendan. We really appreciate it, and some good insights to get folks started with thinking and planning towards microservices. Really appreciate it.
Absolutely. Have an awesome time, and yeah, thanks.
All righty, and we'll be right back with our next speaker, Kelsey Hightower. You're live.
Hey, it's kind of weird when there's like no MC, so I'll MC myself. I'm Kelsey Hightower. A lot of you know me from the Kubernetes world, and I find myself at .NET Conf, and this is super, super strange because I actually don't know .NET at all, but that's actually pretty good because today I'm going to ask you to either consider or learn a few new things. So I actually dusted off the keyboard and gave .NET a little tour over the last couple of days. So I'll kind of share a little bit of my feedback of what it's like for someone like me to jump into the .NET world for the first time. Don't worry, this won't be a language war or a language comparison, but it will be some kind of, hey, this is where some people are coming from in your community. And I think today the topic is like this focus on microservices. And the title of my talk is interesting. People say, hey, how'd you come up with that title, Stay Sharp? Well, when you get an email saying, hey, what would you like to talk about? We need a title. This is what you come up with. But the bigger meaning here, honestly, is most people get very comfortable in their ways, right? So if you know Python or Ruby or .NET or C Sharp, sometimes we actually just stay way too tightly to what we know, and we do that for 20 or 30 years. Now, there's no problem with that, especially if you're getting value out of it. But I think in order to stay sharp, to keep your skills kind of where they need to be, it helps to pay attention to what's actually going on in the world to see if there are more tools or is there a better way to go about doing something that you're doing. So I think a little bit of experimentation is always helpful. So that's kind of the focus of today. And the other thing I want to do is make sure I can, what I wish I had when I was starting to think about microservices seriously. There's a lot of advice out there. There's a lot of what we call, or people will ask for, what's the best practice? And to be honest, I don't know what the best practice is. I think there's only practice, and maybe we'll talk a little bit about that. So I think the first question most people go to is, what's a microservice? Now, depending on who you ask, you're going to get a different answer, right? And I think we should probably start with the easier question than that one, which is, what's the meaning of life, right? I believe that this question is probably easier to answer than this one. And they both dive into kind of religious debates at some point. But I think the best thing you can do, honestly, is kind of focus on wherever you're at and try to get the most value out of your current situation. I don't know if there's a definite answer here, but I think the best thing to do is to focus on the fundamentals. This is the part where I think people go off the deep end the fastest. I was watching a little bit of Brendan's talk earlier, and there was a question around, how best to get to like microservices as if it's a ultimate destination. The truth is, whether you go with monoliths or microservices, I think the fundamentals can hold true in either of those particular architecture styles. So I'm just going to walk through what I believe are some of the fundamentals that if you were to think about them hard or closely, they might provide some value in the journey. That's all the slides I have. This is going to be a fairly short talk, and ideally want to optimize for a lot of Q&A, so maybe challenge some of the ideas that I'm putting forth. A little bit of background first. Someone coming to .NET for the very first time, it's very interesting. So some people will also ask, what's the best programming language or framework to be building microservices in? And I gave it a lot of thought. And the only thing I arrived to, honestly, is that the best programming language is probably the one you know how to use. Given the situation, given the task at hand, the ability to produce results is probably the most important thing that you can do. So if I go over to my laptop, you got to understand where I'm coming from. These days, I typically write code in the Go programming language, right? And I know what you're thinking. It's like, this is .NET Conf. How dare he speak blasphemy that there's another language that exists? But luckily for me, I think this is a pretty open community. But really, I'm showing you where I'm coming from to help you understand the way I'm particularly approaching this. And I think this is going to help a lot of people think about the path towards microservices. So for me, when I think about writing code or a service, in my world, I actually don't use the IDE. Now, I hear the life draining from the professional programmers who have like the enterprise grade IDEs. I actually don't use any of the IDEs. I actually use a very simple command line editor, Vim. So when I start writing a service, I like to keep things super small. So for example, if I'm going to write, let's say a Hello World app, right? Most of these services tend to look the same, in my opinion. You get a request, you do something in the middle, and you return a response. That pattern is pretty consistent. How many things the service does, well, that's going to be up to you, but here's a common approach that I take. These days, I tend to avoid large frameworks, and I'm going to show you why in a moment, but I typically try to build an app with as less code as possible. So when I'm writing Golang, if you can see here, I'm just going to walk you through. It's okay if you don't know Golang, but it reads pretty much like pseudocode. I'm going to log a few messages to my terminal. And I'm also going to just set up an HTTP server and respond to requests with hello world. Like, that's super simple, right? So here I just start with the log message. I'm starting my app. Now, here's the thing. Most people are like, why is logging so important? Well, trust me. If you're going from the monolith to a microservice world and you don't have good logging between those services, it's going to be damn near impossible to debug. Don't skimp on the logging. Even better, structured logging becomes a big deal here. If you haven't seen structured logging, imagine adding context to the things that you're printing, like the service name, the service IP, what other service it was trying to talk to. You probably want to have a lot more context than you normally do when you're all running in the same monolith. And then down here, if you look at it, I'm just adding a header saying what my runtime is. It's Golang. And then here's hello world, and I just bind to a service. Most people that are good at any of their programming languages can probably figure out how to do this in a very simple way. The next thing that I do in part of my workflow, again, a little bit of my background, is I like to test things locally. Now, why am I talking about testing things locally? I've seen a lot of people get into microservices and believe that their whole world needs to change. Some people believe that you have to install Docker, Kubernetes, Cloud Foundry, 1,000 tools on your laptop just so you can write a microservice. Microservices are supposed to be a bit smaller. So when developers go around asking for like a terabyte of RAM on their laptop so they can actually replicate production, there's two things there. Number one, you'll probably never really replicate production. You can probably get close to the workflow, but I don't know if you're going to ever get close to production. The second thing is, I don't know if you should necessarily write any service that requires a specific infrastructure to run. So whether you're looking at Lambda or Kubernetes or Azure Functions, ideally, you don't write code in a way that only runs on one of those platforms. Ideally, you want to preserve a little bit of agility depending on where you want to run. Typically, I test locally. So I'll just run this app locally. And my workflow these days is just hit it with curl, right? As long as it works with curl, I know that I'm pretty good in terms of moving on to the next step, which is deploying this particular app. And then we're going to get to my attempt at learning .NET here in a second. And don't laugh at me. I'm a new person to this world. Okay, so we have Hello World. Now, in my world, I like to try to normalize my programming language or framework of choice using container images. Now, I popped over to the schedule, and let me click on this agenda. There are a lot of Kubernetes talks at this conference, like a lot of them. So today, there is no need for Kelsey to talk about Kubernetes. So I appreciate all the other speakers that will be talking about Kubernetes today. And if you're interested in Kubernetes, I really think you should stick around for those. I'm just going to focus on maybe the price of admission to those container runtime platforms. So for me, no matter what language I pick, I try to normalize that decision as fast as possible. So in this case, this is a Docker file. Maybe you've seen one, maybe you haven't. But all of these programming languages have a different way that you go about either starting the project, building the project, or even packaging up its dependencies. One way that we want to normalize as much of this as possible. And who better to figure out how to build an app and how it should be packaged than the actual developer? I think this is super key when you start to think about your microservices. A lot of times it's best if those services are self-contained as much as possible. And that also means being able to produce an artifact that can be deployed anywhere regardless of the runtime. So if I step through here, I'm doing a bunch of Golang specific things. And then here I'm just running the Go command to create a static executable. I like to keep these things super lightweight. And then I can package this up and build it. So if I were to build this application, you'll see here that I'm just using, you could use Docker. I'm using a hosted build service inside of my environment. But ideally, you're going to submit up your source code and have a container image built. Once you have that, I like to think about deployment. So if everything works on my laptop, that is my litmus test, then I deploy to the simplest environment when I'm getting started. Now, I'm known in the community for being the Kubernetes guy. With Brendan Burns and Joe Beta, I wrote a book called Kubernetes Up and Running. But these days, I actually don't turn to Kubernetes first. Okay, so if you're Kubernetes fans, I apologize. But here's how my workflow looks these days. Once I package my app in a container, and I'm thinking about this kind of services model, I'm trying to deploy to the easiest, no-friction platform that I can. So typically, I'll pick some serverless thing like Azure Functions or Azure Container Instances. If you're in the Amazon world, that could be Lambda. And in the Google Cloud world, I would probably use something like Cloud Run, mainly because it gets me close to using the artifact that I produce in the previous step. Now, the goal with this is once I build my container image, I can just deploy that image from my container repository, hopefully hosted somewhere else, maybe in the cloud if that's your thing. Now, I'm going to show you how this works in the .NET world, just so you can kind of see that I think most of the workflows are going to be roughly the same. So if you're on the fence about what's the best framework, what's the best programming language, ideally, I think you can put your mind at ease because I think there's higher level concerns that should be where your focus should lie. So now that my application is deployed, I'm just going to hit this URL really quickly, and maybe we take a peek at how it was deployed, but this is my workflow these days. I run my app, we can see the header is set to Golang, and we see Hello World. Great, that's my workflow. So whether I'm working on 5 microservices or 10, a lot of times what I'll do is host the dependencies, the things I'm not working on, and code locally and stay local as long as I can. Only when I need to complete a deployment do I actually worry about containers or the serverless platform that I'm using. But day to day, I have not given up my local development workflow. So if you're using something like VS Code, ideally you do everything there. If it works there, you can pick and choose the platform you deploy to. So what about the C# world? Okay, this is how I started. So I looked at it and I was like, maybe I can do something like this, right? Program.cs and just start writing code. That didn't actually work well for me, right? So what do all good developers do when they don't know how to do something? They go to Twitter to complain. I am no different. So I went into this .NET thing thinking it was a programming language, but it seems I stumbled upon a mini operating system with support for multiple execution environments, programming languages, and now I have so many questions. And I still do, but I've been educated quite a bit. Luckily for me, people like Scott Hanselman exist in the world. And you can see people are calling Scott Hanselman to the task like he's Batman. And eventually, Scott Hanselman will appear. I believe he was probably sleeping and he just knew something was not right in the world. And he jumped on Twitter and he explained something super important to me. This block here. .NET's the ecosystem, CLR is the JVM, C Sharp, F Sharp, VB, and others are the languages, and then a bunch of other stuff. And I looked at it and it says, well, this is just the way that things work in .NET. But I got a lot clearer about what I actually needed to do. Later on in the thread, he also shared something pretty cool about how you get started. So he mentioned that I can actually just run a get started command to actually pull this off. Now, here's the thing. All I want to do at this point is write a simple service so I can get back and integrate it into the workflow that I already know. I don't want this language to be a big distraction to me, so I'm looking for the shortest path possible to using this particular program. And you'll see that a lot also in the real world. It's not very common that you see one company using a single programming language for everything. So I have a lot of empathy for developers that have to context switch between things like Python, Node.js, C Sharp, and maybe the Go programming language. But this is pretty common. So what advice did I get? Well, the first thing they said is you can just run this command, .NET new web, and give it a name. I was like, oh, sweet. So I run the command, and a lot of things are happening. Something about ASP.NET. I do remember that from back in the day. And I cd into this directory. Now, remember where I'm coming from. I'm coming from a world where everything lives in this one file. I'm only using this standard library. This is where my mind is. You also notice there's no classes, there's no object-oriented business here. And I come into this world, and I'm like, all right, I'm ready to go now. And I run the ls command. There's a lot more files than I think is necessary here. There's also this other folder. I have no idea why this stuff is here. I have no idea why I need it, but I figured that's the way it works. Now, what's the next step that I need to do? So I can pretend like I know the programming language. So I started with program.cs. Now, here's the thing. When people ask you to dig into the world of microservices, Kubernetes, and containers, they're expecting you to learn a lot. And a lot of the things that you see, like Docker files or Kubernetes deployments, I bet seem just as daunting as a Go programmer looking at a .NET application for the first time. So right around now is when I was like, I don't know if I'm going to figure all of this out anytime soon. And plus, I'm not using a nice IDE like VS Code to help me. I'm still in Vim with no syntax highlighting and no plugins. That's just the way I write code. But luckily for me, I scroll down, some of this stuff starts to make sense. I'm not going to pretend I knew exactly where to go in the beginning, but one thing I did figure out is most of this stuff is pretty much the same. The fundamentals are pretty much the same. So one thing that I figured out was you can actually just go into this program.cs. I'll drop down to the bottom. The only changes I really wanted to make here was like listen on port 8080, maybe something fancy like pull the port from the environment variable, and then just listen on that particular URL when I start up. And then I learned, after many hours of just trying to do this myself without looking at any other docs, I learned that you can edit this startup CS file. And then down there in the CS file, again, there feels like a lot of boilerplate here, but I get it. The fundamentals are roughly the same, right? I just want to respond, hello world. I figured out that this context response has a headers thing, and you can add headers directly to the code. All right, we're getting somewhere. So now that I got that to work, the next thing I did was figure out how to run it. And again, shout out to Scott Hanselman for helping me figure out how to actually make this work. Turns out I can call the .NET run command. It will compile it, even though I'm on a Mac, not on Windows, and it still works. I think this whole .NET Core might be the greatest thing that happened to this whole .NET ecosystem in a long time, because I remember there was a time where you had to have a Windows machine in order to make this work. Now, the last thing I'm going to do here is just make sure that local development is preserved. We'll also hit curl again. And it looks like it just works. We'll do -I, and we can see the header is .NET. Now, here's the first thing that I do once I figure out I can actually write code in a new language. I figure out its build tools. At this point, it's probably going to be largely syntax and learning some few frameworks. I need to get back to normalizing my workflow as fast as possible. And this is the key. So for me, I'm going to turn back to Docker to take all the things that I've learned and take all of these steps that I would normally run on my local machine. I'm going to throw them in a Docker file. So basically what I'm doing here is I'm going to just start from a Microsoft approved .NET Core image, going to run it on ideally a Linux operating system. That's where I'm going to be deploying. And I'm just going to make sure that all my code gets uploaded into this work directory app. And then I'm just going to do all the .NET things to create my release. Once I get it right just once, I know that this will be a repeatable process. At this point, I'm now back into a workflow that I understand. Different programming language, maybe optimized for the use case. But the nice thing is, it turns out I can probably do anything I can do in the Go world on the .NET platform, ideally with C# or F# of my choice. And at that point, guess what? The same scripts also work. I can just run the very similar thing here. I can run this deployment object. I'm going to do that now. And what I'm doing behind the scenes is I'm leveraging not Kubernetes, even though I'm using containers. I'm pushing both of those container images to a container registry. All the cloud providers have them. You can also run an open source registry if that's your choice. There are going to be a few differences. For example, even though .NET is fairly slim these days, I'll be remiss not to warn you that you're probably going to end up with like maybe 42, maybe I heard maybe as low as 30 megs binaries or tarballs that you spit out from Docker, because you have to bundle all of the dependencies, the runtimes, and everything you need. But the good news is, once everything's bundled, you don't need to worry about installing any of that stuff on the other machine. So I think the trade-off is worth it. Again, this whole container thing is allowing us just to treat both of these things the same. Now, I know you're probably curious, like how big is the Golang one? So a static binary in Golang, they're actually fairly big, but both of these are compressed, and you can see here, I'm about 2.2 megs. Now, why does size matter here, right? So most people are like, Kelsey, we're not shipping software on floppy disk anymore. What's the big deal between 42 megs and 2? Well, it turns out storing these things costs money. So the larger the images, the more you pay for storage. The other thing is, when we're deploying these things, you have to stream those bytes from a registry into your platform of choice. Today, I'm using Cloud Run, and what I've done here is I've deployed .NET to this particular instance. The reason why I like to start with this when I'm doing any microservice is just because I don't want to think about infrastructure. I want to delay that as much as possible, and I also don't want to code my app to any other platform, whether it's Docker or Kubernetes. I want to make sure that if it works on my laptop, it can work on a VM, Kubernetes, or a serverless platform. So if I click on this link, ideally what should happen is we should see hello world, and you can see that we're doing this from the .NET instance of my app. Now, a lot of you would be like, so how's that any different than what I'm currently doing? That's a great question. It shouldn't be very different from what you're currently doing. For example, 5 years ago, I wrote this blog post on Medium. Remember when we used to write blog posts on Medium? I heard that's not the thing anymore, but 5 years ago, it was. And I had this blog post called 12 Fractured Apps. It's a play on words, because when I learned about microservices back in the day, 12 factor was all the rave. So this is a dawn of the platform as a service. What's a platform as a service? One popular one would be things like Heroku. Always got to give them a shout out. Back in the day, I would say Heroku was one of the best platform as a services, and arguably still is. You just focused on building your service, kind of like we just walked through just now. And then once you build your service, you can run their command line tools and deploy your app. I don't know what the hell this is. This is not the platform that I wanted. So we'll scroll down a little bit here. You can find it on your own, but it's from the Salesforce folks now. But they came out with this 12-factor manifesto. And it gave some guidelines on how we should write our services to be portable, lightweight, and ideally, if you do those things, they'll be easier to maintain down the road. I encourage you to go study up on the 12-factor app, especially if you're thinking about going down this road of microservices. I really think you got to make sure you avoid the common trap, which is starting with these small services and then ending up with like hundreds of mini monoliths, right? Back where you started, but more of them. Wrote this post called 12 Fractured Apps. And the thing about it is most people jump into microservices without understanding the basics. So beyond 12-factor, what do I mean by 12 fractured apps? Well, fracture, if you get injured, maybe you don't quite break your leg, but you fracture your bone and it hurts like hell every time you try to use it. A lot of people apps are exactly like that. So if I were to scroll through this, there's a couple of things that I always ask developers to think about when we're dealing with a services world, meaning services tend to change often. They may move across different platforms, and we want to keep that agility. But the thing is, the infrastructure alone can't do everything. So a few things I want to focus on. A couple of things. One is when you're actually connecting to your application, one of the things in a 12-factor manifesto is going to be you should be able to leverage things like environment variables for everything. I kind of disagree with that one. Platforms like Kubernetes these days allow you to actually use configuration files. And one thing I encourage people to do, though, is to be able to start with environment variables, but fall back on a config file if that's what your app needs. You don't need to go and rewrite everything, but it's a valuable tool if you want to give people more configuration options. We'll scroll down a little bit more. Now, this is one that really, really makes system administration hard, especially for people trying to manage your app. Think about what it takes to connect to a database. Don't worry about the code that you see here, but basically, I need some configuration, maybe some credentials, and I can connect to the database. But what I see most people doing is they connect to the database. If it doesn't work, their app just crashes. If you're writing services this way, no matter how good the infrastructure you deploy to, it's going to be a nightmare to manage. Number one, you can't make any assumptions, especially in the microservice world, that any of your dependencies will be up at any given time. This is one of the biggest mistakes I see when people move into the services architecture for the first time. What ends up happening is people have to create these complex scripts to try to manage your application to start things in the right order, and it just makes rolling upgrades damn near impossible to do. What do I actually recommend? Well, I recommend what people do. I'm going to show you a little trick here that you can see inside of my logs here. I'm going to just scroll down really, really quickly. So in my logs, what I like to do is use a bit of code. I'm going to just show you some logs really quickly. Here what you'll see, that same app trying to connect to a database that doesn't quite exist. What I like to do here is assume that I'll connect to the database, and if it doesn't work, I'll just log repeatedly until the database eventually shows up. This set of logic inside of your app will go a long way to not assuming that you're going to be on the same server as the database or the database will always be there. The same is true for your dependencies. I want to cover one last thing before we jump into the Q&A. I'm hoping I'm sparking a few questions for you all. The last thing is code is a liability, all right? So I created this framework called no code. And a lot of people got excited about this. This is a pretty popular project, actually. It has 42,000 stars. Let me show you this. This is enough stars to actually start a business and raise VC funding. I can probably get an A round with this many stars. No customers, but a lot of GitHub stars. The other thing here is, if you think about the no code, the philosophy here is that, listen, code is a liability. The more code you write, more likely the more bugs or security or complexity you're going to introduce. So the no-code framework was giving people kind of the extreme measure of only write code when you have to. I encourage you to poke around here, but the big takeaway here is try to find a lightweight framework, because a lot of these platforms, to run efficiently, you need to make sure that you're not going to explode the number of resources going from maybe a monolith to a bunch of little services. You don't want to double the memory and CPU footprint when you do that. So you're going to have to think about how you shrink down those services and only have the code that you actually need. With that, I'm going to end the presentation, and hopefully there's a bunch of questions for us.
All right, Kelsey, let me bring up. There we are. There's the two of us. Thank you so much for joining us, and a lot of good insights there for folks that are getting into and building microservices, want to build an entire system architecture. And we particularly, oop, I lost your camera. You still there? Yeah, there we go. In particular, we have a question from Sumant asking, do we need containers for microservices? And we saw how you made that quick jump from write a little bit of code, put it in a container so that you get that assurance when you do deploy. Do you feel like containers are kind of central to our experience as a developer?
So I'm going to say no, and I have to have a little caveat here. The reason why I say no is, if you notice, when I was writing my Go and fiddling around with the C#, I focused on making sure everything worked in my local environment, and I didn't need to rely on containers to do anything. I don't want any of the container stuff leaking into my code base or any assumptions I make when I'm writing code. For me, when I do code reviews or I'm watching how the people on the team are developing things, that will be the immediate code smell that I give. It's like, hey, will this work outside of a particular implementation or deployment pattern? Now, why would you use Kubernetes or containers having said that? Well, the nice thing about containers is when you ask people to deploy your app, right? So let's think about a world without containers. And I've lived that world for a very long time. In that world, people need to know what's on the server. Maybe you have to put the runtime on the server first, depending if you're using dynamic linking. There's a lot that goes into prepping the target for the thing you want to run. If you look at some of the newer platforms like Kubernetes or Azure Container Instances or Azure Functions, a lot of the container-based platforms, the price of admission for ease of deployment, consistency, regardless of language you're writing, is you need to probably package it up in a container. And the analogy I like to use, if you're shipping packages, let's say you have a phone, maybe some batteries, whatever it is, if you walk into a FedEx, for example, with a bunch of loose items, the first thing they're going to do is they're going to tell you to put it in a box. Yeah. Mainly because the rest of their infrastructure, their cars or their trucks, their planes, and the carrier, they don't want to be dealing with loose items. They want them to be packaged in a consistent way. They don't really care what you put in there, but they need a consistent way to be able to promise you that it'll get to the other side on time. And that's the way I view containers. It's a hidden technology, ideally invisible, to make your life a little bit easier when adopting these other platforms.
And I like the comparison to packages. Right, it's a great packaging and distribution framework. We see NPM in the NuGet, in the .NET world. We use NuGet. Put your application in a package so that you do get that standard deployment.
And I like the fact that you brought up those package managers. And if you don't mind, I want to pull on that thread just a little bit. So those packages have gotten us a long way. Whether I'm on Red Hat, I can use RPM. You just mentioned a couple of other popular ones, and it seemed there was a period where every programming language had its own packaging format. And when you're switching between them, you would have to learn a whole set of tools. I still think they're super valuable, but the nice thing about this whole container image, it's language agnostic.
Yes.
You still use all of those package managers. So you still use the thing that packages your libraries, versions of them, making them easy to distribute and manage your dependencies. But when it's ready to package for that final deployment, that's where container images start to really, really shine as this universal application packaging format that doesn't try to supersede or duplicate what the individual language packaging tools are doing.
Yeah. Oh my gosh. Right. In the old Windows world, right? We have little install shield things so you can install and update all the things. Much easier to do with a container. And you also showed us a bit about how you really take logging to a next level when you get into containers, so that you can start to track and get a little bit more information coming out of there. I feel like that's really important for us when we do get into thinking in containers, not just microservices, but when you're thinking with containers, logging becomes much more important. Can you talk a little bit towards what steps you want to take once you have logs being emitted from your containers, so that you can actually do something with that? Right? We get logging output somewhere, don't we?
Yeah, so you hear this quite a bit with these modern platforms. So what makes these modern platforms different from the ones we're currently using? typically to get this consistency, to get this scale, to get this level of security, that means we tend to lock down the host. And when we lock down the host, we tend to take away the ability to just log into a machine and do all the things that you were doing before. And that presents some challenges. And this is why, whether you're talking about a monolith in a container, and it's doubly true when you start to think about splitting your app across multiple containers, you need way more visibility than you had before. And logging and metrics come to the rescue. So this is why, even in that 12 fractured apps post, I talk about the simple thing of, hey, my app has started and I've been able to reach all of my dependencies. Here's what they are. Here's what I'm using. Simple log statements like that are a godsend when it comes to trying to troubleshoot these things. So in the container world, a lot of those platforms, whether it's Kubernetes or it's Docker or it's Cloud Run, all of those particular platforms tend to assume that you can just spit your logs out on standard output or on the console for the people in the .NET or C# world. If you're just spitting things out to the console, then you have the ability to have the platform take those logs and centralize them for you.
Very cool. Yeah. Get that dashboard so you get the insight from above. There's another question here I want to bring up from Twitter. Let me put this up. Does it make sense to actively and aggressively use containers and Dockers in development, or are you saving it to only package at the end?
So I remember I was going to GitHub and I found a little tool I wanted to try. I was like, oh, sweet. Here's this tool. I'm going to download the binary and run it on my laptop. And the tool said, you can run this using Docker. I'm like, no. I actually don't have Docker installed on my laptop anymore. I don't want you to force me into a platform up front, right? If I want to deploy it in Docker, I would really appreciate it if you had a Docker file so I can build it myself. Without that, I'll like a Docker image and maybe I trust you. But for the most part, in the Go world especially, we like to just download the project and then call Go builds using our runtime of choice. So that's where it is. So when it comes to development, one thing I do agree with is using the container or the platform that you'll be using in production as early as possible. So if I'm going to run integration tests, I may choose to run those integration tests using the packaging format that production will be using. That way I can get all the integration there. So if you think about it in CI/CD as a developer, think about our workflow, right? We're typically doing things like linting, maybe we run some tests locally. And you know what? Maybe I call Docker build locally just to make sure that Docker file is still good.
Get that sanity check.
Get the sanity check. But then when I push the repo, I want my integration test that hit dev to be like, all right, we're going to build, test, and package. Yeah. And whatever ID I assign to that package, container in this case, we'll deploy to the target so we can run all of those integration tests. Maybe we're intermingling with some dependencies that have been deployed. If everything looks good, I can take that blob, that package, that container, and let that static artifact, unchangeable, this immutable thing, go up the stack. We never rebuild it again. And that's when I like to do that process. But I've seen people go the other way where they say, hey, everything I'm doing, I want to have Docker on my laptop. So every time I hit save in my IDE, I want to rebuild the container, deploy it to Docker and see if it works. I just don't know about that because I've been through too many transitions from like Vagrant and virtual machines to now Docker and this other thing that it's not about the deployment target that should be the validation if our code works. The runtime should be the thing. And then integration testing should surface as many issues as possible.
Yeah. So really, you're also speaking a little bit towards we can deploy that container to someplace that we can run our integration tests. But if it passes all of them, we can get into things like continuous deployment.
That's right. That's right.
And then deploy, let Kubernetes pick up, orchestrators do their thing at that point.
You brought up a good thing. Those things are what I call last mile technologies. A VM can run a container. Kubernetes can run a container. But I like to decouple that from my day-to-day workflow so I can focus on just writing code and, intermingling with the dependencies locally if I can.
It feels more like a DevOps type of responsibility when you do get to Kubernetes at that point in the stack. I've focused as a developer, like you're saying, and I'm happy with my process. Let the DevOps folks handle the coordination and the deployment at that point.
And sometimes you're both. I just think it's
Mm.
really great for the context switching method, right? Because a lot of times once you do get your, your Kubernetes templates all set up nice and neat, you get your Docker file nice and neat, you tend not to revisit those things unless there's major infrastructure changes. So you want that front loop to be super tight and super integrated to your current developer workflow. And sometimes that doesn't mean building a container every time.
Yeah. Oh, absolutely. There's a question here about the risks of not using a container orchestrator. Let me bring this up. This is a question from Gopal. It says, you mentioned at the start something simple like Azure container instances rather than Kubernetes. Can you elaborate a little on the risks of not using a container orchestrator like Swarm or Kubernetes?
So the question here is really like, why do I need Kubernetes? I need Kubernetes ideally to run my app on some compute. I need memory, I need CPU, and maybe I let Kubernetes be in charge of orchestrating how those things get consumed. So if someone said, hey, you have 100 virtual machines, how would you go about managing the resources on those machines? Well, in that case, it gets a little bit more obvious, like Docker Swarm, Nomad, or Kubernetes might be a better fit than me writing a lot of bash scripts. There are a lot of people with a lot of bash scripts. And
Yes.
you can go that route. I'm not saying it doesn't work because I wrote that for a very long time, but there's some nice things that you get from these orchestrators. They do things like if one of the machine dies, they reschedule your workload, aka container, on a different node. There's just so much you get out of the box between these tools that if I'm dealing with virtual machines and I need to have something map my application to resources so it runs, I'm going to pick something like Kubernetes. But if I already have an orchestrator built in to Cloud Run or Azure Container Instances, now we're in a slightly better situation. There is no machine. Here's my app. You run it. Ain't that a good place to be? So when someone can do that, right? Maybe not for every app in the world, but if I have an app that can run in an environment like that, why not? And in that
Sure.
case, you don't need an orchestrator.
You're speaking and you're hinting a bit towards serverless applications.
Yeah, I think so. The nice thing is serverless has multiple meanings. So for some
Yeah.
people, it's going to be a function that's event driven, and that's cool if that's your definition. When I think about serverless, and I think some people have made this point many times in the past, serverless is like the name implies taking the pain away. Servers, for a lot of people, if you've been on call before, like I have, represents
Same.
right. It represents
Yeah.
a bunch of pain you don't want to relive. So whenever there's a server, there might be pain.
Mm-hmm.
So if we take the pain away, serverless, we end up in a different world. So how would that world work? Number one, we won't be talking about or exposing any servers. In that case, if you have an app, and it doesn't matter if it's a container or not, but most of these serverless platforms are saying,
Right.
give me your app in this format and I'll run it for you.
Yeah. Right. And I think back to, gosh, you're reminding me here, times on call. When I was on call, we had our servers were physical hardware, right? We had two servers, and the application ran during the day for schools. And you know what? The time to update them was in the middle of the night, and you could take them down, but we were deploying. We didn't have a package, right? Being able to package and deploy and having that choice that we're seeing now when we choose containers, when we choose some of these deployment technologies and orchestration makes our choice around how we integrate, how we deploy a lot better. And there's something to be said about the orchestrator then, right, when it bleeds off the current flow onto one server and allocates another, where in
Yeah, I
the
think it's
cloud.
healthy for people to think about this like they think about the CLR, right? Like this thing knows how to run multiple programming languages because of the interfaces that it provides, right? The libraries it
Sure.
provides. So when I think about these orchestrators, they allow us to encapsulate the complexity between the languages and how they make syscalls. And they just give us much better contracts and interfaces between what we're doing, what we're writing, and how it's actually running. Most people write their code and let the runtime figure out how to allocate memory, garbage collect memory, get CPUs and all of that. So if you just zoom out a little bit, these orchestrators are like that for infrastructure, right? You don't make direct system calls typically. You typically don't write assembly, and you typically don't allocate your own memory in some of these runtimes. Think of it like that.
Okay. It makes a lot more sense when you think about I'm distributing what were all the pieces of my monolithic application. In fact, we have a question here that just came in over Twitter from this is ATX Dev Dude. Let me put this up so everybody can see. Kelsey, is the way to think of microservices as individual applications that run logic that would have previously been built as one giant app?
You can think of it that way. Like, again, I don't think there's a right way, but let me talk about some experiences I've had. I've managed teams who've written many languages. I've written many languages. And when you're approaching it from the first time, let's say you already have a monolith. So one thing I think a lot of people can reason about pretty easily is if I have one project, and let's say I need to be able to allow users to log in, and then once they're logged in, they can edit their user profile. And then once they're done with that, they can buy something. Well, if I have one project, I just start hacking away, exposing all three of those endpoints, and there you go. Everything's in one place. And for most people, that's fairly easy to deal with, right? I call this method, and this method gives me a response, and maybe I call this other method. That's pretty straightforward.
You could have done it in one file like you were showing us earlier with Go.
Exactly.
It could all be in one place.
It's good. Now, when people start to think about a microservice, maybe start to say something like, let me explain one of the microservices that no one considers a microservice because it's so obvious. DNS.
Yes.
Right? DNS is a service that runs over there, has a pretty clean interface. When you want to go look up some other host somewhere in the world, in the network, your libraries transparently call DNS and get a response, and then you keep doing what you're doing. And it makes sense to split out DNS servers because someone else can host them for you. You have a choice in the matter. That's one of the most common services that everyone has. So even in the monolithic world, if you squint real hard, if you're really looking to update that resume or add something to that LinkedIn profile, now you have permission to say you have experience with microservices because you're using DNS.
You're using DNS.
So let's carry that over to your own app. Let's say that login portion, you want to support different ways of logging in, maybe username, password, jot tokens, and now the team is hot and heavy on the authentication piece. And now you're starting to notice that you're touching the whole app just for this authentication work. And people are like, dude, why are we like deploying 25 times this week because of this authentication thing? So then you start to run into issues around conflicts. There's no deployment to get your change. There's a whole list of reasons. Code merge, and a lot of them are organizational. So one thing, and I like this approach, and I've done it in the past. Let's say we take the login service and we move it to its own standalone thing.
Okay.
Now the interface goes from methods, and maybe they can still be methods if you're using something like gRPC. There's talks on that later today. But it could be HTTP, whatever you want. Now this thing runs over here in isolation, and then what that team can do is maybe the first order of business, and this is the way I used to do it. Take the monolith, make a new name called off service. Here's the trick. It's still a monolith. And all I do is expose just the off components. Then in this other monolith over here, I say, hey, I'm going to add a little bit of client code to say either use your local library or talk over the wire to this other thing. And the truth is we don't tell anyone. It's also the same exact monolith. But we want to iterate it. You've duplicated it. Yeah. And then some people will start that way where you then strip away all the things you don't need and the only thing that's left is the off service. And now you can iterate a little bit faster and keep the contract the same. That's one of the benefits of doing this. So what I would say here is if you can find a way where you can split around either organizational lines or something that just makes a lot of sense like DNS, that's where it starts to get interesting to carve out. I'm going to say one more thing here.
Sure.
Typically, people land in microservices world when there's something new that comes up. For example, you want to integrate with Alexa or the Google Assistant. Now, you could go look at that monolith and say, look, we can just expose a new API that does all of the things we need to do to integrate with one of those voice applications. Or you create a brand new library, use the programming language that's the best fit to write code for Alexa or Google Assistant, and then call back into your existing monolith. And guess what? Now you have a second app, and people will understand why you have the second app. It made a lot of sense. And that's the pragmatic way of going about it.
And I think it's compelling that you would take a cross-cutting service like security, authentication, authorization, and move that out, because every element of your application is going to benefit from that. Whether it's at login time, checking that you're authorized to use a certain feature, all of those places that your application would have bogged down, that would have been touched, like you were saying, it now just becomes a ton easier because it's being handed off to somewhere else.
I'm going to grab a question if you don't mind. I see one that I want to answer.
Please.
What is Kelsey's point of view with microservices? It's in that third column at the top. What is his point of view on microservices helpers like Spring Cloud and Stilto?
Yeah,
I love this question because this is where I think things are actually going to go.
Okay.
I love what platforms are doing, like Kubernetes. They do a lot of stuff for you. But honestly, I think they can only meet you halfway. Let's think about application tracing, for example. Your load balancer gets a call from your client. And there's a header there that says, I'm making a request from an iPhone. And it hits the load balancer, and the load balancer is really smart, and it takes that trace header and it puts it into the thing that it passes to you, or maybe lets it pass through. And then along the way, it comes to you. Now, your job, and you really can't delegate this too much, but your job is to take that header, and if you're going to connect to a database and you want to have deep level tracing, you may take the header out of your HTTP request and put it into the tracing library that talks to your database, so that way your database can also add to the tracing, so you can see this end-to-end thing.
Yeah.
And doing that from scratch, and I've tried it in many languages, it sucks.
It's difficult.
It's difficult, hard to get consistency. So let's get back to the question. When you start to think about Spring Cloud, just like Kubernetes makes it easy to leverage a bunch of infrastructure patterns, well, the other half of the responsibility lies with the developer. Structured logging, metrics, tracing, et cetera, et cetera. Now, instead of you writing that from scratch, there are frameworks like Spring Cloud that say, you know what? I know how to create structured logs. I know how to send traces. I even know how to extract the traces from load balancers and proxies and aggregate them to client calls that you do below. And I think that's really a thing that lets you speed up. So this is where we start to get into libraries versus frameworks, right? So before Spring, I remember it was all about JBoss, WebLogic. Those things were fairly big. And they came with a high memory cost or maybe some additional complexity that you didn't need. And now seeing the same community, the Spring community, come up with Spring Cloud and Spring Boot, that just says, hey, let's take a library approach, import a line, and then you can just do all the things you need without a lot of boilerplate. So I love those things.
Yeah, and there's a number of vendors out there that are building tools to help with that type of tracing going on through your operations, and being able to attach and orchestrate all of the various interactions is kind of important to, like you're saying, get the entire flow, be able to visualize everything that's happening there.
Yep.
I think there's one more question we can bring up here. Hugo has a question here. What are your thoughts on using Dapper to run your microservice applications as an alternative to using Kubernetes?
This is a good question. I actually kicked the tires on Dapper the other day, and I'm not an expert, so if I'm getting a few things wrong, just make fun of me on Twitter or something. It's okay. I would say this. I haven't seen a situation where you can just use Dapper by itself with no VMs, no orchestrator to run the sidecars that Dapper does. So for those that don't understand Dapper like I do, the idea with Dapper is it feels similar to what you see with like serverless projects, where I can put a lot of logic in these sidecar adapters, like how to read a message off a message queue, how to grab an HTTP request. Maybe I can do all of that outside of my app and make my app super simple. So what you end up with is it feels like a blend between Spring Boot and JBoss, where you have a lot of logic that sits on the outside of you. And this is a really nice pattern, right? This adapter pattern or the sidecar, where we put a lot of logic there. And ideally, the trade-off is my app becomes much easier to write. But here's the thing, though. When you think about that, whether I pick Spring Boot, JBoss, or Dapper to do this kind of application server effect, I still need an orchestrator to map those things to resources so my app can actually run. So it's more of, my mind would be Dapper and Kubernetes. And I guess the last thing here as we wrap up is, here's where the sidecars fall apart. In some of the serverless platforms, you can't run a sidecar at all. So then you're not able to make that kind of trade-off. And this is where I think libraries become interesting again. So I can imagine in a world in Dapper where you have a proxy list, and I think you can probably do it, import Dapper as a library. Now you're in that Spring Boot territory, and now you have more flexibility in using even serverless platforms and getting all of those benefits.
Very cool. All right. You know what? There's a follow-up question here to that authentication discussion that we had just a second ago. Let me put this up here. Is it not a little bit of overhead to authenticate each request between microservices? Will it impact performance? How do you handle this?
Yeah, it's funny. I don't have time to show you the end-to-end demo, but this is something that I do have a lot of code around. So this is where I think JOT tokens, JWT, come into play, right? So there's various ways of caching, and authentication has been a problem everywhere, even in the cloud or LDAP or even Active Directory. This is why we have caches. So in the stateless world, JOT tokens, I think, play a major role in security. So I'm going to walk you through the flow really quickly. And this is still true today for most things, even though people say passwords are bad, they're still largely used in many cases. So let's walk through one flow, not the only flow. You have a separate service, that's the auth service. You are correct. If I had to have this service over here call the authentication service every time, or the client authenticate every time, it will be a nightmare. So what do we do instead? Well, we have the client log in once, and then we figure out who they are, and depending on what your security requirements are, we may give them back a token, like Active Directory does under the covers. You get a ticket or something. Yep. And once you have this thing in hand, you would say, look, I authenticate that this person is who they say they are with maybe a few attributes, and I give them back a token. Now, the other services in the stack, they should have a way of verifying that that token is legit and still valid. So what that does is now as a client, I may be required to attach that token in every request that I do. So guess what? On the client side, I'm not logging in a bunch of times. Maybe I'm caching that token. And as long as it's not expired, I'm going to make my request to the other services. And now the services can avoid the network altogether because they have maybe a private key where they can actually verify the signature of the token. And if it's something that I trust, then it's a bit safe for me to go and read what's in there. Say, oh, you are Kelsey with this email address because everything in that signed token came from an authentication service I trust. And then I can do things on your behalf and avoid the extra network hop.
Very cool. All right. That's all the time we have, Kelsey. Thank you so much for joining us here for .NET Conf. Really appreciate you joining us. And we're gonna take a quick break while we get ready for our next speaker. All righty. Take care, Kelsey.
Bye.
go.
Hey everybody, welcome back to .NET Conf Focus on Microservices. I'm Javier Lozano. I'm one of your co-hosts. Jeff Fritz is actually being our OBS DJ in the background, making all the cool transitions and everything going. We have David Dieroff coming up and talking to us about a journey into .NET Microservices with Steel Toe. How's it going, David?
It's going great, man. How are you?
I'm doing great. Take it away. It's the
Cool.
conference yours.
Thanks. .NETers, what's up? What's happening? I can't tell you how pumped I am about being here, talking about things. Kelsey's talk was awesome. And to tell you the truth, I just want to extend everything that he said in my point of view. We're going to go on a little journey here for a few minutes. We're going to talk about microservices, right? That's where I'm all here. But we're going to talk about Steel Toe as well, and why Steel Toe is going to make your life with microservices unbelievably easy. To do that, we got to agree on a few things, though, as we go along here, right? Your microservices are going to the cloud. And I think I've just offended Kelsey by my first slide by saying all this, having watched his points of view. But you're going to the cloud at some point, right? Maybe private cloud, maybe public cloud, whatever. Well, along the way, there's going to be a short list of things that every single microservice is going to have to do. Things like logs. Every microservice has got a log. You've watched these other talks this morning. Everybody's talking about it. But IIS logs, event store, to local disk ain't going to work for this. Now we're talking about streaming logs. That's the fancy way of saying it. You're writing to console, right? And then your platform that you're running on, whether that's Azure App Services, Cloud Foundry, any public cloud, Kubernetes, what have you, Docker, that platform is going to grab those logs and forward them onto an aggregator. Metrics. You may not be doing anything right now. You may be doing IIS or something like that. Again, ain't going to work when you go up there. Now we want something like a simple endpoint that presents the metrics about your application on some interval, and you let something scrape that endpoint and check things out. Health. This is absolutely number one. I mean, for me, probably above logs, right? Your application has to report its health to its platform. But health is not just, hey, I'm here, good, 200, right? Health is, my database is here, my dependent services are available, right? Health is a pretty involved check for making sure. Your response back ultimately is one single response as a 200. That's how you report health. And then your environment and instance info, right? You may be using IIS, you may just be manually writing everything in, I don't know, web.config or something like that. But you're going to the cloud, which means you're going to need tools around you because you're not going to have near the visibility of your application as if it's running on some VM that you can RDP into or something like that. A lot of this is going to go away for you, so you got to adapt. And so you need to know what environment am I going in? What environment variables have been exposed to my application? What version of my application am I running at right now? How many instances am I running? Got to know these things. Oh, and then there's backing services, right? This one gets even more fun because first you have to deal with the connection to your backing service, right? That's the first thing. That's maybe the easy part, as Kelsey was showing, right? Either connect or I don't, and I fail out. That ain't going to work. You need to be highly available. Really, your services ideally would be highly available, right? Your application's running multiple instances. That's good. It's sessionless. That's good. But you have multiple instances maybe of your backing service, which now kind of complicates things for how your application decides to connect to that backing service. What happens when that service or your app moves to a different zone or a different data center, right? If you're doing disaster recovery and things like that, what's going to happen there? Is it just like, well, I got to flip the switch off, move everything over, flip the switch back on? And we all know that ain't going to work. And then a resilience to change, right? And so this, if you want to be super cool, you're going to use circuit breakers for this. But circuit breakers are not easy to implement. I will be the first to be honest about that. But that's what you're thinking about is I'm going to write my code assuming that this service isn't going to be there, but my app will be. What do I do? How do I design that? So that's the basics, right? We can continue on. If you want to become a rock star, you ain't going to be a rock star overnight, right? But as you go along here, you're going to get better and better at this. More microservices, learning how to deploy, learning about pipelines and automation, and just putting all the pieces together, getting the most out of it. So when you become a rock star, at least in my opinion, you're doing things like external configuration. My application, appsettings.json, really only holds like 1 or 2 values, and basically they're to how to get my application to an external config server to retrieve all the good stuff out of there, connection strings, business values, what have you, out of there. Circuit breakers, we kind of touched on that. Authentication, maybe even some authorization in there, building all that in. Discovering services, right? I don't remember all of the URIs of all the different services that I'm supposed to connect to. And by the way, those URIs are probably going to change. What am I going to do about that? I use service discovery as a phone book. So all I look up is the name of the service. And then the phone book gives me the actual URI back. And then I go connect to it. And then if you're going to be the uber cool kid on the block, you're going to go to message buses, right? And then you're going to say, all I'm doing is, instead of calling another microservice, I'm going to write to a message bus, and somebody else is subscribed to the same topic that I wrote to, and they're going to get the message off of there. And you get into events and all this super cool stuff. That's why you're a cloud native rockstar. Yeah, okay. All that is a lot of code, right? I mean, consider this. External configuration, circuit breakers, authentication. Let's go back one more. Connection to my database, being highly available, resilient to change. As Kelsey was saying, this is all stuff that you should not be dealing with. This is all code. You haven't written any business logic. You haven't done anything for your actual job yet. You've just written all this stuff to manage all this. Meet Steel Toe. Steel Toe is here to help you with this stuff. Steel Toe is here to take all this kind of cloud expectation, these boilerplate things, take them off your shoulders, take that debt away from you. And I'm going to use Steel Toe components to do this. And it takes it down to attributes and one-liners, right? Very, very simple things. That's how you implement it with one-liner. Put some configuration in your app settings or go with the defaults, right? Steel Toe knows how to talk cloud. It was created in 2015. It's been around for a while. That's all I'm wanting to say, because I keep running into open source projects that have been around for a week or two. It's open source 100%. The .NET Foundation owns it. It was donated in 2017 to the foundation. It has no real, commercial purpose or anything like that. This is for the community. This is for writing better .NET microservices. We know what a microservice is supposed to look like, so we can do some purpose-built features in both framework and core. Steel Toe got its start before core was even a thing, or at least publicly was really a thing. So Steel Toe is here to help you with your microservices. This is a common one for me. No, we're not trying to replace .NET. .NET is flippin' awesome. The .NET runtime, specifically ASP.NET, is freaking awesome. As Kelsey learned, .NET New Web API. How awesome is that? No, we're not trying to replace it. It's just the .NET runtime has to be a lot to a lot of people. And so they have to account for a lot of different scenarios, console apps, ASP.NET, other things. Maui's coming out, and Blazor's there to help out with all these things going on. So specifically, you can put a lot of opinion. If I'm only going to microservices and I'm only going to run a cloud platform, so I'm probably going to be containerized, once I get up to the platform, we know a lot about what's going on. And so Steel Toe's here to say, you know what, I'm going to extend all the goodness of .NET and put a whole bunch of opinion around that, because I know exactly how you should be running in the cloud. And let's take away all that overhead that you might have to take on going to microservices. Code for the business, not the platform. if I can tell you one thing today, if you're just getting into microservices, if you've kind of dipped your toes in microservices, and now you're really getting into it, you're in the middle of writing a project, if you're spending a lot of time writing code to manage your infrastructure, so that's like, I'm not talking about entity framework stuff, right? Your data schema is specific to your application. I'm talking about managing your database connection, a connection to a message server, a cache server, those kinds of things. If you're spending a bunch of time writing all that code, in my opinion, you're doing it wrong. You need some helpers around you. You need some things added in to help you. You need to be writing code for the business. That's the only way the business is going to grow. And I bet you anything that's the only way you're going to be happy is by writing some logic, really creating the real applications. Okay, I'm going to take a break for a minute. That was a lot. And we're going to switch over to the mandatory Visual Studio. This is a .NET Conf, by the way. All I want to do here, I'm not going to get super in depth. All I want to do is kind of show you the beginnings of what a steel toe application might look like and why steel toe, I'm just so emphatic about it. Just to show you that I'm not holding anything under my sleeves or have any black box, going anywhere, rigging anything up. I'm going to do this straight up as a new application, right? Can't hide much here. We're going to create that. Because I don't want to be asked about a self-signed certificate, so I'm going to turn off HTTPS. Okay, here we go. Straight up application. Don't really need to get too far into that. First thing, we're going to go to NuGet, and we're going to look for steel toe. We need to browse. Okay. So I'm going to bring in, there's a lot of packages. Go to steeltoe.io. You're going to see a lot. There's a heck of a lot of components that the team has made. I'm going to bring in what I consider kind of the bare minimum here. I need a health check. I don't want to build that. I need to emit some amount of information about my application. I don't want to build that. I need to stream logs. I want to also get into distributed tracing. So whenever I write a log message, I want the span ID and the trace ID on that message because I need some context here about what's going on. Remember, when you moved up to a container, when you go to the cloud, you have very little visibility. So your debugging skills are going to have to adapt and learn new ways of doing things. So let's go for, we're going to go for endpoint core. First, I'm going to cheat and copy and paste here. So we'll bring endpoint core package in. We're going to bring, yes, we need to do that. We're going to bring the dynamic logger package in. Again, if you don't know what this stuff is, it's all good. Steeltoe.io is going to teach you, show you everything about what's going on. And there's documentation to your heart's content over there. And we're going to bring in tracing core as well. All right, I brought in those three packages, pretty basic stuff. I'm going to go in program CS. All right, and if by some miracle, Kelsey's watching right now, I hope this is going to put a smile on his face because all we're going to do is put in 3 one-liners. That's it. I now have a health actuator endpoint, an info endpoint, and I've put in streaming logs using the console. And I have some pretty structured way of doing logging now. That's it. That's the idea here with Steel Toe. Give the developer a very quick, simple way to get something done so they can get past the boilerplate stuff. If I wanted to go beyond this and I wanted to start filling this stuff up with, all kinds of rules and, all kinds of different authorizations and everything, I can. There's configuration to no end, and you're going to stick it in app settings and everything's going to be good. But I'm going basic here because I just want to stick to to what we're doing. We're running locally anyway. Then over here, I want to add distributed tracing. Done. Let's pull in the package. Okay. This now will create spans and traces it will use a project called OpenTelemetry, and all the opinions of OpenTelemetry have been brought into Steel Toe. That's an active thing. It will take the opinions of OpenTelemetry and its distributed tracing about creating spans and traces and such, and it will use that. It will watch everything coming in and out of the application, and it will use that for logging. It will also begin to do everything in a compliant way for other systems to watch those spans and traces and take them and do other things. So like Zipkin, right? Zipkin's a very popular way to do tracing. And it's really, it's not a protocol, but it's more of a way to structure your spans and traces and make them available to others. Anyway, Steel Toe is going to take care of all that for you. That's what I'm getting at here. You've got the Zipkin compatibility and you didn't even do anything for it. All right, let's F5 that bad boy. And we're going to see our weather forecast app came up. Good job. Let's see, did we write logs? We did not. Let's go back and write a log. Let's just make sure our application's running. I'm going to circle back around and we're going to show you some of the good stuff, but I want to bring this in as well. So let's bring logger. Let's do a debug and let's be super nice. Okay. So we'll bring up our weather forecast again. We're going to come back and look at our logs once more. Everything is looking pretty good. All right, so now I'm going to come over here. Oh, we need to get our, yes. In just a minute, I'm going to make a very sweet plug for Project Ty, and I'm feeling the pain right now because I have to go grab port numbers and things like that. So, all right, haven't turned that one on yet. Oh, and I have a bunch of people watching me, so I have to type everything. Okay, now wait, before we look at this, /actuator/health, okay? Let's go back over here real quick. Bear with me for a minute. Do you see a controller anywhere that is called actuator? Health uses that? Let's go in startup. Let me keep myself honest here. No, you see nothing in here for this because you shouldn't spend any time with that kind of stuff. But Steel Toe added that in. And Steel Toe also knows quite a bit about your application, like how much disk is running for right now. That's just an initial one. You can add all kinds of other fun, crazy stuff on here for health, but this one they know about. They're reporting a readiness state. They're reporting a status. They're reporting these different ways of doing this because they're compliant with different platforms. Cloud Foundry, I believe, is looking for a status of up. Kubernetes is looking for a liveliness probe. So it's doing that. All you did was add Steel Toe in. You didn't really choose a platform or anything like that. But they know how to add liveliness things and health check things for the different platforms that you have. We turned on info, didn't we? Look at all this. Again, I never added that endpoint into the application, right? But it dumped out, it knows a lot about what's going on. Now I have a way to query the application and learn about what version am I running right now for this individual instance. What version is going on? What version of Steel Toe packages and things like that am I running? And some other odds and ends in there. That's good. Let's go back and hit the weather forecast again. And we're going to come back in here and have a look at what's going on. my context didn't get bound to it. So we're going to switch that off. And let's change this to information. And we'll run our get again. There we are, nothing too crazy going on there. We'll come over to our application. Cool. So I'm sorry, I can't zoom in here, but I can zoom in here because I want you to see what information was dumped out. All right, there's my hi there log, right? That's what I did. That's what I wrote. But steel toe added on there. It came from this application with this span ID and this trace ID, and this is administrative. I can take this, right? And if I'm using some distributed tracing platform, I can now take this and go over and look it up. And like Kelsey was saying, I've got databases behind this. I've got other services behind this, and I need to see the whole trace because I need to see who's the bottleneck and what's going on and the headers between that are getting exchanged between these different requests down the chain. I now have the ID to do that. Now, of course, you'd love to have a platform, a distributed tracing platform already plugged into your platform, so you can just go right over, query on the application name, and so on and so forth. But what I'm getting at here is such little overhead, bringing steel toe into your application. Okay, that's it. I'm going to spare you anything else for hands-on. Last thing I'm going to show you, though, this is already pre-written, pre-baked. This application was based on doing a file new web API. I swear there's nothing up my sleeves. I rolled them up just in case. But so you can do like one-liners, all actuators. So that's going to give me a list of a whole bunch of different information about my application. You can add in, like here I have my database context in here. Went a little bit further to add in some more Zipkin stuff with distributed tracing. Added in a hook for a Spring Boot admin server. The endpoint's about the same. Aha! Now I wanted to add a little bit of configuration because I'm using a SQL Server. I'm using it completely software defined, right? I'm using Entity Framework. I have no actual SQL Server. So wherever I'm going to connect to this thing, the database has got to be created. Something's got to be done. My endpoints, so you can actually choose what endpoints are exposed publicly outside your microservice and what's only available on the network of your microservice. And then this is for my Spring Boot admin server. It needs to know how to talk to it, where to come back to, the callback for it, and that sort of thing. So I give it all kinds of configure information. This application needs a SQL Server. It needs a Spring Boot admin. It needs a Zipkin server going. Right? It needs all of these things, these services around it. And so when I'm going to develop this locally, and I'm sorry, Kelsey, but I want to spin all this stuff up locally. I'm going to use Docker for it. But I'm going to use Thai. And Thai just complements a steel toe app so well because this is the reality, right? You're going to be connecting to all these services. So I want to try to recreate these things locally. Kelsey's right, though. You're never going to get to the point of production, right, where you just totally recreate production. I get that. But it's pretty darn easy for me to do this if you've got Docker installed. That's a whole other topic. But see what I'm doing here? I'm bringing in Zipkin. I'm bringing in MS SQL. I got to set up my SQL database, set it on the port, the EULA, the SA password, and then I'm spinning up boot admin and turning off security for it. That's all I do. Now, notice this. I have the choice with Thai to either spin up my application right here in another container. And I would want to do that because I need it on the same network as these guys. Because over here, all I said was web application 1. Well, who knows where to route that? Well, in fact, if I'm on the same network in Docker, then it knows how to do that. It'll be my DNS for it. So I need my application there. But I enjoy being able to run my application right out of Visual Studio and then let Thai spin up all this other stuff around it, manage all the ports and do all that stuff. Okay, that's it for my demo. We're going to head back over to the slides now. Hopefully I have either enraged a bunch of you or you have some good questions. Either way, I look forward to it. So my final is the shameless plug. Of course, I got to do it. Steeltoe.io, learn more, right? Steeltoe, man, I just barely touched the surface there. That was just the beginning of it. You've got service discovery, external configuration. You've got service connectors to databases and caches. They've built so much of this project out, these libraries out to help you get away from the boilerplate code and start writing business logic. Thank you. Javier, you're on mute.
Thank you. Sorry about that. I was like trying to do like 9 different things to get stuff
You
going
had a
over
whole
here.
thing going there. We missed it.
That's right. Yeah. No, I wanted to share. We actually have one question come up, and is from Beast Unicorn, or Unicorn Beast, which way you want to read it. It seems to me that we will be depending on Steeltoe. How much is this thing extensible? Right, like whenever you have a framework, right? And it's great that you had the 3 lines to be able to add telemetry and vlogging and everything else. But how can I plug in? Is it a provider model, or how does that work?
So that is a great point, right? Because there are realities here, right? This is all give and take as a developer and how I'm choosing to design my thing. You're bringing Steeltoe in, and you're going to be dependent on the Steeltoe libraries. There's not like a Steeltoe instance running out there that's going to bring my application down. It ain't anything like that. It's still your app, completely your app. This is just a library that you brought into it that can help you connect to things. But it's very much up to you. All the components within Steeltoe, the developers try to expose as much configuration as humanly possible, but inevitably, there's going to be some edge situation that may not be right for you. So here's what I offer to you. Your options are to write a resilient managed connection to a message queue, or put a 2-liner in from Steeltoe and configure the bejesus out of it for what you want to do, right? Which one's going to save you time here? Which one's going to get you coding and get you your microservice onto production faster, right? Steeltoe, I would love to see it in every single .NET microservice out there, but I realize that it's not for everybody. And there is give and takes as far as what kind of dependencies I'm willing to take on to make my life easier versus I need to make my app uber portable and I'm not going to take on 0 dependencies. I'm going to write it all myself. So I still can't hear you, Javier, but you're not on mute. So you've done something else. Nope, still can't hear you.
How about now?
Maybe I'll just, oh, there you go.
Hey, there we go. All right.
Talking about Steeltoe.
Yeah, I was going to say, well, the thing about it is, like, obviously you have to find a balance between what you're trying to accomplish and what you can do, right? To deliver the value for your customers. So this is really great. And obviously, Steeltoe, like you said, is part of the .NET Foundation. So it's open source, so it's available. So in case you want to know how it all works, there's the source code's available for you to look at it, right?
100%.
Perfect. Great. Well, David, I want to thank you so much for taking the time to speak with us at .NET Conf. We are getting Ruben Bond to talk about how we use Orleans at Microsoft. So, David.
Thanks, everybody. Thanks for your time.
Thank you. We'll talk to you guys in a bit.
you're live.
Hey everybody, again, welcome back to .NET Conf Focus on Microservices. I'm Javier Lozano. I'm your host for the next couple of speakers. I have Ruben Bond from Microsoft to talk to us about Orleans at Microsoft. How's it going, Ruben?
Good, thanks. How's it
Great.
going?
Great. Take it away. Well, I'm dying to learn about how Orleans is being used.
Good, thanks.
Awesome, thank you.
All right, well, let's get into it. Hi, folks. I'm Ruben Bond. I'm a principal engineer on the Orleans team at Microsoft. You can see my Twitter handle down there, @RubenBond. And I want to talk to you all about Orleans, and in particular, how we're using it to build production services at Microsoft. So we won't cover too much detail about Orleans itself as a framework, but I want to give you a very brief overview for the folks who are not really familiar with it yet, or people who want a refresher. So Orleans is a framework for building distributed applications, and in particular for building scalable, fault-tolerant applications that are composed of distributed objects that we call grains. And by building your applications using these grains, you can run your code on a single server or on a large cluster of machines without needing to change your code. And Orleans helps with a lot of the heavy lifting. So things like forming into a cluster, distributing load across the cluster, letting these grains communicate, and recovering from host failures. And that might be things like when you're scaling out or scaling in, doing rolling upgrades, or even just traditional host failures when a machine goes down. Now, Orleans really shines when it comes to writing stateful services. So that can be tricky to get right otherwise, especially in a cloud environment where those machines are coming and going frequently. The final thing is, Orleans is battle tested. We've been running it in production for 8 years now. I mentioned grains. Grains are the building block of any Orleans application, just like how a control is a building block of an MVC app. And grains are brought into memory when they're needed, and they're removed when they're not in use anymore. If a host in the cluster fails, Orleans will detect that, and any grains that were on that failed host, well, they'll be reactivated somewhere else the next time that they're needed. So as a programmer, you don't need to worry about where a grain is activated in your cluster, or if it's activated at all, or if you've ever even called it at all. You simply make calls to your grains and Orleans will figure out the rest. That's the beauty of it in a nutshell. Now, conceptually, a grain is a distributed object composed of these three things: the identity, behavior, and state. The identity is this type plus a user-defined key. So you see the type there is user, and the key is a string Ruben. Now, the behavior is a .NET class and a communication interface. We have user and iUser here. The state can be in-memory state. That might just be properties on your class, or it could be persisted state that gets injected into the constructor of the grain. And we'll see that on the next slide. So this is the only code-heavy slide in the presentation, and that was really kind of conceptual and way before. But to look at how it looks concretely, here's a grain that we've defined. So we've got iUser, this communication interface up top, and you can see that it has two methods there: send message and get messages. Now, I want you to notice that they're both returning task. And the reason for that is that, well, these are distributed objects. So they could be, when you're making a call to one of these things, it could be on a totally different machine to where you're calling it from. And so because that might involve I/O, these things are naturally asynchronous. Now below that, you've got user, this user grain, which implements that interface. So see how the constructor has this parameter that gets injected, and that contains a state. In the top right there, you can see how we get a grain reference and how we pass in the user, iUser type, and also Ruben, that's the name of this grain. And then below that, how we call them. So we do this asynchronous RPC approach. So you wait a call to this grain by reference, and you can also get results back from that. So one more thing that I want you to notice there, look at that send message method down there. It's a simple kind of implementation. We're just adding a message into a list and then writing some state. But notice how we don't have a lock around that. There's no concurrency control here. And that type that we're adding that message to, that's just a list of messages. So it's not thread safe by itself. And the thing to note there is that Orleans, by default, is going to make sure that only one call is executed at a time for a given grain. So for the Reuben grain, for example, it's only going to execute, say, send message, or it's going to execute get messages. It's never going to interleave these things over each other. And that means you don't have to write potentially buggy concurrency safe code because it's safe automatically. And so you avoid a lot of concurrency issues by doing that. Another thing to notice here, we have write state async. But if you look, there's no read state async. There's no load state async anywhere. And the reason for that is that these things are stateful objects. So we can load state once before the grain user code ever gets executed, and we keep that state around in memory all the time while the grain is active. And so you can serve requests straight out of that in-memory kind of cached state. And you only need to hit the database when you're writing the changes back to the database, right? So the nice thing there is you improve latency. You don't have to hit the database on every request, so you skip that bit. And you also reduce load on the database. So it's not much nicer there. All right, one last thing about the framework. I just wanted to highlight a few of the things here. Now you saw that nice and simple, maybe even simplistic kind of persistence on the previous slide. And we were dealing with .NET objects and we had this write state method, very abstracted away from the database. Now that doesn't work for everyone. So a lot of teams around Microsoft, for example, they're just going to write directly to the database. They might interact with SQL or with, say, storage or Cosmos, and they can do that directly. There's a couple reasons why they might want to do that. One of them is that they might want to have a lot of control over the shape of the data. So they want to be precise about how it's stored. Another reason could be that they want to take more advantage of the particular database's features. Let's say you want to use queries or indexes or other kinds of things that the database provides. And so that persistence model you saw, that's fully opt-in. Other teams around Microsoft achieve a similar kind of effect by using custom plugins. So they'll have a custom, let's say, Azure Storage plugin, and then they can choose exactly how their grain state gets stored in Azure Storage. The next thing I want to mention is distributed transactions. And this is a cool, very kind of unique feature in Orleans. You can actually inject transactional state into your grain. So imagine you want to build a bank and you want to have, say, 2 bank account grains and transfer some cash between them. So you might have a method, let's call it transfer, and transfer can call into one grain, deduct some funds, and then call into another grain and increment some funds. And you can make this all transactional so that even though those grains have their state stored in totally separate places, and they can actually even be separate databases altogether, Orleans can guarantee that this happens in a transactional manner, and you get strong isolation on that as well. And that's a pretty crazy kind of a feature, I think. So transactions can really simplify life for a lot of these kinds of applications. Like a bank account is probably the classic example of that, but there's other cases as well. And it helps you to avoid a lot of the kind of pitfalls that you'll get when trying to build big systems that need these sorts of features. Next is virtual streams. So you saw on the previous slide again that we were making method calls, asynchronous method calls, and that's the RPC paradigm. A lot of the time though, a developer is going to want to decouple both sides of communication. And they also might want to decouple things temporally, like decouple them in time. So let's say I want to issue a request, and then I want to be sure that that does get processed, but I don't really mind if it happens a little bit later. And so Orleans has streams for this. And streams in Orleans are a pluggable abstraction. A lot of teams around Microsoft end up using Azure Event Hubs, which is a great choice because it scales well and is very reliable. But you can also use things like SQS, GCP, or even in memory if you want to do things like testing, or just fire and forget things that are not really that important. And these streams, they can have declarative bindings. So you can say that either you want to explicitly subscribe to a stream from a grain, or you can say, all right, well, I have a grain and I want these grains to subscribe to any stream with the namespace X. Or you might say, I want to subscribe grains to any stream where the namespace matches some predicate, like or regex or something like that. So it can actually run some code to decide whether or not it subscribes to that. So it's a very powerful kind of a thing. The next thing I want to talk about is deployment freedom. Now within Microsoft, we have teams running Orleans on Kubernetes, on Service Fabric, on Windows, on Linux, on Azure cloud platforms, the classic cloud services. So it's very unopinionated about where it runs. runs pretty much anywhere the .NET can run. And outside the company, we see people running on AWS and GCP as well, and even on bare metal, on-prem or in the cloud on co-located machines. So it's very flexible. All right, so enough about the framework. How do we actually use it at Microsoft? Well, here are some of the products or services or even parts of the company that are using Orleans in some capacity. And we'll talk about a handful of them today. So we've seen services built on Orleans that are ranging from a single host all the way up to tens of thousands of calls. But a typical kind of a cluster size might be 5 to 40 nodes. And you obviously don't get too much resiliency from running on a single node because if it goes, well, it's gone. Now, there's a broad set of applications here. Some of them are in gaming, some of them are more geared towards the enterprise, and you see Azure Quantum and Azure Machine Learning down there that are more science-oriented. Some of these are very large, and Orleans is used somewhere in all of them. And within these services, we see different use cases like workflows, graph processing, analytics, stream processing, transactional workloads, and resource scheduling, just to name a few. The one thing that's common to all these use cases, or all these cases, is that state is naturally partitionable. So it maps very nicely to grains, and it can be more easily distributed across a cluster of machines. So for example, in the IoT case, you might have devices, or you might have users, sessions, purchase orders, workflow jobs. Those kinds of things are really readily distributable. And when designing grains, you need to think about the granularity you're working with. If you have a single grain that's involved with 50% of all of the requests, well, you're going to hit a wall when it comes to scalability. And conversely, if you have a request that needs to fan out to say 50 grains in order to get back an answer, that's going to add additional latency and it's going to limit your throughput. So that granularity is important. Now, to get a little more concrete, imagine you're building a chatter. Would you have a grain for every chat message? I would say no, probably not. But you might have a grain for a conversation between users and cache only the messages that you need in memory. That scales much better, and it's much better latency as well. Now, game studios use Azure PlayFab for building and operating their games. Many studios within Microsoft and outside rely on it for some massive titles. And PlayFab is much more than what I'm showing on this slide, but I want to mention these three cases using Orleans. And in the interest of time, we're going to talk about the first two in a little more detail. So let's dive into PlayFab's multiplayer server hosting. Now, PlayFab runs game servers for studios, and these servers are spread across the world to ensure that gamers get good pings. And up above all of these servers, is a control plane that orchestrates everything. And that control plane is built on Orleans. Now, the model that game developers see is that they have a tenant, let's say it's 343, and then they have a game, let's say it's Halo, and then a deployment, which is a specific configuration of that game that they want to run. And so then they'll configure multiplayer services to keep a pool of these servers running at any time so that players can join without having to wait too long for a server to spin up, for example. And the control plane's job is to make sure that there's always a sufficient number of VMs that are in a healthy, ready state with that game server loaded at any point in time. And as a matter of scale, we tend to see hundreds of thousands of VM cores running in PlayFab multiplayer servers at any point. So the control plane has grains that represent things like tenants and titles, deployments, VM pools, VM allocators, monitors, and even individual VMs. And VMs will send the status heartbeats up to the control plane, so the control plane can keep status updated locally and make decisions on it, and then it'll eventually pull VMs out of a pool to allocate them to a given game session. Now, Orleans clusters are very resilient, and they'll detect failed nodes automatically and recover from those failures. The gamers really dislike outages, so there are multiple control plane clusters hosted in different regions to ensure that if one region has a blip, then another one can take over. And clients calling into the control plane, well, they use HTTPS. And the control plane co-hosts the HTTP server within the same process as the Orleans silo, the Orleans server, and we do this using the .NET generic host feature. Now, by co-hosting the HTTP front end with Orleans, the front end can directly call local grains without needing to make network calls or do serialization round trips. But when it does need to cross the network boundary, by co-hosting them, it has access to knowledge of the current state of the cluster, so it can avoid going through additional gateways and instead call directly to the place that it needs, avoiding network hops and significantly improving performance as well as resiliency. So that was a recent change to the multiplayer server's control plane. Now, the HTTP server used to be separate from the Orleans server, and they changed to merge them together into one process and gain that performance. That didn't require changing the application code. It only required changing the hosting code. So when we set it up and we have this generic host, instead of just adding the HTTP server, we also add an Orleans silo in there. And by doing that, without changing the application code, we can merge these two things together and we get that performance optimization. And just as easily, you could separate those two things apart. So there's a nice amount of flexibility there. PlayFab's economy service allows game developers to process payments, manage virtual currencies, sell items, and guard against fraud. And so they have grains that represent accounts. And within those wallets, they have multiple currencies. So you can think of a currency as either an in-game item or something that's more traditional sort of a currency, like, for example, rubies in Minecraft Earth. And when dealing with real money, you often want to use transactions to make sure that you can avoid exploits and you can prevent unhappy players, because if players are paying for something and they don't receive it, well, that causes agony. And the economy service uses Orleans distributed asset transactions for that. It's very similar to the bank account example, but they have a custom storage provider and it's built on Cosmos DB, and they use a currency per document in there. And they do that because it allows them to only modify the documents they need to modify when they need to modify them. They also have custom participant in the transaction, so they can monitor these transactions and output the lifecycle messages like commit, abort, and prepare, for example, into an Azure Event Hubs, and they do that in order to form an audit log. All right, so Halo is probably the most well-known application using Orleans, and multiple Halo titles have relied on Orleans-based services for a while. Multiple Gears of War or Gears titles are also running on Orleans, or at least their services are running on Orleans. And for the Halo case, they built services for tracking players in near real time, performing detailed analytics on the game matches, and also doing things like cheat detection, like detecting modified consoles or detecting griefers in the game. And they also have content management servers. And for the analytics part, they're using Orleans streamed on event hubs so they can reliably incorporate what happens in each match into a player's profile. And for Gears, the Coalition up in Vancouver, they also use Grains to create a lobby service. And other studios outside of Microsoft are also building lobby services on top of Orleans. You can see more details about the Halo case in some of Katie McCaffrey's talks, and I can link you to them. All right, we talked about a bunch of cases in Microsoft that are built around gaming, and those use cases, they can be applied elsewhere as well. But we want to talk about other cases around Microsoft. So for example, Azure IoT has built their digital twins offering on Orleans. And IoT is a good use case for Orleans because the Internet of Things, well, each of those things can be mapped very nicely into a grain. And so IoT digital twins allows users to create these graphs of their digital twins, these IoT devices. And instead of having a big soup of devices, they can create relations between these things. And so they create bidirectional links between the grains. And for reliability, they use reminders. And reminders in Orleans are a kind of a durable timer. They're like cron jobs, but they're scoped to a grain. So they will, for example, set a reminder, and that reminder will ensure that even if a machine suddenly fails partway through this, it's okay because the reminder will fire again very soon. And then that process of creating this bidirectional link can complete in a reliable fashion. Now, Dynamics 365 fraud protection, it helps businesses to detect fraud in things like e-commerce or account usages or in bots. A good example of this would be the e-commerce case, where you've got users and the users are doing things like making purchases, and those purchases will have, for example, payment information, shipping addresses, billing addresses, the IP address that the user used. And so they can run some analytics on these things and detect fraud in real time as it's happening on these grains. Other companies have also used Orleans for identity-based or user identity-based applications to great success. And Gigia is one example that was acquired by SAP. One thing that's interesting about the Dynamics case is they've actually got geo-distributed clusters. So they've got clusters in multiple locations around the world, and they've used some custom Orleans modifications to allow them to have certain types of grains be roaming between those clusters. So they're always accessible from anywhere. They'll exist at most once in any of these clusters around the world. So you can do some really interesting things there. Now, the final case I want to talk about is Azure ML and Azure Quantum. So these things, in the interest of time, we'll keep them together. They're different, but they have a lot of similarities as well. And Azure ML runs a broad range of different services on Orleans. So this is just a selection of what they do. But as a whole, as a product, they allow you to design and train and then serve up models. Now, Azure Quantum allows users to submit quantum computing jobs, and then they get run on special hardware like simulators and things, so that you can run quantum computing experiments. In both cases, though, you have some special hardware and you want to maximize the use of it. So they build job scheduling systems on Orleans. And again, they're using those reminders to make sure that these things end up being nice and reliable. All right, that's all I wanted to show you today. So .NET, Orleans is built under the .NET Foundation. We build it openly on GitHub, so improvements and features are coming often. We have a warm and welcoming community up there on GitHub and in the Gitter channel, but we also try to be very open and approachable. So please feel free to contact us directly if you'd like. Thank you.
All right. Let me get the questions up and going. Oh, shared the wrong thing. Too many windows. So you can see that. So, all right. So one here for you, Ruben, is how is Orleans different than Service Fabric? I'm sure you guys get that question a lot.
Yeah. So Service Fabric and Orleans are actually quite different things. You saw that I mentioned that Orleans inside of Microsoft is often being run on Service Fabric. And for example, that multiplayer service case, they're running Orleans on top of Service Fabric. So Service Fabric is a few things, one of them being a hosting platform that will manage application rollouts and keep things reliable in terms of running your service. And there's also an actor model inspired by Orleans that's built on top of that. So they have that actor component that's also running on there that's sort of tied to Service Fabric.
Perfect.
Hopefully that explains it.
Great. I was going to say we have another question from @UnicornBeast that asks, if a silo goes down, how can I ensure the data from the grains? I'm sure, like, how is the data not lost, right, as if something were to happen?
Yeah, that's a good question. So you will configure storage providers, and so your grains can have persistent state. They can either have state that's in memory, and in that case, you'll lose the state if it fails, which is okay for a lot of cases. But in the persistent case, you're writing your data back to storage every time you're modifying it. So you can use a variety of backends there.
Right. So at that point, essentially, it's up to you to essentially try to persist the data as the silo is running.
Yeah, that's right. So you'll persist it, and then Orleans will make sure that it gets loaded before your grain runs next time, in case there is a crash somewhere.
Awesome. That's great. So actually, the next one, it seems like to be like a three-parter question. So I'm going to start with the first one, and we'll go through it. All right. Yeah. So the question is from Mazen Ezzadine, which is, does Orleans provide a guarantee on execution semantics exactly once processing? And so to roll through it, so the state is persisted in a remote storage cluster, and the state of computation of Orleans objects are not coupled for any persistence and impact.
Okay, so I think we should deal with the first question first. Does Orleans provide any guarantee on execution semantics?
Yes.
So exactly once processing, Orleans messages if you're using the RPC paradigm, you get at most once. So we're not going to retry your messages automatically for you. You can, of course, use something like Poly if you want to have retries. And there's a feature called call filters, and that also allows you to put some retry logic in there if you want. Now, you can achieve exactly once kind of semantics if you're careful about the way that the application is done. For example, if you're doing things on persistent streams, then you can checkpoint where you're up to, and you can store that information so that process only new messages and you don't process messages twice. And you can achieve, I usually call that effectively once processing rather than exactly once, because the result of it is only visible once. Right. In other cases, like, for example, in the commerce case that I mentioned with the digital economy, they want their transactions to be able to be executed once. But if the caller doesn't know that that happened and something failed somewhere along the line, or they're replaying some logs, they still want item potency, right? And so they actually have a grain involved in some transactions that acts as an item potency check. And so that says, okay, if I've already executed and this transaction is committed before, don't commit it again, just return the same result. So there's a few different ways you can achieve that effectively once processing.
Great. I was going to say, since we're out of time, if you go to Twitter, you can actually answer those questions.
Yeah.
Right. So if you go that, because like I said, it's a pretty long. It's like, and this, and what about this? It's a pretty good scenario. I was reading as you were going through your session. But anyway, thank you so much, Ruben, for taking the time to talk to us and show us about Orleans. This is a really great topic.
Sure.
Thank you, everybody. We'll be right back. We're going to get Cecil Phillips up and going here. So we will stay tuned.
Thank you.
One, you're live.
Hey everybody, we're back again with .NET Conf Focus on Microservices. We have Cecil Phillip talking to us about Dapper for your .NET Microservices. How's it going, Cecil?
Pretty good, man. Thank you for having me on. Appreciate it.
Thank you for being on. Take it away, sir.
Sure, no problem. Hey everyone, thank you for joining for my session today. I'm going to talk to you about how we could use Dapper, which is like a really lightweight runtime for building microservices, how you could add some of those components to your .NET applications. We've had a lot of conversations about what microservices are and what we can do with them. So what I want to show is how Dapper could actually make the development of those things a little bit easier for you. All right, so let's start off with talking a little bit about why is building microservices so difficult, right? I feel like the ecosystem is really rich with a lot of different tools and services and different frameworks that we could leverage. But I also feel like some frameworks versus the others might have a little bit more support, right? Like some frameworks might have better support for messaging or for using open telemetry and distributed tracing and those types of things. And also, some of the frameworks might not necessarily support the targeted framework or the targeted OS that you're trying to deploy to, right? So, maybe some of them are more Linux focused or Windows focused, or maybe they're focused on deploying to Kubernetes versus, maybe you just want to run your own VMs, right? And so depending on what you want to use, you kind of have to filter out and determine what are going to be some of the best components that you could use to kind of plug together and make that world kind of work for you. And so this is where Dapr comes in, right? This Dapr is a distributed runtime, and this is DAPR, right? And what it allows you to do is to abstract some of those concerns, some of those commonalities that we use for building microservices, and it makes it very easy for you to kind of just add them to your application as needed without having to worry too much about where the things are and how do I set them up and those types of things. It kind of just makes building these apps a little bit easier. So let's talk about really quickly, what are some of the main goals of Dapr? Right. So first of all, we're going to see that, an important thing is that it supports a lot of different languages and frameworks. So, I know we're at .NET Conf, and, I'm definitely going to show you some .NET demos. But if you're building an application that runs with maybe like a mix of different programming languages, maybe it uses like Go and it uses Python, uses, PHP or something of that sort. How can we plug all of these things together and still use the same type of tool set to be able to build our distributed application? It actually reminds me of a story about, a few years ago, I used to actually build stock trading software. And, in that company, it was actually like a mix of a lot of other smaller companies that it had acquired over time through acquisitions. So that meant that like its development team was a development team that was a mix of different tools and frameworks and stuff like that. So that means that some of the folks were writing Ruby and some of them were writing Python. And I was doing .NET, right? So now how is it that we're going to be able to leverage all these different tools and different libraries and different parts of the larger application that are all built in these different types of languages and platforms, right? And so, we had to do some gymnastics to get around that, but, now we have Dapr and, hopefully that can make that a little bit easier for us. Dapr also adopts a lot of open standards. So you'll probably hear folks talk about things like cloud events, things like open telemetry and those types of things. By adapting those open standards, it makes it a lot easier for us to integrate with existing tools and services. Maybe you want to use something like Zipkin, or you want to use AMQP for messaging and those types of things. And then Dapr is also very extensible and pluggable. So depending on whatever target it is that you're trying to get to, maybe you want to use Redis or some other cache, or you want to use something like Cosmos DB in the cloud, right? Like it has a very pluggable architecture that if you wanted to use those things, I could very quickly pull them in and make those work. And so this is kind of what what Dapr kind of looks like, right? I mentioned at the bottom, like it supports a lot of different building blocks. So Dapr itself allows you to use things like service-to-service communication, it allows you to use state management, public subscribe functionalities, and all your application at the top needs to do is to be able to speak HTTP or even gRPC. So as you can see at the top, regardless of whether I'm writing Node or Python or .NET Core, I could be able to communicate with that Dapr runtime to be able to leverage some of these additional functionalities. So what does that mean? Well, I don't necessarily have to bring in any additional NuGet packages. I don't have to rely on anything other than what's exposed by your Dapr. And if you notice at the bottom too, it also shows that we could deploy this almost anywhere. Now I'm going to show you some demos of this running locally on my machine, but I could very easily deploy this to Azure. I could run this in AKS and have it running in Kubernetes. And I should be able to have the same type of application architecture, the same type of experience, regardless of whether I'm running in the cloud or I'm running on my own infrastructure. So how does Dapr do this exactly? Well, Dapr makes use of something called the sidecar pattern. Right? And so if you're not familiar with that pattern, essentially next to your application, and if you see these little gray boxes that are here, that represents your app, right? So your application is going to rely on this sidecar, right? It's a Dapr process that's going to be running locally right next to your machine. So again, if we're talking about Kubernetes, it's going to be running within the same pod. Or if you're just talking about a virtual machine, it'll just be running right next to you on localhost. But now your application is going to primarily focus on communicating with that Dapr sidecar. And then now those other sidecars that are attached to those other instances of your apps or services across the network are going to be able to talk to each other. And they're going to know, well, what services are available within my cluster? What kinds of functionality do I have enabled? So, hey, do I want to do pub sub with, a component? Then my app doesn't need to know where that pub sub component is. It doesn't need to know how it's configured. All it needs to do is say, hey, Dapper, here's a request. I want you to go do this work for me. And could you please let me know when it's done and like send me back the request. And then Dapper, based on its configuration, is going to go ahead and figure that stuff out. I mentioned a little bit earlier that we could host these inside of Kubernetes. The Dapper team has Helm charts and all kinds of stuff that's in there that allow you to do pod injection. So as you're deploying your application, it'll just insert that Dapper container, right? It'll insert that Dapper sidecar process inside of your pod for you. So now, again, your application will just be speaking to it, just like it's speaking to something that's running on localhost. All right, so let's kind of dive into these building blocks. And I want to show you a couple examples of how exactly Dapper does, some of the things that it actually does. Right, particularly today, I want to focus on like the service-to-service invocation. We're going to look at state management, pub sub, and then hopefully if we have some time, I'll show you what some of the distributed tracing features kind of look like. All right, so let's talk about service-to-service invocation. Now, when you have a distributed application, you might have one or multiple instances of a particular service. And the hard part is to know, well, where exactly does that service live? Particularly if you're talking about the world of containers, where these things spin up and spin down very quickly, you're going to have multiples of these things with like different IP addresses and different port numbers and these types of things. Okay? Well, what Dapper does is that it exposes your different services once they're configured via a well-known URL pretty much pattern. Right? So if you notice here, my front end can speak to my shopping cart without really knowing where the shopping cart is. And it simply has to send a message over to Dapper and say, hey, I want you to invoke the checkout method on the cart. And you can kind of see that convention a little bit when you take a look at the URL. It passes along a payload, and then the two Dapper sidecars will, again, figure out, well, hey, do we have something that could understand this request? And then it'll pass it over to like the right process that's going to be able to handle that. And then it'll send the response back. But from perspective of your application, you're just making a request, you know what I mean? And you got to get a request response. It's going to look like you're making a regular web service call. And again, I'm showing this here as we're using HTTP, but this also works if you use gRPC as well. Another thing you might want to do is leverage something like a cache or a key value store for doing some state management. And Dapper has, again, like a well-defined endpoints too that you can make use of to leverage those things. So if you notice here, I can make a post request over to something on the port of /state/ and the name of the store, whatever my state store configured happens to be. And I can pass it over with a payload. And then it would store it inside of whatever was configured on the other side to store that information. So if you notice here, we could support Cosmos DB or Redis. We could support Cassandra and Cosmos DB and tons of other things. Now, why don't we stop for a second? I'm going to head over to Visual Studio Code. And I actually want to show you a demo a little bit of how some of this things gets wired up. So I'm going to head over to, first I'm going to head over to my browser really quickly. And hopefully you can see my browser right now. I'm showing an instance of an application called Contoso Crafts. Now, this was put together by my buddies, Brady Gaster, and I think Maria Nagaga also kind of worked on this application. And it's actually pretty straightforward app. It's only a single page. It's built on server-side Blazor. And what this app allows you to do is, well, I could view some information about some items that are in the store. I can add them to my shopping cart. I can hit these add buttons. And then if I wanted to, I can hit this little shopping cart that's at the top. It shows me this checkout, and I can do some bit, right? And that's it. There's no other pages to the app, a single page application using server-side Blazor. But what I've done is I've taken this simple application and I've microserviced it a little bit, right? Like I've added some additional components to it. Before I go on, I just want to say, this might not necessarily be the type of app that you want to turn into a microservice, break it up into a microservice application. But I wanted to do this because I think it was, a simple enough application that, we didn't have to worry about too many moving parts. But the way that this is set up right now is that I have my front end application right now. So that's just my Blazor app, and it's serving the UI, right? I have another web API that's another service that's running. And that essentially is communicating with the database. And I'm making calls to that to get data and update things and so on in our data store. And then the third service I have is I actually have a queue processor. So every time I add something to the cart, right, and I come here and I hit checkout, What that's doing is it's putting an item onto a message queue, and then I have another service that's listening to that queue for messages. And so whenever that pops up, whenever a message pops up in the queue, then my worker will start and will start processing. Okay, so let's take a look and see how we configured all this stuff inside of Dapper. Right now, first thing I did, well, I'm running a lot of this stuff inside of a Docker Compose file. So what you'll probably notice is I'll have here, if you're unfamiliar with Docker Compose, I'm defining a service. And this is just my .NET application, and it's running on port 80 and port 443 because I have HTTPS set up for it. But then I have my website, but I also have a Dapper sidecar running next to it, right? And my Dapper sidecar is just running this command, right? And then we don't need to pay attention to the rest of this, but as you scroll down, you'll notice that I have a products API, I have a checkout processor, but for each one of my applications, I have an associated sidecar, right? So there's a website and there's a website sidecar. There's a products API, there's a products API sidecar. There's a checkout processor and there's a checkout processor sidecar. Because again, the whole point is that on my applications, they're going to speak to those sidecars, and then the sidecars are going to talk to each other. It's going to figure out where things are. Now, the only other thing that I needed to do in terms of me like configuring services and things of that nature is here, if you notice on my right side, I have a folder called components. And inside of my components folder, I'm able to set up a lot of different things that I want Dapper to use. So here, I'll give you an example. Here's an example of my state store. So I'm saying here, I want to create a component called a state store. I want to use Redis. And here's where my Redis instance lives, right? So here you can see that I have a Redis service. And then there's a username and password. Well, there's just a password. And I'm getting that from a local secret store. Right? And I kind of like that too, because that means that my secrets aren't exposed and everyone doesn't need to see what I'm doing there, right? But that's all I have to do. And so now whenever I start up my process, Dapper is going to scan that components folder and it's going to say, hey, what are the things that you have set up here? I'm going to wire them up for you. So now whenever I configure something to do state or whenever I need a service, like it'll just find it and then I'll be able to start working with it. Okay. We're going to talk about some other things too before I dig any more deeper into some of the Dapper stuff. Let's talk about PubSub, right? So a common integration pattern for a lot of folks is doing messaging with publish subscribe. So that means that I have some work that I want to have done and I want it to be done in another process, or I want it to not run in a background thread in my app. I want it to run somewhere else. And so what I'll do is I'll put a message on a queue, or I'll use a messaging service again, I could use Event Hubs or Nats, or in this case too, you can also see that there's Redis here. And all I have to do is, again, I'm going to use that well-defined Docker endpoint. I'm going to make a request there, and then Dapper is going to know where exactly it needs to send that stuff. On top of that too, more recently, the Dapper team also added the ability for you to do input and output triggers. So essentially what that means is as things happen outside of your Dapper application or your Dapper-enabled application, like something might happen in Kafka or Event Hubs or something like that, that will now invoke your application and have it start running code. So again, instead of me just writing an application and me having a web front end, this can react to things that are happening on the outside. And very similar to, we also have output triggers too. So again, if you want to interact with another store or some other system outside of your application, we could do this as well. So that might be sending messages over to Twilio, or I might be running something on DynamoDB, or something like that. Okay. Now, let's do the PubSub demo, because this is the one I really wanted to show you, because there's a lot of cool stuff in it. Now, I am going to, so my app is still running, right? And I remember what I said to you before, right? So every time I add something to the cart, I'm going to click this thing. And what it's doing is that it's going to send a message over to our message bus. Now, in this application, I actually have RabbitMQ set up as my message bus, right? So you can see here, I have, my RabbitMQ connection string. I have some data here set up. But now that's all I really have to do. My application, my .NET code knows nothing about Redis. It knows nothing about RabbitMQ. And I'll even show that to you inside of the RabbitMQ management console, right? So if you click here, you can see that I have connections here to 3 different services, which kind of makes sense, right? Because I have my website, I have my API, my queue processor. But they are all aware of what those things are, right? But they're aware because Dapper set that up for me and not because I knew anything about it. Also, you'll notice that I have an exchange here. I have an exchange called checkout. I also have a queue called checkout processor, right? Again, I didn't create these things. These are things that Dapper just made for me, right? And now my application can just use them. Now, just to prove the point that I actually don't need to change my application when I want to switch components, this is what I'm going to do. I have this RabbitMQ item here. I'm going to delete it. So I'm going to right click, I'm going to delete it. Poof, it's gone. Don't have it anymore, right? But now, how is my application going to keep running, right? Like, how does it know, like, what is it going to use? Well, I actually have another PubSub component set up here. I have Redis also set up as a PubSub messenger. So, but what do I have to do to my code to actually get that to run now? Well, I'm just going to go ahead and I'm going to do a Docker compose as soon as my window comes back and lets me do it. I'm going to do a Docker compose up, right? So all I did was like I shut down my application and then I ran it again, right? So now my Dapper compose, my Docker is running. My Dapper doesn't know anything about RabbitMQ anymore because I took it out, but it does know about Redis. And you notice here when I search through the logs, it says component found message bus. It says Redis, right? So I'm like, okay, it is established that Redis is now going to be my message bus. So what does that mean? That means that if I refresh my application, right, and I'm going to, there's nothing in the cart, I'm going to add stuff to the cart again. Notice I haven't changed any code. I'm going to submit my application, and it's still working, right? And if I take a look at my logs at the bottom, I don't know if you could see this, hopefully you can. It says at the bottom, order received. So that's perfect. Like my app is still running. I've just switched out the component that I'm using, right? I've just switched from RabbitMQ to Redis, and I haven't changed any code, which is great. Now, some of the other things that come out of the box with Dapper that I think are really cool is it supports the Open Telemetry standard. So that's a standard where we, collect our logs, our metrics, our tracing in a very uniformed way. But because of that, Dapper knows how to do things like creates, it knows how to actually find out what exactly was happening in our application if we wanted to. So here I'm using a tool called Jaeger. And Jaeger is a tool, again, like it displays traces and it collects that information for you. I can click on one of these traces and I can show you that, hey, our request was made and it involved my website and the checkout processor, right? I could see how long it spends in my website and I could see how much longer it spends in the checkout processor, right? But I could look at these things and I could look at the different requests that were made. Let's look at one that called the shopping cart, right? So this is the shopping cart one, and is there anyone that's any more interesting? Right, here's one that called the products API, right? So here it called the products API, and it was waiting for it. This entire time it's here at the top waiting for it. And then when it got a response, it was able to continue and process, right? So I could look at my requests and I could see where they're going and how things are happening. But also what's really cool is that I could click this system architecture diagram, and notice now just by the fact that I have Jaeger wired up, it can show me the components that are inside of my app. And remember I told you I had 3 components, right? I had this website, I had a products API, and I had this checkout processor. And now because I have Zipkin wired up and it's collecting these things for me, it's able to do that, which I think is really cool. Now, the last thing I want to show you, like at least in terms of the demo, is, well, hey, we have all these components that are running, but what if I actually wanted to debug these things? And I think being able to, have that developer loop where I can actually debug my running containers is actually really important. So what I'm going to do, so this is the code for my checkout processor, right? And all it does is that it just listens for something on a /checkout endpoint. I'm going to add a breakpoint here. And then inside of VS Code, I have a task set up that allow me to attach to the container. So what I'm seeing here is a list of different containers that are running. I'm going to select my checkout processor. Now, what I'm expecting to happen is that it's going to fire up the debugger, it's going to attach to the container. And now if I go ahead and continue using my app just as I was before, right? So again, I'm gonna click some things, I'm gonna add it to the cart. I'm gonna hit submit. 1, 2, 3, 4, 5, boom, there we go. And if you notice, it's now engaged my debugger, right? And I could step through the code. And again, this is running in the container using Dapper sidecars. And so if you want to really see what's happening in your app, you could set these breakpoints, you could debug through your app, and a very familiar development experience for a lot of us .NET developers. And if you notice here at the bottom too, it says, information order received, so which I think that's great. Okay. All right, let's head back to the slides really quickly. I know we're running a little bit late on time. I only have like 30 minutes, so let's kind of scoop through some stuff real quick. Right. So that was Dapper, right? We have a lot of different components that are inside of Dapper that we could use. We saw service invocation, we saw states, we saw distributed tracing, we saw the pub sub stuff, and there's a lot more things that are inside there as well. Some of the things that we could start looking forward to in the future is, everything that I've done so far has only been using like HTTP calls. The team's going to be working on a set of language SDKs that you could use. And also, too, there's going to be additional framework integration. So if you want to use things like Azure Functions and Logic Apps, or if you're a Spring Boot person, if you want to use that, or actors, you'll have that ability there as well, right? So right now, if you head over to the Dapper repo on GitHub, you'll see there's a project there that talks about integration with Dapper and Azure Functions. And I know them and the Functions team work together on creating these different input-output bindings for functions so that you can use it with Dapper, which I think are really cool. One of the more newer projects is Dapper Workflows, which essentially is the Logix apps runtime, right? So the same Logic apps that we have in Azure today, running within the context of Dapper. So if you have workflows that you want to orchestrate, you can have that running, but within your Dapper architecture and trigger there as well. There's also support for actors if folks are interested in that type of stuff. We just had to talk a little bit about Orleans, right? And so, you see a lot of games like Halo and those things are built on like an actor-based type architecture. If you're doing anything with IoT, that's another good example too of using actors. All right, so roadmap, really quickly. So what are some of the things that we got to look forward to? The team is working hard, pushing to Dapper 1.0. Then, we got to get the functions extension to 1.0, the Logic App extension to 1.0. And then hopefully, too, we'll see some work being done with getting Dapper into some of our managed services like Azure App Service and Azure Functions and things like that. But I think that's all I have to show you for now. I know I'm running super late on time. I want to leave some time at the end here for some questions. But if you want to learn a little bit more about some of the things that you've seen today, definitely go check out this website, theurls.com. I promise it's a safe link. You don't have to worry about it. But you head to theurls.com/.net-dapper. And I'll have a collection of links with the source code for the demos, links to the Gitter community for Dapper. Definitely go in and check out some of the issues, look at some of the things that they're working on, and and see if maybe Dapper is a good fit for your application that you're building. And if you have any questions, let me know. I can't hear you, Javier, if you're speaking. Can't hear you.
How about now? Can you hear me okay?
Gotcha.
Perfect.
There you go. I was like, am I talking to myself? Like,
I've been having issues with my mic all day. I've been checking everything, and I was trying to get the next speakers up and going. Anyway, so we have a few questions out there.
Sure.
So from George Stalker, he asked, so to me, someone who never really adopted these frameworks, do Dapper, Orleans, and Steel Toe all try to solve the same problem?
Yes or no. I think they saw them using different ways. So first of all, like Steel Toe, for instance, is a package, right? So that's a NuGet package that you run in your .NET applications. Mm-hmm. Dapper is not a package; it's a runtime. So that means that it's a process that you're actually going to run on your machines, on your servers, on your containers, whatever the case is. And it's also language agnostic. So it doesn't have to be a .NET application, or it doesn't have to be any application that's based on one programming language. Again, like I think a lot of folks, particularly in the enterprise, are using multiple things when they build up their solutions. And so if you want to pick and choose what you want to use, it's okay, right? Like all you have to do is be able to speak HTTP or gRPC, and it'll work great.
Yep, perfect. So let me go to the next question. So does Dapper allow HTTP or only gRPC? I've had issues using the Dapper/.NET SDK.
Yeah, it allows both. I personally have not used the .NET SDK, mainly because I think the RESTful endpoints have been plenty for me.
Yeah.
But if you're having issues with that, I definitely recommend you to go ahead and file an issue inside of the Git repo. I know folks are constantly looking at that and looking for feedback. And so if there's a mismatch there between what your expectations are, I definitely say to do that.
Perfect. All right. So here's another one from our Adam, or rerun Adam. Since Dapper is defining an abstract version of a message bus in the example, Redis and RabbitMQ, how do you handle the fact that RabbitMQ and Redis offer a different set of features?
Sure. So I think what you're seeing with Dapper is they're giving you their prescribed patterns, right? So what does that mean? So sure, you can do a lot of things with RabbitMQ. You could do fan outs. You could do competing consumers and lots of different types of patterns. I know Redis has a streaming feature, which is there as well. But what Dapper is doing is that it's just trying to abstract the common pieces of building microservices, right? So what are those common pieces? There's never going to be, I support everything for every different target kind of thing. You're going to have to kind of pick and choose and see what makes the most sense for your application. Maybe you have a Dapper application and you don't use those features, but maybe you just make use of the observability features because you want to get that app map functionality, or maybe you just want something to, kind of do secrets for you. Like that's possible as well. But if you do need those more advanced features, then, maybe you do need to just commit to using that product's SDK or, their API or whatever the case is, and take it from that approach.
Excellent. Let's do one more question.
Sure.
All right. So let's see. From Andy Wall, which I think we kind of answered it. What is the difference on positioning between Steel Toe, Azure Service Fabric, and Dapper?
Yeah, they're just different, right? So again, Steel Toe is it's a package. It's a .NET package. With Steel Toe, you still need other stuff, right? Like Dapper is a runtime and it's something you communicate with. Steel Toe, for instance, like if you want to do service discovery with Steel Toe, like I still have to set up console or Kubernetes or whatever the case is, right? And then, I'd have to be writing my code to focus on that thing, right? Versus Dapper, it just kind of does it for me, right? Like a lot of those things are ambient. And so my application knows a lot less in terms of like code I have to write and packages I have to depend on. Again, even like things like, Service Fabric. Like for Service Fabric too, like that's a service that runs in a cloud. Again, Dapper, you could run it anywhere. So again, like there's different ways to do things. I think, just as you have to make the decision about whether I want to build a microservice or not, like you have to kind of determine, well, what are the features that I really need for my application or not, and then make those smart choices.
No, that's really great point. Well, I think that's it. We're right on time. Cecil, thank you so much for taking the time to print us. It was great. I know you and I went through an A/B check, and you showed me all the demo, and I can't wait to take a look at it and everything. Thank you so much for volunteering your time. We'll be right back more with .NET Conf Focus on Microservices.
Hello, everybody, and welcome. I've been getting a lot of Twitter traffic about Thai and wanting to see an amazing deep dive into it. And I'm going to go, it's not as deep as, Fowler and I would normally compete about doing deep dives and going as deep as possible. But half an hour constrains us a little bit. So let's get into this. And it looks like Justin joined us just in time.
Hi.
That was a pun and I didn't realize it, but well done. So let's get into running through this. So I want to first of all cover a little bit of what we hopefully got out of the keynote again, which is why do we care about Thai to the first bit. I'm going to gloss over a lot of this, just quickly recap it, because I'm hoping that Fowler and Hunter managed to cover this pretty well. So today, if you want to get started, you got to just do something be simple, not even something complicated like a big fancy microservices architecture with 80 microservices, as Kelsey said earlier. You just got a web app that wants to talk to an API. Right now, in here today, the problems you get a bunch of problems. You can make Visual Studio or Visual Studio Code or whatever tool run multiple applications at once normally. Right, it's a bit easier in Visual Studio than other options. But then you have this problem where if you've just done .NET New Web a couple of times, everybody's trying to listen on the same port. You need to go manually configure all of those. Then you need to go configure every app that wants to talk to another app to have another config key that points to those things. So you have a bunch of config files, all with URLs, all pointing to each other. And God help you if you want to change them. And then in production, you need to go make all of that config work over there as well, or point everything to some service discovery, centralized service discovery system. You would have seen one of those in Steel Toe, for example, solves this with a particular way of doing service discovery by default, when you saw that earlier with David Duroff. And then if you want to, on your local machine, use message queues or Redis or SQL Server or something like that, there's nothing really in the box to help you get started. So Thai wants to solve all of those. Now, what have we got today in the ecosystem, like Docker Compose? Could Docker Compose be a solution to this? And the answer is maybe. It solves some of these problems. It certainly lets you run up multiple containers at the same time very easily. It lets you do a lot of this, get your dependencies in there. The little bit of a problem with that we thought as .NET folk is, well, then you have to have gone through all of the effort of learning Docker before you can even get started. And that seemed like a little bit of a higher barrier of entry than what we were really happy with. There's a fairly steep learning curve. And even as Kelsey said earlier, it's not necessarily, you don't really necessarily want to containerize your app during development. You don't necessarily want F5 to go into a container. That's a pretty heavy hammer to wield. So, you might need to do it for some reason. That's why we have kind of the debugging tools to get into there. But in general, it's probably better if you don't. That's kind of some of the premises that we started with Thai on why we didn't just say go with Docker Compose or something like that. So we have Thai, and it has a bunch of these things that you've seen, and we're going to continue to talk about further, which was the solution to a lot of these problems that I just kind of listed. So let's talk a little bit about the app that I'm going to show you today, and I think Justin is going to show you today, which is this voting sample. Now, this sample is in the Thai repo, so you can go grab it from there if you want. We've been doing a lot of work modifying this, and we'll merge those eventually, but it is all in the public, so you can see it. And the premise of this app, if you've seen this this is common in the microservice, in Docker land at least, where you have a votes, which is a web page, which has a button. You can either vote for dogs or cats, right? Then it uses Redis. It puts that your vote on Redis, and you can change your vote. Then it puts that vote onto Redis. Then a worker picks it up from Redis and adds it to a Postgres database. And then there's a results page which shows you the results of how many people have voted for either cats or dogs. It shows you a pie chart. And today in this, we've secured-ish, because we did a little bit of things that were a little bit bad in order for the demo, that results page with identity server. So there's a dedicated authentication kind of service that does all of auth, right? Which seems like a very nice microservice-y thing to do. So first off, let's show you some stuff. So let's open up code. So I have code going, but let's first of all just run this with Thai. I'm using this thing that says this thing called dthai. It just means that I'm using my local copy of the Thai source code rather than a pre-installed version, because Justin and I have both actually been hacking on Tye and on the sample app at the same time. Every time we try to do something, we would say, oh, there's a great feature idea there. Let's go do that. And then we would sometimes hack those in. So this is stuff that you've seen before. This is Tye booting up all of the things in my solution. And what I'm going to do to show you what that solution contains is switch back to the dashboard. So here you see I've got my Vote app that you saw earlier. I've got a Redis container that has been spun up at the same time as I ran. I've got my worker project. I've got a Postgres database, the results app, and an identity server. So that entire diagram that I just showed you was just spun up all at the same time. And all of these things have been configured to be able to point to each other and run. And so now if I open up a new tab, I can vote for like dogs or cats. I can go to my results page, and it's going to prompt me to log in using identity server. So this has redirected me to the auth service in this case. I'm going to use the default stuff because we're using like in-memory usernames and passwords and all the default identity server stuff, basically. Then I'm going to log in, and then I have this beautiful pie chart with only one vote where I can either vote for whatever I want. And as I vote for things, it'll like change, right? So you can see the pie chart kind of animating over there. So that's the application. There's kind of an amazing amount of stuff that just got kicked off all at once. And then if we look at some of the features on here, we can go look at the the logs for my application. I can in here somewhere, like just here, you can say, oh, I'm adding a vote for this photo ID for this, and they're voting for A, right? So you can see that stuff is starting to appear in the logs. And then I could, if I jump over to the worker, I can probably see, yeah, you can see it processing each of those votes as each of those votes change, right? And then I also have logs for example, the database server kicking off, right? And then there's something interesting in here. You see a bunch of this stuff at the top here. This is actually the Docker run command that this project used to run this Postgres database. And at the moment, you can see a whole bunch of config variables being set, worker service port, for example. So I had a few questions on Twitter earlier about config and how Tye does some of its service discovery. And the answer is we have a convention for how we configure your apps to all talk to each other. And that, which basically boils down to, when we're launching you, we set environment variables with the port numbers and the URIs for all the other services in the solution. And then in your project, so for example, in here, when I'm configuring identity server, I can say configuration, get me the service URI for identity server, right? And you can do that for any other service that's in there. And when talking to something like Redis, you can say, get me the connection string for Redis. And then down here, in my Tye YAML. So in this case, because I've got a more complex solution, it's not just .NET code. I've also got database dependencies and stuff. I have a Tye YAML. You saw it running without one of these earlier in the keynote. So in here, I do things like say, this is my Postgres service. This is the connection string for that Postgres service. And then any other service in this solution will have a config key set, which is in the order of, I can't remember its exact format, Justin probably can. It's something along the lines of Postgres : connection string, something like that.
I think it's service _ Postgres connection string.
So there's a convention, and we have some code that gets that hanging straight off of the configuration builder. Okay. Now, if you are so kind as to go try this out, I'm going to remind you again towards the end, this link up here takes you to a survey. Please go fill out that survey. Helps us a lot. Charles is probably in chat right now, our user research guy, saying make sure they go do this survey, because it helps us define the future directions of Tye. It helps us understand who in .NET is actually trying this and using it. So please click that link and go do it whenever you try out Tye, because that helps us a lot. Same for Blazor, if you click and do the survey for Blazor. Now, that gives you a whirlwind tour. This is a quick talk, so I want to keep things moving, keep things snappy. I was trying to say snappy, I think, at the same time as doing a keystroke combination. My keyboard doesn't have F5. It's like the worst in the world. Anyway, so then that gives us the idea of the local story, right? It's running all of those as local processes. And you saw earlier how Fowler could decide to run them in containers, and you have that containerization aspect. So now you've seen that thing running, you've seen some logs, you've seen the dashboard, you've seen that it can make things a lot easier. Now we're going to move into deployment. Then Justin, I believe, is going to talk to all of these, and I guess I will press next every time you want to, rather than doing the machine dance. How does that sound?
Sounds good. That's totally fine. Eventually, I'll steal it though to do the demo potentially. But For now, yeah, thank you, Glenn. So to start off, like we recognize a bunch of the problems that existed with the Thai run experience today. However, we noticed that for Thai deploy, not many things can handle a lot of the things that Thai deploy does today, simplifying all of Docker file creation, pushing images to Docker, creating Kubernetes manifests. All those things effectively create an experience where you can deploy something to Kubernetes without having any configuration locally besides the Thai YAML. So go ahead and go next slide, Glenn.
Sure thing.
So the first step here is going to be recognizing the difference between our projects that are like .NET projects, so our voting app, our results page, the worker, and authentication, versus the things that I would consider more external, like Redis and Postgres. Thai today does not deploy these directly to Kubernetes. It requires pre-configuration, which is either done via like creating the Redis image within the Kubernetes context, or providing a connection string to something else like Postgres hosted on Azure SQL or Azure Database for Postgres SQL.
Yeah,
so
I think the way we think about this is for generally your dependencies, you probably don't want Thai to deploy them. You've probably already got them running, either because they're a managed service or you've already configured them on your cluster. So we expect you to give us a connection string for things like Redis rather than us just creating a Redis for you.
Exactly. Exactly.
Yeah.
All right. So the next step is going to be doing something with these .NET projects. So what we're going to do here is we're going to first put all these Docker or all of these .NET projects into a Docker image. To do this, what you first do is we do .NET publish on each of them to get the publish output. We create temporary Docker files to be able to call Docker build on in order to create these Docker images. Afterwards, we go ahead and push them to a container registry. This can be any container registry like Docker Hub.
Mm-hmm.
It could be Azure Container Registry. There's many different options.
You saw the Google Cloud one earlier with Kelsey's talk.
Oh, yeah. And then finally, now that we have these images on a container registry, the whole reason we did all of that was to be able to reference them within a Kubernetes manifest. So in order to actually finalize this, Thai creates Kubernetes manifests that reference these images and actually applies them to the Kubernetes context. Wow, look at those transitions.
Yeah.
With this, Thai also sets up all the environment variables that we saw earlier inside the Kubernetes context, such that when you actually have an app or have a service running within a Kubernetes cluster, you can see that app having all the environment variables necessary to communicate with all other services within the cluster. Awesome. Can I steal presentation at this point?
Yeah.
Sweet. Let me go here. Can you see my screen? Glenn, can you see my screen?
I don't know if I'm going to.
Okay.
Let me see. Oh, yes,
All right. Awesome. Sweet. So I went ahead and already did a Thai deploy for the sake of time, considering my internet died. So what we're going to see here is we had a few things go on. We see that the projects were published. We built Docker images for each of them. We pushed these Docker images, and we also did some validation of the secrets that were mentioned earlier. So making sure that Redis and Postgres were both set up beforehand. Then at that point, we generate the Kubernetes manifest in order to actually put it in Kubernetes. For Redis, we also see that we're kind of skipping everything here because, again, we mentioned that we expect you to pre-configure it. Finally, I wanted to talk a little bit about ingress. So in order for this app to actually be available to the internet, what we realize is we need to actually have some way to access some IP. Ingress effectively gives you the ability to expose parts of your Kubernetes cluster to the internet. So what I did is I actually set up a definition inside my Thai.yaml to define stuff for the ingress. What this has here is it has some paths here to reference the voting service, the results service, and identity server. So when I actually access those addresses at the whatever IP I'm hosting at, you'll be able to get those. All right, so now let's actually go take a look at the app. I already have it deployed, and I have it running at this URL. I have an aka.ms link here, Thai demo, you can go to. And if you would like to go vote on your own machine today, feel free to. I'm going to vote for dogs because those are clearly superior. If you go to the results page,
Amy disagrees. Wherever Amy is right now, she just set up an alarm.
It's okay. It's okay.
Amy is our Thai PM, and she loves cats.
Yeah. So anyways, we can see that the page is constantly updating right now. We see people voting for cats.
Yeah, look at all of that.
I don't understand why.
Look at them all. Just look at how many.
People are just toggling back and forth. What a shame.
Yeah.
Anyways, we can also log out from here and go from there. Awesome.
So yeah, if you look through this text, you can really see the order that we're doing things, right? As we were prompting, you can see where we prompted for secrets, right? Where we validate here, where it says validating secrets, where it didn't prompt, right? Found existing secret. So what that means is the first time you run a deploy, it'll prompt you to say, hey, what is the configuration? What is the connection string for Redis? You'll give it to it. After that, the second time you deploy, it's going to say, oh, I've already got a config key that matches the name I would use for Redis. I'm going to assume that's the right one. And then if you ever go delete those manually on the cluster, we'll ask you again the next time around. And that's kind of the way that works. So if you use the Kubernetes CLI, you can see all of these containers now running. You can see them all getting up, and it's a really quick way, really good way to just quickly get everything up and running on Redis, including configuring all your public endpoints with that ingress, which, because by default you do this without ingress and nothing is publicly exposed. So you can get to it via the, port forward command in the Kubernetes CLI, but you can't necessarily get your friends to hit it or whatever.
Exactly. So as you can see, I'm going to do a little bit of a browsing of the Kubernetes stuff. So we can see that there's 5 pods here. 4 of them are the .NET projects that we're currently running, but one of them is the Redis image. I decided to configure Redis to be in cluster as an example. However, I actually have Postgres hosted on Azure Database for PostgreSQL.
Right. And the way we do that is just we went and found the Helm chart for Redis and said, Helm, install Redis for me on this cluster. And then it went and created the Redis container images. And then the configure, so the connection string just points to those containers, but Ty doesn't have anything to do with deploying them, is the way that we did that.
All right, cool.
Cool.
Glenn, do you want to take the slides again?
Yeah, I can take the slides again.
Yeah,
let's do this. So here we have a slide of more features, and I'm just going to go down and talk about some of these. Some of these you wouldn't have seen before. The first one, which we just added, and you should probably go try it out. We don't have deployment support for this, but we have local development support, right, Justin?
Yep.
For Azure Functions. And so the way this works is you can add a function to your app, and Ty will take care of knowing that it's a function and running effectively the functions emulator locally on your machine to let that function run, and then participate in the service discovery stuff so you can go invoke it, right? So that's Azure Functions and Azure Function support. And then we have Dapper. This has been around for a lot longer via our Ty extension, where you can have Ty knows enough about Dapper such that it can run all of the sidecar containers for you automatically without you filling your Ty YAML with those, just by saying, I'm using Dapper.
And this works for both run and deploy.
And then Dapper does work for run and deploy, whereas Functions we still haven't got to deploy. We only did the local run support. So then we have ingress support, which you saw a little bit of. That lets you define your ingress rules so that for working for locally and deploy. And one thing I don't think Justin got to show you is when you're running ingress, and you didn't see it, when you run locally, we also run a local proxy, so that you have that ingress experience on your local machine as well as in your Kubernetes cluster. And so then you have this local proxy that proxying all your traffic as well. So you can have the experience of using a local reverse proxy as well. Then there's also some support. And if you look at the build talk that I did with Ryan Nowak, I think we show a lot more of this. So you can have some diagnostic support with Zipscan, Seek, Elastic Stack, things like that, to be able to get distributed tracing, more structured logging, ability to search across all of your logs, and a bunch of cool features like that. So just like Kelsey said, logging is super important. One of the other things that can be really important is correlation across services, and that's where things like Zipkin and stuff can really shine, is correlating when I did X over here, Y over here happened. Right. And then multi-repo scenarios. I've had a lot of comments asking about this because not everybody has a single repository where they put multiple microservices in it. So a lot of people are interested in how do I have multiple repos that I then use with Ty? How does that work? And we have a doc on our repo that talks about some of the support we have for this. We have the ability to reference other repos, reference other Ty YAMLs and things like that. I don't know if we've 100% nailed it yet, but we're still working on it. We're happy to hear all your ideas about that. But we're
still playing around with a few things with it. We're still trying to figure out whether or not like having some sort of packaging format is going to be good in the long run. We're playing around with a little bit of CNAB, but we're still not 100% landed on anything yet.
Yeah, still experimenting, right? You could imagine, for example, a team completely independent of you taking a a solution using Thai and say publishing some artifact, and then you could just reference that in your project, and then when you run, you would go run all their stuff without you necessarily knowing anything about it. That's kind of the idea of bundling. We don't do that right now, but that's one of the ideas we played with. So happy to hear from you if you want to come talk to us about the ideas you have for that, or what you think would work with your workflow. Even is always valuable. Feel free to go create an issue, throw the idea label on it, talk about whatever you want. We'll be there in GitHub in .NET/Thai. And then we have Thai build, push, deploy, undeploy, right? One of the things that's interesting, Thai push, now remind me, Justin, that's the one that just goes to the registry, right?
Yeah, I believe so.
Right. So a couple of people asked, like, well, if I've already got this like flow for being able to go to Kubernetes, one of the things that Thai push lets you do is just take your project, push all the images to a registry, but not do the final deploy to Kubernetes. So then you could have something else kick in and take over if you've already got some other way of deploying to Kubernetes, for example.
We recognize that there's so many people that whether or not they have a system set up today to do their entire CI/CD versus a system that did just like they have absolutely nothing. We're trying to make sure that Thai has some sort of potential way to do any of those. So adding Thai push as an example allows people to handle all of the Docker files within Thai. But if they already have something set up for Kubernetes, might as well let them use it.
Yeah. Another thing we have a couple of samples on but haven't necessarily nailed is how you manage your SPA JavaScript front end in your Thai solution. But anyway, that's everything from us. I believe that's all of our time up, right? Timekeeper Jeff over there, master of all the times.
We do have just a few questions here and a couple minutes. If you don't mind, I'll share my screen over here. And
if I say yes, I don't totally mind. What would happen?
We'll throw you out. That's
okay.
It. You're going.
Okay, in that case, I don't mind at all.
All right, okay. Let me bring up the tag board here. We can take a look at some of the questions that we have here. And you started to go down into a common question that we have here from a few folks like Peter asking, does Thai also work with non.NET applications, perhaps Angular with SQL Server databases?
Right. So obviously SQL Server databases, yes, because we showed the demo of Postgres, for example, and SQL will work exactly the same way. SQL Server runs in a container as well, for those of you who didn't know. So basically anything that you can find a Docker container for, that you can run locally and use as a dependency can just be a dependency in Thai in general, right? Because you should be able to configure it to work. For Angular and such, we have kind of a couple of ways you can sort of get it to run at the same time. We haven't necessarily put first-class support in, for example, for creating a Docker image for your Angular app. Right? We're not yet sure about how far down that path we want to go, whether we're better off sticking to what we know and being much better at deeply understanding .NET, or should we be spending more time making it more broad and supporting many languages, but potentially not being as good in any particular one, for example. We're still a fairly small team working on this thing, but that's also why it's still an experiment, as we said. Like we're still heavily in the experimentation phase, trying to work out exactly what we think this should be and what the future of it should be. So again, the best way for you to try and make sure it supports Angular is to put your vote in for Angular and come talk to us about it. Or talk to us more specifically about what you think the best support for Angular might be.
Mm-hmm.
Yeah.
We also do support Docker files. So if you do have a previous Docker file that is for a certain project, like even like a Node app or an Angular app, if you have a Docker file that you've already written, we will run it with Thai.
Yeah, the idea is you just drop it next to your CS proj, right? It'd be the idea.
Well, not necessarily CS proj. You can just point a path to your Docker file.
Yeah, that as well. Yeah.
Very cool. One more question I want to sneak in here. And this one is from Bob Crawford asking, how do we use Thai in our CI/CD pipelines?
Thank you, Shane.
Yeah. So that's an interesting question, right? So you could, if you wanted to, Thai is a command line experience. So obviously you could invoke it if you want to, right? If it completely matches all of your requirements. I assume that right now, where it stands, there's going to be a lot of gaps and edges in trying to use Thai, to invoke Thai in a way that just goes to Kubernetes straight from your CI/CD flow. What I expect to see more of is things like using Thai to get to an image registry and then doing something else, right? But this is another area where we're still talking about it a lot. We've got lots of ideas for what it could be, but we're still not sure what the best approach for us to be is should Thai play in that space? Or should Ty stick to a slightly different box and let the tools that are experts in that space continue to be tools that are expert in that space? So that's another area that we will definitely want your feedback on. Right now, the options are basically run Ty and let it deploy to Kubernetes if that's what you want. But I expect there's going to be it's probably not quite what you want right now, and then you should talk to us about what you hit. Or use it just to get to a registry so you don't need Docker files and stuff because you're just doing .NET or just doing whatever the thing is. You're not doing anything complicated in Docker, and let it do that part for you. And then after that, do different steps to automate it in your CI/CD flow.
We already we do have a doc that Shane Boyer contributed recently to that talks about Ty deploy with GitHub Actions.
Yeah.
That's something you can try. Like that, we will not say, oh, don't try it. But like again, we do say like, this is not necessarily something that's production ready at this point, and use at your own risk.
Yeah, we just want to hear from you to tell us what you think is good or bad or ugly about it.
All right. Thank you so much, guys. I really appreciate you joining us for this segment of .NET Conf, and we're going to get ready for our next speaker. Clemens Vasters will be joining us.
Hey, excellent.
All right.
I'm glad I was before Clemens and not after.
Yeah.
Thanks, everybody.
Thank you.
All righty.
Really
take care.
it. Bye-bye.
One.
Hey everybody, we're back with .NET Conf Focus on Microservices. We have Clemens Vasters talking to us right now about eventing and messaging patterns. How's it going, Clemens?
It is going really well. Thank you for having me.
Thank you for being here. Take it.
Yes. So the topic is beyond REST and RPC, asynchronous eventing and messaging patterns. And this session is not going to be as demo-rich as the previous one because the principles are not so well known apparently in the C# community, because otherwise you would use more of these asynchronous services. So I thought I'll spend this half hour educating you a little bit about the patterns, and then I also will point out some products as well, OSS projects and products, as well as Azure services that we have to realize them for your microservices applications. So because this is a .NET conference and everything has to do with code, here's your demo. So basically all I'm talking about is you craft messages that carry information, and then you send that information to someone else, and they will either be reactive, which means they were going to register a handler on a loop and then will be called whenever a message arrives, or they will be imperative, which means they will go and receive messages. And that's true for most of the infrastructure that I'm going to talk about. And what I'm really talking about is that little blot in the middle, that little queue-like thing. And the question is, why do we need that? And why does it make sense to have these kinds of infrastructures in the middle? So that leads me to the pattern section. So generally, we talk about here in this session about synchronicity versus asynchronicity. And most of the demos and all the demos I think I've seen so far in the previous sessions are really synchronous, which means you have a sender who is doing an HTTP request, an RPC call, and that sends a request and then waits immediately for an answer. And the underlying primitives are obviously asynchronous I/O, and that's what I just had with this send async. You're making async calls, and that means that you're calling on a thread, and then that thread goes away into the I/O stack, and then eventually comes back to you, gets resynchronized, and all the magic happens, and then you're going back into your logical thread, but it's still looking like a local call. And in those models, the request and the reply are implicitly correlated, and that's super convenient. And errors, exceptions, etc., are typically flowing back in the same path. When we talk about asynchronous messaging, then the sender sends a message, raises an event, and then goes and does something else. It doesn't wait for anything. The replies, if there are any replies, come back on a separate path. And those messages, because the sender walks away and doesn't wait, they may be stored by an intermediary, and they may also the delivery of those messages, because nobody's waiting, might also be attempted multiple times. So that's the right side of this, the asynchronous services. That's what we're going to go and drill into. And you're going to say, oh my God, one way. How does that even work? Because if you are coming from a world where everything is a function call, or everything is a REST call, what you will be familiar with is the model where you get an immediate response. You know what the outcome is of an operation. And with messaging, if you're using messaging or eventing-oriented services, you have to trust the middleware to keep the message, not lose the messages, not lose the information that you entrusted into it, and then leave it effectively to the middleware to then negotiate outcomes with the receiving end. And that may be one consumer, may also be multiple consumers, as we'll see. So asynchronous flows are generally one way, and the producer only gets the immediate answer. Only gets the message has been secured. You can walk away. That also means, and that also enables really, that those reply and error channels of how we learn about the outcome of those operations become explicit. So they're not tied into this request reply channel, and they also don't depend on that request reply channel staying alive. So if you have very long running activities, I'm going to talk about that in a moment, that may take hours or days, you're not depending on a single volatile and brittle socket to stay alive, but you're effectively modeling how your replies are coming around and how your errors are returning. And also correlation is flexible, which means in this model with asynchronous messaging, you can send one message, but then you can answer with 30. Or you can send one message, distribute that to multiple parties, and collect answers from every single one of them. And that's the liberty in terms of communication patterns that you gain through starting with an asynchronous one-way flow. So I just talked about long-running work. So let's think about that for a moment. Processing at a consumer may take very long, minutes to hours. If you think about use cases we're working with companies who are doing autonomous driving, for instance, or planning for autonomous driving, and they're having these sensor data packages that they need to go and crunch, and crunching that data can take minutes, can take 20 minutes, can take an hour, can take very long times. And of course, that's something you can't do within the scope of an RPC call or an HTTP call, because you will lose the context. You will lose that precious socket, because the longer a connection lasts, the higher is the risk that you're going to lose that connection for all kinds of reasons. So if you have very long running work, it is preferable to have that long running work come from a queue or come from a buffer, so that you can go and process it. And then once you're done processing, then you go back to that queue and effectively say that you're done with it, but you don't let the producer wait for all that time. So you want to have those decoupled. So processing of that consumer may also require, in addition to that, super reliable one-time outcomes. If you have a payment, you only want to execute that payment once, which means you want to have certainty about how often the job has been done. And if you think about exceptions, specifically network exceptions that can occur during an HTTP call or an RPC call, you don't quite know when exactly the communication broke down and whether the work had already been done or whether it had not been done, or whether you should schedule that again, etc. And simply decoupling producer and consumer and having the consumer take the job, execute the job, and if it can't do the job, do that job again. That is creating higher degree of certainty about doing that work exactly once. And then if you find a bad job, and you can't execute that payment for some reason, then you can move them into what's called the dead letter queue for inspection. So for long-running work, having an intermediary, having these queues in the middle is an ideal setup and much more robust than using a REST call or RPC call. Then you may have situations where you have requests that are coming in at great variation. You may have tall spikes in terms of load. And what queues help with, and buffers also help with, I'm going to get to that distinction in a moment, is they act as an inbox for requests, and you have consumers at the end who are pulling those requests out, and they are processing effectively at their own pace. So because it's a push-pull translation, so instead of pushing work onto a worker which may get overwhelmed, you're rather pushing into an intermediary, you're pushing into a queue, and then you pull the data out, and that data is then being produced at the exact rate and the maximum rate that the consumer is able to do this. So the processing, the requests per second get capped exactly at the processing capacity of the consumer. And if you need high reliability, again, payments, or if you need to go and do inventory management, if you need to do serious transactional work, then you never want to go and overwhelm the system with more work than you can, and the queue allows for that kind of decoupling. We all know about the too busy errors that systems happily throw, and those too busy errors, if you think about microservices and think about 5, 10 microservices making up a system, if one call leads to the other, then very easily those too busy errors then kind of propagate back to the system, and it's really difficult to get back to that state. And here, through that decoupling, you effectively don't have those too busy errors, but you're really processing at the pace of the consumer. Obviously, that also means that work might be slower in execution. And for that, you can use some information that the queue gives you to scale up resources whenever necessary. So you may have multiple consumers who are consuming messages from that same queue. The queue assures that only one of those jobs is assigned at any time to one of the consumers. And every consumer only pulls data when it has capacity to process, which means you get real load balancing, right? When you think about load balancer in the sense of HTTP or by transition also for gRPC, because it runs over HTTP, you really think about a piece of networking infrastructure which sprays requests across a number of available parties. But it's completely unaware of how much capacity those parties have to actually do processing. The only thing is if it can observe, and that's something that the load balancer doesn't observe, but you observe from the outside, whether those systems come under stress, whether they have high CPU, high memory, and that's all quite a bit of black magic to figure out what the right load levels are. But here you actually have a measure of how much load there is on the system, because that's the length of the queue. If the queue gets longer, there is obviously work that cannot be served. And then you basically put a threshold in your system where you are calculating the average, and that's something what monitoring systems can do. And then you're adding further consumers. So if I translate this into things that happen in Azure, you can hook up our metrics that we emit, the length of a queue, to Azure Monitor. Azure Monitor can then go and raise an event if the length of the queue goes over a certain threshold, calls an Azure function, and the Azure function can then go and add a further consumer. And then, of course, when you add a lower threshold, the queue is empty, then you can go and take those consumers away again. There's an infrastructure that's open source called CADA for Kubernetes. It's actually working exactly in that way. And it can also be driven by, for instance, Azure Service Bus, but also by other messaging systems. Another pattern family or set of pattern families is when you have one message and then you want to have multiple parties have that message. That's something that is really difficult to do with an RPC model, because with RPC, you would have to go and have a list of URIs, and you would have to go and call them all. And of course, when more parties become interested, then you need to provide an endpoint where you can go and register those URIs and then keep track of them. Then the question is, what happens when you're can't deliver a message because that endpoint is busy? So that becomes very complicated very easily. So brokers have the capability to provide these publish and subscribe capabilities, where you are sending one message into a topic, you're effectively offering for a subscription, and then subscribers come in and are effectively pulling data out with those subscriptions. And with publish subscribe, every subscriber has the opportunity to obtain a copy of every published message. And often that's supported by filtering, where you can go and pick particular messages out for your own stream. And then one producer produces to a topic. It doesn't even know which subscribers exist. And then those consumers are then pulling those things out. Partitioning is also something that is popular. So publish subscribe is something you find in message brokers that provide queues typically. Partitioning is a model that you'll find typically in event stream engines. And that is not the same as publish subscribe at all, because partitions are chosen while publishing and not while subscribing. Partitioning is specifically there to allow a string to be subdivided so that it can store it reliably if the volume is enormous. The biggest clients, the biggest systems that we have, for instance, on Event Hubs, which is a partitioned event log, push far over 1 gigabyte per second. And that's something that's very difficult to store on a single machine. So we're splitting this out, we're partitioning this out, and then with that, you can have effectively a single thing, a single address that you can publish to, that can then be in parallel processed by many, many different consumers. Typically, because processing is much harder than producing, you also need to have enormous parallel processing at the back of those things. So partitioning is for parallelization of work. PubSub is for being able to pick messages out of those things. Those two things can compose, but if you have a contrast of Event Hubs or Kafka, they do partitioning, and Service Bus or ActiveMQ or RabbitMQ, they do PubSub. Then there's another form of multiple in and multiple out, and that's multiplexing. That's a feature that's available, for instance, in Azure Service Bus or also in ActiveMQ, where you are effectively taking multiple sequences by multiple producers, and instead of putting them into those partitions, you're putting them into one queue and you multiplex them through that queue. And that is typically used for scenarios where you have enormous numbers of different contexts. Think of games, sessions in a game like Halo, where you have millions of these sessions going on. Think about workflows and systems like SharePoint, again, where there could be hundreds of thousands or millions of sessions going on. If you need to go and effectively keep all those sessions together and want to make sure that only one consumer gets what's currently going on in that session, then you need those exclusive consumers. And those are things that we are supporting in the messaging brokers as well. The reason why you want to have these stateful, these event stream engines like Kafka or like Event Hubs or like Pulsar or like Pravega is that typically at the end of those, on the consumer side, is an analytics entity. And the analytics entity will try to go and make sense of telemetry or other events that have been pushed in. And they are looking at those and they try to make sense of them over a period of time. They want to go and analyze an average or a median value over the data that comes in. To do this, you need to build up state, because you need to collect all those events so you can calculate what the average or the median is. And so that requires that you have state. And it's a much easier model to pull towards state rather than push to a location and try to locate then where that state is, but rather you pull those things in. So the reason why infrastructures like Kafka or Event Hubs exist in the form that they do is that they allow then stateful processors like Azure Stream Analytics to go and pull the state towards a context and then aggregate state in that context and then produce results out of that stateful context. That's why they're using a pull model rather than a push model. And then in general, a further pattern is sparse connectivity for message brokers or for asynchronous messaging in general. You have a producer the producer is inside of a car, is inside of a mobile phone or a tablet app that is connected to a mobile network. That means often that unless you are in a super coverage area in the middle of the city, sometimes your wireless connection will be failing, but you still want to be able to go and submit some information. You still want to be able to go and collect telemetry. You still want to keep working, especially in IoT scenarios. There, it makes a lot of sense to have a local queue to go and collect that information in. And then when you have network, then you go and replicate the information out to the cloud. So instead of making a call and then failing when the network is down, you collect information locally, and then as soon as the network is back again, you leave it to the infrastructure then to go and replicate things out without bothering your application with it. To compose those, and with Edge and Cloud, there is a lot of scenarios where you need to have state synchronization, for instance, in scenarios in the IoT where you have multiple devices that need to go and talk to each other, but then also need to go and replicate that state for consumption in the cloud, for instance, into a digital twin. And for that, you need to have a broker, which is a PubSub broker where you can go and send the information in and everybody can get the same information out and everybody can go and synchronize their state. Then there's an analytics scenario, which we just talked about, right? You want to go and have local analytics capture. You want to eventually go and replicate this out to the cloud, but then you maybe want to go and use that already to do local analytics that you want to go and feed back into your application. Maybe also because the amount of telemetry that you're capturing over there is just a lot. And then there's common business workflow coordination. We all know that there's business branches of all sorts. There's medical clinics and there's law firms and tax advisors and all kinds of local businesses, of course, lots of retail and restaurants, which need to have local capabilities, which must be working even if the internet is down. So you need to have some local capabilities, some local broker that works there, but you also want to be able to go and get information from the cloud, like someone ordered something on the website, or a meal from the website. And information that you want to go and put into the cloud for further analysis. So all of those things are provided by integration flows based on messaging. Now, when we talk about messaging here in Azure Messaging, one of the things that's really important to us is protocols, and also to have standard protocols. We have a number of principles here. I'm not going to read them all to you, but generally, we prefer that protocols are vendor neutral and have a formal definition independent of any implementation. And we also believe that they must be under neutral guidance, governance, which means we don't do proprietary protocols. And we try to avoid proprietary extensions to protocols, no proprietary interfaces, no proprietary extensions, and if we have any, then we will promptly take them to a standardization venue. The standardization venues that we like are the big ones that also give us a way into ISO and IEC so that we can have international standards, because we have a lot of customers who are depending on building effectively on top of the independent standards that we work with. We also require that there's multiple competing implementations of the full protocol feature, so not just clients that work against one project server, but really we prefer protocols where there's multiple implementations of servers and multiple implementation of clients, because if that implementation gets effectively superseded in the community by something that's yet better because it's newer, then you should be able to move your payloads, your workloads, to that next broker, and neutral protocol that's feature rich is actually helping you with that. So based on that, here are some of the protocols that we prefer. HTTPS and the WebSocket protocol should be obvious. We're then preferring AMQP 1.0. That is implemented by Event Hubs, Service Bus, and IoT Hubs. And then in OSS, there's a large number of brokers that implement AMQP 1.0. ActiveMQ in various versions, Cupid in various versions, and then CNCF Strimzi has an AMQP bridge for the Apache Kafka broker. And then Eclipse uses that in IoT. That's kind of the open source counterpart for IoT Hub. And then Pivotal, RabbitMQ, even though their primary protocol is an expired older draft of the AMQP protocol, and they're also offering a very functional plugin for AMQP 1.0. And then MQTT is implemented in IoT Hub. It's a protocol that we're also invested in, and that is providing effectively PubSub capabilities for small devices. That's been written specifically to be super smart. It's super small to implement, and that combines and composes really well with AMQP. And then a new initiative that we've been helping with is CNCF Cloud Events, which aims to provide a common definition of what an event is. That has been developed by over 40 companies in the Cloud Native Foundation, and we've been implementing that on Azure Event Grid as a primary protocol, and other vendors are supporting cloud events as well, and it's also now gaining hold in the Cloud Native Foundation in the Kubernetes area. Some of the things that you can do if you're embracing AMQP, if you're coming along for the ride effectively, and why you should ask for AMQP from your preferred vendors, is that it gives you lots of integration opportunities. I can't explain those, also kind of a bit tight on time, but you see those integration opportunities from effectively Eclipse Mosquito through RabbitMQ with Service Bus, and then out to CNCF Stringy. Most of those routes work today because interop is real, and that's what standardization is for. And if you are just leaning on a protocol that's only supported by one broker with one particular pattern, then that's not going to get you there. And you see the slide that I put up earlier with those patterns. You can realize those on premises with ActiveMQ and the Qubit dispatch router, which comes together, for instance, packaged for Kubernetes on premises with the NMAS project. And that can then go and federate with Azure Service Bus. Similarly, Strimzy and the Qubit dispatch router, they can also go and federate in a similar way. And RabbitMQ can natively also federate with Service Bus with the onboard shovel, which I'm showing here. So there's a plugin that's part of RabbitMQ, which you can install, and together with the AMQP 1.0 support plugin. And once you do this, you can basically just go and configure a queue in RabbitMQ to be the source, and then a queue or a topic in Service Bus to be the destination, or an event hub, or you can also turn that thing around and you can receive from Service Bus and then send it to RabbitMQ and then realize the picture that I have here. And then with Qubit Dispatch Router, which I also mentioned, that is something that is a universal router, effectively. Think of that like a network router, but that's routing at layer 7 of the stack, and that allows to interconnect various AMQP products effectively as endpoints, while the Qubit Dispatch Router is pushing information, is effectively volatile in the middle. So the services that we have, and finally in the last few minutes that we have 4 core services: Service Bus, Event Hubs, Event Grid, and Relay, that realize the patterns that I mentioned. And we have a few extra services that I mentioned: IoT Hub, that's specifically for IoT devices. And then we have Notification Hubs, for instance, which is pushing information, pushing notifications out into the notification channels of mobile operating systems. And then we have obviously logic apps, which allows you to do message-oriented and asynchronous workflows. So why do we have 4 services? Well, you know already a lot. Service Bus is for pull-style queue-based transfer, so that's for queues. Event Hubs is buffers, so that's the client is determining where to go and receive from an event stream. The Event Hubs is also partitioned. And then Event Grid is a push-push translation, so that also has queues inside of it, but really what it's there for is to allow sending into Event Grid and then subscribing from Event Grid where to push to. So if you are doing synchronous calls, if you are exposing webhooks, then Event Grid can go and call those webhooks effectively on behalf of the sender, and we're effectively taking all the complexity of managing subscriptions into Event Grid. In a little bit more detail, event hubs, super large event storage, up to 2 gigabyte or more per second if required, separates events into partitions. The client is picking which offset from where to read that stream, so there's no queue that's kind of determining where to read next. And you can retain your event data from 1 to 90 days. If you want to retain your data longer, then you are probably having a use case for a database. Event Hubs also supports the Apache Kafka protocol. That's a choice that we made, even though the Kafka protocol does not fulfill our criteria, but we have a lot of customers who are coming with Kafka workloads, and so we're effectively meeting them where they are, and then also provide them with the rest of the features of our platform. Service Bus is for all the load leveling, load aware, load balancing patterns that I've talked about, mostly with queues, and also has the PubSub capabilities that I've talked about. Event Grid, as I said, push, ingests events, can also ingest events from a SaaS application, and then bridge effectively those events into subscriptions of other customers. That's called what we call partner topics or partner events, which allows you to do AAD-based, role-based access control from two sides of the system, even though they are crossing different subscriptions. And there we're implementing the cloud events, CNCF Cloud Events 1.0 standard, that will allow you to then use those events in a standard way. And then we have lastly we have the relay, and the relay is a little Swiss Army knife of communication, of network communication, because what that allows is you can expose a service or a database from anywhere, from behind a firewall, and we will go and create a WebSocket relay for you, and we will provide an endpoint in the cloud where you can go and connect that WebSocket, and then you can go and effectively stream across two firewalls, if you will, and make sure that you're finding each other. So that's something you also may want to go and take a look at. And that is what I brought for you today.
Thank you so much, Clemens. So we have actually several questions out on Twitter, but we're out of time for them. So
I'm very sorry.
No way, that's great. It was great. They're really great questions, and I'm sure we can spend a lot of time with them. So if you want to check them out under the hashtag .NETConf, some of them you are tagged with. I'm sure the people asking them will really, really appreciate that.
Great. I will certainly do that.
Great. Thank you so much. Well, everybody, thank you so much. We have Julie Lerman coming up talking about DDD and EF Core. We're getting her set up right now, and we'll be right back with .NETConf Focus on Microservices.
Go.
Hey, everybody. We're back with .NETConf Focus on Microservices. We got Julie Lerman talking about DDD. Take it away.
Hey. So I am, talking about DDD and Entity Framework Core and microservices. And a lot of people ask, well, how do you use EF Core with microservices, which to me isn't really a very interesting question because it's just using EF Core. What's interesting is about designing the microservices correctly, or in an intelligent way. And then once you've done that, then how are we going to implement EF Core? And my go-to when I'm thinking about architecting microservices is the lessons that I've learned from domain-driven design over a lot of years. So that's what I want to walk through here. Just make sure you understand this connection between microservices and domain-driven design. And then once you've implemented using DDD ideas, how Entity Framework Core helps when it comes to doing the mapping and persisting the data. And I'm just wondering why my screen isn't moving. Okay. So microservices and domain-driven design have a lot of guidance in common. So it's all about, breaking up your monolith or breaking down these big complicated problems that you're trying to solve with the software that you're writing. Once you've broken them apart, then it's also important to create boundaries around the different parts. So whether the part is microservice or we're talking about DDD bounded context, we're creating really kind of impermeable boundaries around them. And that's important because as you're solving the problems in one bounded context or microservice, the problems that you're solving there don't leak into another one and then make it harder to solve the problems of the other microservice because there's all this extra unneeded complexity in the way. Another bit of common guidance is in, I would say, a perfect world where you've got large teams, to have these microservices or bounded contexts developed in isolation and have different teams working on them so that they're really focused on them. And then another really important piece of guidance that's common between them is having a unique database for each microservice would have its own data store, not necessarily database, right? Just some way of persisting data. But they don't need to be intermingling. They just are independent. So they're really all created in isolation, right down to how the data is persisted. So once we've laid out some of these common guidance, then come the questions. And we've got a lot of the same questions as well. How do we figure out how to break these problems up into smaller problems? How do we figure out where those boundaries are? What do we do when we've got data that overlaps or types that overlap between services or bounded contexts? Here's one that creates a lot of stress for a lot of people. What about relationships that cross boundaries? And then once you've defined all this, how do you communicate across those boundaries? So fortunately, domain-driven design has been around since 2003 when Eric Evans wrote what we call the Blue Book, Domain-Driven Design, Tackling Complexity in the Heart of Software. 17 years. So there's been a lot of really great thinking and experience that's gone into how to really take advantage of the guidance of domain-driven design, which we can then apply when we're thinking about designing microservices. So I don't want to be presumptuous that people do have understanding of domain-driven design. So I'm going to do the quickest overview of my life of domain-driven design, because I think you need context so that you understand why I'm doing things the way I'm doing them once we start looking at the code and getting into EF Core. So domain-driven design, it's right in the name. We're not bearing the lead. The focus there is on the domain. So like thinking about EF Core and data persistence, right? We're not worrying about how EF Core is going to do its job and how the data persistence is working. You really want to focus on the problems of the business. Another really important piece of domain-driven design, just kind of an overarching theme, is about collaborating with the domain experts. They're the ones who know the domain, what the problems are, what they need to solve, right? And so it's a collaboration between the technical experts and the domain experts, not just up front, but pretty far through. When we're actually following domain-driven design, really breaks down into two different areas. One is strategic design, and the other is tactical design. And I do happen to focus a lot on the tactical because I talk about how entity framework comes into play. But I want to, again, just give you an overview of what these are. So strategic design is about analyzing the problem and modeling the business problem. So it's identifying these subdomains, breaking the problem apart, figuring out which of those subdomains is really your core domain. This is your moneymaker, what really sets you apart, because that's where you need to really have your laser focus. That's the most important thing. Some of the domains are still important to your business and kind of unique, and these can be supporting domains. And then it's also really important to be able to identify generic domains. This is stuff that maybe you don't need to waste your time figuring out, architecting and implementing, like third-party services that you can take advantage and then connect to. And then as you're doing this, you're also identifying the bounded context. They don't necessarily align one-to-one with a subdomain, but they're usually pretty close. And then the last big piece, there's a lot to it. DDD is a big topic, but the last big piece of strategic design is planning how all of these different subdomains and bounded contexts are going to connect with each other or even through some other service to make a connection to each other. I'm pointing to my screen. I always have to wave my hands for some reason. So before I go further, and this is a huge topic, and I just want to make sure you're aware of it, is that when I'm talking about DDD and bounded context and microservices, a lot of people make an assumption that a bounded context and a microservice are one and the same, that the boundaries around a bounded context equate the boundaries around a microservice. And in some cases, in a lot of cases, that might be true, but there are definitely cases where that just doesn't make sense. You might have a number of microservices within a defined bounded context, or for some strange reason, the other way around. So there's a lot of good information out there about that. I just want to get that into your head so that you don't make that leap, because a lot of people do. So once you've done your strategic design in 2 minutes or less, then it's time to get going on the actual implementation, which is the tactical design. And this is designing what's happening inside each bounded context. So the really critical concept here is that you're going to be working with an aggregate. You're defining aggregates. An aggregate is essentially a transactional unit of different entities that work together. And every aggregate has an aggregate root. This is really, really important. An aggregate root is in charge of what happens with everything else within the aggregate. So it's got all the rules for invariance and validation, et cetera, related to the various entities, properties, value objects that are within the aggregate. So that's really important. And as we get into tactical design, we're getting closer to where EF Core comes into play. So just to not be so generic about this, just a really good canonical example is if you have an order has line items, and line items really don't make sense on their own. They only really make sense within an order, and the order as an aggregate root can make determinations like you can't have more than $100 spent total, right? So it knows about all the line items. And we also have value objects, and I could spend quite a bit of time making sure people understand value objects. You can go find other talks or articles or writing that I've done about that, but I just want to make sure you're aware that value objects are different than entities. They're a different kind of a type, and you'll see some in the code that I'm going to be showing. So when we're designing aggregates, this is important, right? Because this is where the idea of, how, if we don't care about data persistence, then, how is the data going to get persisted, right? So what is it that we do care about? What we care about is that you're designing your models based on the needs of the business, the problems you're trying to solve. And it's probably an old joke coming from me now. Unless you're designing the next OneDrive or the next Dropbox, data persistence is probably not your core domain. So that's not your business problem. An aggregate root, as I said, it maintains the invariants and rules inside of the whole aggregate. Entities, when you design your entities, these aren't DTOs, right? We have rich behavior. They're really focused on behavior. When they're really just getters and setters, we refer to that as an anemic data model. And that's not a bad thing, but that has its place, right? And domain-driven design also has its place. Some of the helpful patterns that we use, for example, is to protect properties. We use a lot of encapsulation. I like to refer to it as ADD driven design, because I'm such a control freak. So you really protect your properties to make sure that nobody who's using your class can do things that you don't want them to do. They can't have effect on them that you don't want. And another important thing is to look for value objects. Again, this will depend on an understanding of them, but once you do, they're a really important part of the aggregate of your system. And just a little hint about them is, quite often when you think something's a one-to-one relationship, it's much more likely that it could be better represented and handled as a value object. And there's plenty of other things about designing aggregates. And also, there are things that while you're focusing on your aggregates, you just say, I'm not going to worry about that right now. And we have patterns in DDD to take care of those. And I'll use those patterns when the time comes. I don't mean I'm going to today in my short time here. So, drilling in closer to where we're getting to entity framework. So, domain-driven design, one of the big tenets of domain-driven design is to ignore data persistence, right? And we can. We're, focusing on our data model, not letting the problems of persisting the data or the problems of how your database schema needs to be or anything about the database. Like, just don't worry about that when you're creating your domain model. And what's nice is Entity Framework Core, and I'm not saying 100% of the time, right? But it is so rich now in terms of what it can do to help us map our nice domain models and create a data model with the DB context, like all the configurations and everything, create an in-memory data model and create that data model to closer represent how it can be persisted into the database and come back out. So that's an interesting thing. You can have an extra data model and have a mapper, or where Entity Framework will solve a lot of these problems of doing that transformation. We can use Entity Framework Core to define that data model that will allow us to take our domain model and make sure it gets persisted into the database. So, thanks to a lot of wonderful features in EF Core, and we get more and more features that enable us to do these kind of mappings as each iteration of EF Core comes out. So what I want to be able to do is show you a number of different features that allow me to take my nicely designed domain model and still be able to map them into the database. So we've got private field or private property support. We've got field mappings. We've got support for encapsulated collections. We've got a feature called owned entities, which lets us map value objects. We've got shadow properties, which are great for keeping track of kind of audit data that you don't want in your domain model. We've got value converters, so you can use .NET types, and they know how to persist the data. Keyless entities, new. And also, for those of you who have been waiting and waiting and waiting for many-to-many mappings, we're going to be getting them in EF Core 5. Up until now in EF Core, we've had to do those explicitly. So flip over here to Visual Studio. All right, so, actually, just so you know what I'm working with, so the aggregate root that I have is about team management. So I have a team management bounded context, and my aggregate is about managing the team. So I have a team entity, has a bunch of properties, team name, nickname, you're found at home stadium. So those are just scalar properties. Then I have a value object called uniform colors. And then I have a collection of players. And players have the player type has a property called name that itself is a value object. And I also have a one-to-one relationship between team and manager, since the team only has one manager at a time. And the manager also takes advantage of this value object called name. So what does this look like? So here's my team class. First of all, trying to do a little bit of nicely designed projects here, right? I got entity framework is outside of all of my business logic. And, it's separate, right? It has nothing to do with my business logic. So I can design all of my domain models and testing and doing all of that before even worrying about persistence, right? But now the question is, how is this stuff going to get persisted? How can I be sure if I design it beautifully according to all the nice things I've learned from DDD, and then it's time to persist the data? I don't want any surprises. I spend a lot of time actually researching as each version of EF comes out to see where we're at and what more we can do. So this, a lot of what's going on here, again, is protecting this aggregate from anybody doing anything to it that I don't want them to do. So when I'm instantiating, I have to pass in the team name, nickname, you're found in home stadium, right? And so that's the only way, these are the business rules. These are the rules that I determined, right? A team doesn't make sense unless it has those things. So why create a team that doesn't have those properties filled? So notice that this constructor, the parameterless constructor, is private, so nobody can just go ahead and instantiate a team with no team name or nickname in it. We need those things. Also, when I'm doing that, I'm also instantiating some of the other properties. So here is one thing you'll notice throughout this whole class is there are, except for these properties here, which are just kind of extraneous to this example. So they have getters, but I don't really care about those scalar properties, right? So all of the other properties that I want to protect, there are no getters here at all. So right off the bat, the key property, ID, I'm using an expression body to populate it, and I'm keeping track of that ID with this variable. And notice also, not only is the field private, which is normal, but the property's private also. Nobody needs to be reading the ID, right? So from outside, when they're looking at team, nobody needs to be looking at that, except Entity Framework will. And Entity Framework, so Entity Framework is able to see properties that have either a getter or a setter, but this has an expression body. So I've really messed this up as far as Entity Framework is concerned, but I've designed it the way I want to because I wanted to protect things. So here's the context, the DB context, and what I've done is, because this doesn't even have a getter or a setter, by default, Entity Framework won't recognize it. If it did, it would realize this is here. It would realize it's the key. It would understand that we've got this backing field here. But because I've encapsulated it even further, it's not going to see it. But all I have to do is come in here and say, oh, by the way, that ID property, that's the key property. And now it'll be happy. And it'll also recognize the underscore ID as the backing field. And by default, starting with EF Core 3, Entity Framework will actually, if it recognizes a backing field is tied to a property, it will automatically use that backing field when it's reading for saved changes, and also when it's materializing objects. It'll actually materialize the field instead of materializing the property. So the next thing I'm doing is encapsulating the team name. Now, my business logic for doing this is because I wanted to demonstrate another bit of mapping here. So, this is really protected. Nobody can touch team name. And, again, I'm using the expression body here. So this is a little different than with a GUID, because here at least the property is public because I do want people to see what the team name is. But because I don't have a getter, it's still, if this just had a getter, then Entity Framework would figure it all out. But again, I'm protecting it even more using DDD, or maybe ADDDD. So I can go in here to the DB context and just add a mapping. So one of the things I want to make sure you understand is I don't need you to memorize all of these mappings and properties. My bigger point is I'm designing this aggregate the way that I want to, in a really constrained way, and protecting everything. But Entity Framework is giving me all kinds of great configurations that I can get around and still be able to map things without having to worry about that. So in this case, I needed to explicitly let Entity Framework know about that field that's called team name. And the reason I'm doing it as a magic string here is because the field's private, so I can't use a lambda. So here's another example of encapsulation that is a pattern that we've often used with domain-driven design, but has always been had with up through EF6, had always been a big challenge to deal with persisting with Entity Framework. There was really no way to do it. And it was really frustrating because we found ourselves modifying how we designed our aggregate to accommodate for Entity Framework. So what I'm doing here is I have a collection of player objects, right? I'm not exposing the collection. And notice this is a field anyway. So the player's property is an IEnumerable. So people can access the players and they can read that players, but they can only enumerate through it. They can't add players to it and they can't remove players from it. However, as they're enumerating through it, they could grab a player and edit it. So what I'm doing is using a defensive copy, and I'm returning a copy of it by calling toList. So people are not working with the actual player, so they can't edit the player. So it's totally protected. Now, internally, I've got the players collection. That's where I can work with it. And then remember, I said an important thing about defining your aggregate is that we do it based on behaviors, not just DTOs, right? Not setting and getting properties. So if you want to add a player, I've got some rules that have to be applied. I have some specific logic. So I've got this add player method. And what this does is just make sure that a player isn't already added to the roster. So we're just protecting it from that. And then so it's totally protected. And I'm trying to remember off the top of my head if Entity Framework is going to recognize this. I don't even have to add an extra configuration for this. And the other interesting thing is the difference from EF Core 1 and 2 to EF Core 3 was before EF Core 3, materialization would have gone through here, but now it's going to go through this backing field. Another interesting thing I'm doing in here is the manager. So the manager is a one-to-one relationship, actually a 0 or 1, right? Because a manager could get fired and not be associated with a team. And again, I'm doing all of this protection here. There's actually no manager property, right? All I have here is the field. I don't have the actual property. And then if somebody wants to see the manager name, they have access to it. So if I want to modify a manager, I have to use a behavior. I have to go through this function, pass in the new manager, and then the manager class has some logic that says, oh, if we've already got a manager, then obviously we got to fire that manager before we can create this person as the manager. And we get some history happening there. So this, again, because, there's a lot of scenarios in which Entity Framework would figure things out, but I'm actually have constrained this so much that I needed to give Entity Framework a little help here. So if I go back to the context, where is it? Down here, I have a configuration to make sure that Entity Framework understands that that field, right? Because there's no property now for the map for doing the linking, right? But I can still use has one with the field that represents that relationship. And another interesting thing I'm doing here, this is actually not, this has been around since EF1, I think, is that the foreign key inside of manager is not named by convention, so I have to explicitly tell that. The other interesting thing here, and it took me a little bit to figure this out because I was like, what's going on here? Because I wanted that manager to possibly be independent, orphaned from a team if they're not managing a team quite yet. I needed to use this mapping to make sure that that was possible, because if we look in manager, we'll see that that foreign key is a nullable GUID. So let's see. So by the way, I'm not going to run them every single time. I have lots and lots of tests here to make sure all of these assumptions I'm making, all of the things I'm doing are working. So I've got a whole bunch of class tests for my domain classes just to make sure that internal logic is working. But I've also created a slew of in-memory tests with Entity Framework Core, and also some integration tests directly with the database, because there's a lot of things that in-memory is still not going to represent when it comes to actually testing a database. So it's really important to do that. There's a couple of other things I want to show you that are, my beautiful entity domain-driven design. So for example, value objects. I said I've got some value objects here. So person full name is one of them. Sure, I could have a first name and a last name inside a team and inside of, inside a player, inside of manager, but I've got a bunch of logic that I want to always have around somebody's name. Not only do I want to have a first and last name, but maybe I want to be able to expose it as the full name, like first name and last name, or maybe I want to have last name, comma, first name. So I can encapsulate that in here. And so that's a complex type. That's really all that is. But there's a few more things that make this a value object. One is that it's immutable. So the only way to set those first and last name values are when you're instantiating that. And also, these are really important pieces of a value object, facets of a value object. You have to be sure to override the equals and to get hash code for equality comparison, because it needs to compare all of the values. And the other important thing is there's no ID, no key value. Okay, so this can only be used as a property of an entity. And these are the pieces that make this a value object, the get hash code and the equals. But without those, that still aligns to the definition of an EF Core owned entity, that it's immutable, that it has no ID. So, and that it's used as a property of another entity. So the only thing is EF Core can't infer that, can't figure that out. So you have to explicitly map that. And that's what I'm doing here. I'm saying the player entity owns one, so it's an owned entity, and its property called name factory represents that owned entity. And then manager also has a property that is one of those owned entities. And in fact, the team has its own value object, or has a property that is a value object, which is these uniform colors. And I'm also specifying that the team owns one of the uniform colors. And while I'm doing that, I'm also doing something pretty cool. If you've ever tried to persist the color struct of a with Entity Framework into a database, you can't do it. We have to go through all this crazy stuff to turn it into text and then read it as text and turn it back into a color. So there's a feature called value conversions, and this has conversion property is one of the ways of expressing value conversion. So this is kind of an on-the-fly way. And this just says, so if we're looking at that primary property, which is a color struct inside of my uniform colors, right? So if we're persisting, for sending to the database, then use the name property of the color struct to get the text, and then you're going to store the text. And when you're reading it back out, you're reading text, and what we're going to do is use the color structs from name method to convert it back into a color struct. So these are all kinds of ways that I'm achieving being able to use Entity Framework Core, like sticking it in after the fact, after I've designed everything the way I want it based on domain-driven design. And then Entity Framework Core is able to handle these. There's all kinds of other examples. So for example, these shadow properties, I'm creating properties that exist only in the data model. They don't exist in my team class, my entity class. So I've got created and last modified as audit properties that I want stored in the database so that I can do reporting on them. So now I don't have to add that into my business logic. And in fact, during save changes is when I'm specifying the values, what the values of those should be as I'm about to do the save changes. So that is a lot. And as quick as I could do it, and I think I'm getting close to running out of time, or maybe I already have. And so do we have time for questions, or did I use up my whole 30 minutes?
You went a little bit over.
Me?
But yet, but we have a lot of questions out on Twitter.
I'm good on Twitter. I certainly want James to get going.
Perfect. So I was going to say, if you look at the .NETConf hashtag, you can find all the questions, and some of them you're tagged with. So thank you, Julie. This was really, really great.
Thanks so much.
You did amazing.
All right. Have fun, James. Good to see you. Bye-bye.
Bye. Thank you so much. Everybody, we'll be right back more with James Newton-King talking about gRPC on .NETConf Focus on Microservices. We'll be right back.
Live?
All right, everybody, we're back, and we have James talking about gRPC. Take it away.
Hi, my name's James Newton-King. I'm an engineer on the .NET team, and today I'm going to be talking about gRPC, a high-performance technology for communicating between apps and services. So let's talk about what gRPC is for anyone who's not familiar with it. It is a popular open-source remote procedure call framework. Remote procedure call frameworks make it easy for apps to talk to each other. There are alternative RPC frameworks out there, for example, Thrift, but we've observed that the developer community is really unifying behind gRPC as its RPC framework of choice. gRPC is run by the Cloud Native Computing Foundation, and Microsoft has been working on an implementation of gRPC for .NET that we have contributed to the Cloud Native Computing Foundation. gRPC is not new. It was open sourced in 2015, but it's built with modern technologies. It's a union of HTTP2 and protobuf. We'll talk more about the benefits of those technologies throughout this talk. gRPC is designed for modern apps, particularly microservices. It is very high performance and it is platform independent. You can think of gRPC as not one application, but it's more of a standard. It's a standard way of talking between computers. And then there are implementations of gRPC for different platforms, and all of them are interoperable with each other. So if you are building a .NET app and you want to talk to a gRPC service in Go or Node or Java, C++, Ruby, Python, pretty much every popular language has a gRPC implementation available today. Let's go into protobuf. In gRPC, protobuf serves three purposes. The first is it defines a language-independent way of declaring protobuf messages. Protobuf is a contract-first serialization format. So we can see here on the right, we have a basic protobuf declaration of a couple of messages. These are typically stored in a proto file. So here we have a subscribe request, which has a topic property of type string. Then we have an event with ID and details. This is a language-independent way of declaring messages. In protobuf, you can give this to different languages and they're all able to use it. This proto file was also used to define a service model. So the service is like the structure of the calls that people are able to make to a service. So here we can see we've got a topic service, which has a subscribe method. You can think of a service in gRPC like a controller in MVC and a method like an action. And finally, protobuf is the actual wire format. So when we're sending data between our gRPC services, gRPC will take our .NET objects and it will automatically serialize them into this binary format and send it across the wire. So interestingly, with protobuf, it is a binary serialization format compared to text-based formats like JSON or XML. There's pros and cons of this. A pro is it's very fast. Computers are good at reading and writing binary, and also it's very small. A con is you can't easily read it. So you need tooling and that contract file to be able to understand a protobuf message. So I think .NET developers, we're all familiar with building HTTP APIs, aka REST. So I want to talk about some of the underlying differences between remote procedure calls and HTTP APIs. So gRPC, it's an opinionated contract-first RPC framework. That proto file is really at the heart of a gRPC service. Meanwhile, HTTP APIs, typically the first thing you would start doing is you would start writing code to generate URLs, so setting up routing, worrying about HTTP methods and JSON. You think about the content first. And although you can create a contract for HTTP APIs, you might have heard of OpenAPI and generating one with Swashbuckle and .NET. That's like an optional step, while it's very much required with gRPC. With gRPC, the contract and that proto file was designed for humans to read and write. And this is important because the actual content is binary. So the proto file gives you a way to easily understand what you're sending and receiving. Meanwhile, with REST, the content is for humans. So you can look at an HTTP 1.1 message. It's all just based in text. You can look at JSON. It's also text. You're very easily able to read it and understand it. So that's good for debugging, but perhaps not so good for performance. And finally, gRPC, it hides the complexity of remoting. So that proto file is used to drive code generation. So we're able to generate a service base class on the server, and it will wire up all the routing and serialization logic for you, so you don't need to worry about it. And even better, it will generate a strongly typed client for you to call and invoke your RPC methods as if they were a regular .NET method, and then you just await the result. Meanwhile, REST, it emphasizes HTTP. So you're constantly thinking about URL routes, your structure of your JSON, and in the client, you're probably building up an HTTP request manually, although you can integrate with Swashbuckle and code generation and perhaps do it for you, but it is an optional step. So if I was going to sum up these two approaches, gRPC, it focuses on performance and developer productivity, while REST has the widest audience, like everyone can do HTTP 1.1, everyone can do JSON, and it's very easy to get started with REST. There's no code generation involved. So with that, let's do a demo of building our first gRPC service. So I'm going to launch Visual Studio, and we're going to choose to create a new project. Now, starting with .NET Core 3, we ship a basic template for gRPC. So we can type gRPC into our search bar, and a gRPC service comes up. We'll click Next, we'll click Create, and what we're doing here is we're going to create a basic Hello World app. It has a greeter service, which we send a name to, and then it will respond with a message containing our name. Okay, so now we have Visual Studio has set up our project. Let's take a look at the files we have. We've got our standard ASP.NET file, so we've got a startup file, we've got a program CS, we've got settings. We've got a couple of new files which you might not be familiar with. So we've got a protos folder. So this contains our proto contract, which we talked about. Here we've got our greeter service, which has a say hello method. We've got a hello request, which we take a name property, hello reply, which returns a message. Then in our services folder, we've got greeter service. So greeter service is our implementation of that contract on the server. So we override the say hello method. We're taking our hello request message. We're returning hello reply. And then within the actual body of the method, we're taking the name and we're setting it to the message. So we're saying hello to whoever called our service. So something which might jump out to you straight away is, where have these types come from? These are the only files we have in our application. Where has hello request, hello reply, and greeter base come from? So I talked a bit about code generation before. Code generation is really at the heart of gRPC. So tooling is able to look at this proto file, parse it, and generate files to allow us to very easily use and create gRPC services. So it's able to see we've got a greeter service, or generate a service base type, and it will generate basic DTOs for these two messages. And the way it knows to do that is there is this protobuf element in our project file. We're saying here is a protobuf file, and we want to generate a server base type because we're on the server. We specify server here, and then it will just automatically happen for us. And we can see this in action if we F12 into our message. We can see we've got our hello request, and we've got a message up here saying it was auto-generated for us. Although this is code generation, I wouldn't be afraid of it. I think there's good code generation and bad code generation. The bad type is stuff which you need to manually generate yourself. You need to check it into source control. You need to worry about people going in and modifying it and making it out of date. Meanwhile, good code generation, it all happens for you. Visual Studio and .NET will just ensure that any code generation is continuously up to date. As soon as we modify this proto file, it will be updated. We never need to check it into source control. Okay, so that's our service all set up. Let's create a client, because we need to create a strongly typed client to talk to our service. To do that, we'll just create a basic .NET app. In this case, we'll just create a console app. We'll click Next and Create. I'm running some preview SDKs on my computer, so I'm going to use 3.1. Let me just compile everything to make sure everything's working. Okay, so that works. So the first thing we need to do is we need to add our proto file to our console app, because both sides need to know about that proto file. To do that, there are a couple of different ways, but the fastest way in Visual Studio and Visual Studio for Mac is there's this Add Connected Service option when you right-click on dependencies. Once we click on that, we have an option to add a service reference. Anyone who's done WCF, this might look a little familiar, except instead of pointing to some WSDL, we're going to be pointing to a proto file. So we'll select gRPC in here, we'll click Next, and then we're going to browse on disk to our gRPC service, and we'll choose our proto file, click Open, and then here we have an option to say what kind of code generation do we want. Because we're in a client, we'll choose Client. And that will generate a strongly typed client for us to call our gRPC service. So a bunch of things are happening now. Basically, all that's happening is some NuGet packages are being added to our csproj file, and then the proto file is also being added. So here are our NuGet packages. So Google.protobuf, that's a serialization library. This is the client gRPC tools. This is the tooling, and then our actual proto file. And the only difference here is we're specifying client instead of server. So now that we've done that, let's go ahead and call our gRPC service. So first thing we're going to do is we're going to create a channel. So you can think of a channel, a gRPC channel, as like a representation of our connection from the client to the server. In this case, we're specifying our address of our local server. We're creating our channel, and then we want to create our client using that channel. So our client is a strongly typed representation of that greeter service, except instead of a service space, it's a client to call it. And if we F12 into this, again, we'll see lots of generated code that was all done for us. Now to call our service, and this is very easy. We simply invoke a method. So we're calling client.sayhelloAsync. Because it's async, I'll need to make this method async. And we're passing in our request. So like we had hello request on the server, we're also generating hello request on the client. We specify a name and we await the result. So an RPC tries to abstract as much as possible all the underlying mechanism of serialization and URLs and routing. The client does all of that for us. We're just able to invoke it as a method like it was a method within our local application. And finally, let's just write out to the console our result. So we should be good to go. Let me bring up our console, and we will call our console app and our gRPC service. So gRPC service 34, and we'll .NET run it. And then over on our client, console app 56. And if all has gone to plan, oh, we've got a bug here. Let me just compile to make sure everything's working. Give me one moment. Why is this not working? All right, we seem to have a brief issue. I'll back up to an older copy, which I know was working. Okay, so this one succeeded. So we've got our client and our server. Let's go to console app 55. And gRPC service 33. Okay, this time it succeeded. I've got some beta preview bits on my computer. which might have interfered when I created that new project. So here we can see our gRPC console app. It successfully called our server. So we passed in .NET Conf and we got a message back, hello .NET Conf. And we can see on the server we received our gRPC call, which we can see here. So it came in as an HTTP2 call to localhost. This is a standard gRPC URL, application type gRPC, and our server processed it. So now that we've seen how to create our very first gRPC application, I want to do a deep dive on gRPC performance. So gRPC benefits from the performance improvements that have been made in HTTP2. And one of those performance improvements is more efficient use of TCP connections. So HTTP 1.1, typically whenever you make concurrent requests, each one of those is going across on its own TCP connection. HTTP2 adds the ability to do multiplexing. So multiplexing allows you to make multiple concurrent independent calls via one TCP connection. And a good way of looking at this and seeing it for yourself is within a browser, taking one image, splitting it up into 100 small images, and then attempting to download it using each protocol. Only a couple can be downloaded at a time via 1.1, while with HTTP2, all of them are downloaded at once, and it's much faster. Another key benefit of gRPC is its low network usage compared to REST. So it achieves this in a couple of ways. One is it uses HTTP2's binary framing and header compression. So HTTP2 is able to take headers, which it sees have been sent multiple times in a request and response, and rather than send them with every request and response, it just sends a couple of bits. So it's able to make some significant savings there to header size. The bigger contribution to low network usage is protobuf message serialization. So it's a contract-first binary format. So here we can see some JSON on the left and a protobuf contract on the right. Because both the client and the server have the protobuf contract, we don't need to repeat all this information with every single call. There's no point us sending query and saying query is a string, page number, results per page. Like both sides already know this information. So having the contract on both sides allows us to remove unnecessary information and just focus on the actual data itself. So although these two bits of text look about the same size, the actual content that's getting sent with protobuf is just very small binary. Someone in the community measured the difference between JSON and protobuf, and at least in their case, they found that protobuf was between a quarter or a third the size of JSON. Now, your mileage may vary. It will depend upon what data you're sending, but generally protobuf should always be smaller. So I've talked about why gRPC should be fast in theory. Let's look at some real-world numbers of gRPC versus RESTful APIs, in this case, comparing against MVC. Now, with both MVC and gRPC using HTTP2, just for consistency, I observed gRPC was 25% faster. And if we use a advanced gRPC technique called bidirectional streaming, it is 140% faster. So streaming with gRPC is when you're able to establish a single request and then simply stream data backwards and forwards. So you eliminate the overhead of creating a new HTTP request every time you want to talk to the server and having the server parse that incoming HTTP request. You're just dealing with the gRPC message data. Now, this doesn't work with every scenario, but if you really care about performance to the extreme, it's something you might want to explore when you're using gRPC. Let's look at gRPC versus some other implementations. So we found with measuring gRPC on .NET 5, it either equaled or exceeded Golang. Also in this graph, we can see grpc.core. So grpc.core was is a slightly older implementation of gRPC for .NET. So the way it works is it wraps a native C++ implementation. And probably why it's slower is it has the overhead of both that .NET code and then the C++ implementation, while gRPC ASP.NET Core is fully managed. These numbers, we can see we're getting 600,000 requests per second under heavy load on one machine. These are using traditional unary calls, so that's a traditional request and response with gRPC. If we explore using that bidirectional streaming to eliminate some of that overhead, we can get over 1.5 million requests per second, which is pretty impressive for a single machine. Although that machine has pretty good specifications. So finally, let's look at what work went into gRPC to get these good numbers in .NET 5. So the biggest improvements came from optimizing HTTP2 and HTTP client and Kestrel. So that's stuff like reducing latency, removing allocations, improving concurrency. These improvements are great because they benefit everyone who is using HTTP2 in .NET, not just gRPC. Kestrel now fully supports HPAC compression. So it supports taking large response headers, and if they're repeated multiple times, compressing them down to just a couple of bits. That just saves on network usage. The .NET client, HTTP client, and Kestrel now support keep alive pings. So keep alive pings are a technique for keeping a connection warm. So perhaps you might have an application which doesn't have much usage over an hour, and any TCP connections are closed. As soon as you make a call, you have the overhead of creating a TCP connection, doing a TLS handshake, establishing an HTTP2 connection, and finally actually making your call. Keep alive pings can be used to keep connections alive and warm so that when you want to make a call, they're ready to go. We're working with the protobuf project to support span. So when protobuf serializer supports span, we'll be able to eliminate the need to allocate byte buffers when serializing and deserializing protobuf. And finally, we're adding support for additional transports. So gRPC should be able to be used over named pipes and Unix domain sockets when you're doing inter-process communication on a local machine. This offers performance benefits over using traditional TCP. And that's all I have for you. This is a very brief introduction to gRPC. I have documentation available if you follow this link. I hope everyone gives gRPC a try. It's very easy to get started, and it offers great performance improvements and many other improvements I haven't talked about. So hopefully I've got some time available to answer some questions.
Yes, James, you do. We actually have one question. Let me share that screen in a second. And actually, it's a pretty big one, is which ways of authentication does gRPC support?
So gRPC, it uses standard HTTP. And because it does that, and because our implementation of gRPC integrates with ASP.NET Core, you can use pretty much all standard existing authentication mechanisms when you're using gRPC. So some examples are you could use JOT tokens, you could use client certificates, so that's mutual TLS authentication. The one exception to authentication that you can't use with gRPC is you can't use Windows authentication. Windows authentication is limited to HTTP 1.1, and because gRPC is 2 or above, you're not able to use that as an option.
Well, that's great. So essentially, any middleware that I may have right now as part of my ASP.NET Core application, whether it be custom or something out of the box, would just work right on top of gRPC.
I think so. I would assume it does. Like, obviously test it. But yes. I think yeah, because gRPC, although I talk about binary this and like huge efficiency gains, like it's still just running on HTTP2, which is very similar to HTTP 1.1. Like there's still headers, Like if you've got an authorized header and you're passing it along, any existing middleware will use it. And because we integrate well with the ASP.NET ecosystem, your existing middleware should just work.
Sure. Actually, I have a question. We can make it brief here. Is that from like a load balancer perspective, right? So I have my applications behind the scenes. Would I run into any issues with using gRPC, or because it's using HTTP2, it should just forward those across?
There is actually one interesting issue with gRPC and load balancers. So I talked about multiplexing before,
yes.
and how you can like just have a single TCP connection and all your requests will go via it. Load balancers, especially like low-level load balancers, the way they work is they'll get an incoming TCP connection, they'll forward that to one computer, they'll get another TCP connection, they'll forward it to another. If all your requests are going via one TCP connection, all your load will go to one computer. So like there's the idea of level 4 load balancers, which work at that level, and then level 7 load balancers, which work at a higher level and are able to support sending individual streams, so individual requests over HTTP2 to different computers. So if you're using something like gRPC, you might want to use something like Envoy or perhaps YARP to take your, you would make calls to that proxy load balancer, and then it would be responsible for sending requests to different computers.
Yeah, so that way you can sort of fan out those requests and actually get the best performance out of the scalability that you've built in.
Exactly.
Perfect, great. Well, I don't see any more questions that we have. James, thank you so much for taking the time to talk to us. I'm really looking forward to playing more with the gRPC bits and .NET. And for those of you watching the stream, we are actually going to kick off right next to a video. Our next speaker, Jessica Dean, couldn't make it because of vacation and other things that got in the way. So we got her talking about DevOps, waffles, and superheroes. So Jessica Dean's video is coming right up.
Hi, my name is Jessica Dean, and I'm a senior cloud advocate at Microsoft. I'm super excited to be here today to hang out and talk about DevOps, waffles, and superheroes. Oh my. And we're going to have a bunch of fun doing it. Now, just a brief disclaimer before we dive right in, because sadly we only have 30 minutes together. I want to let you know what this session was designed to do so that you know what you should expect. First off, this session was not designed to make anyone an expert. Sadly, even though it's a superhero talk, I don't have superhero powers to do that in 30 minutes. But the session was designed to get you thinking, to show you some of the things that's possible, maybe things that you aren't even aware of if you are familiar a little bit with Docker and Kubernetes and microservices. It's also designed to get you excited, right? To get you pumped up. And then at the end, there will be resources where you can go and learn more. Now let's go ahead and dive right on in. First, let's level set. What exactly is DevOps? Now, as it turns out, you could ask 5 different people what DevOps is, and you would get 5 different answers. So I want to make sure that I share Microsoft's definition of what DevOps is. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Continuous delivery of value. The most important word on this slide is value, because if you're not delivering value, what are you doing and why are you doing it? And more importantly, how do you know if you're delivering value, right? How do you gauge it? How do you have telemetry? Especially in the world of abstraction and distributed systems and maybe decoupled applications or hybrid applications, things start getting very confusing and hard to follow. So we're going to hopefully try to simplify that here. Now, starting with simplification is actually how Kubernetes came to be. So if you happen to have been snapped by Thanos' fingers and you're wondering, what exactly is this Kubernetes? It kind of sounds like it can be a candy. It's not. It was originally actually built in partnership with Google. It was based on a system that they had used for over a decade now called Borg. And it's an open source container orchestrator. It was designed to automate deployment, scaling, and management of your applications. In short, it was designed to simplify automation, but it's quite complex and it's quite robust. And so we'll talk about other tools or other products that were designed to help simplify the simplify. First, let's do a brief overview of what the Kubernetes architecture kind of looks like. You have a self-managed main node, or nodes. You can have multiple main nodes. This makes up what's called your control plane. You have things like your API server, your etcd for your database, you have your scheduler, you have your controller manager, your cloud controller. All of this stuff lives in your main nodes or in your control plane. And that control plane communicates to your agent pool, where you have a Docker engine, you have your pods. Pods can have multiple containers, and these are what's running your workloads or your applications. Now, there's a Kubernetes API endpoint that you communicate with, you as the user, through some sort of workload definition, be it a manifest JSON file, a YAML file, or a Helm chart. And we'll talk about Helm in just a second. But you define the way of the world you want it to be, whether you want all of your microservices deployed in one namespace, and we'll talk about what that means, or whether you want it deployed in a different, whatever orchestration you want it deployed, you define that. You send that over to the Kubernetes API endpoint, and then the main node or the control plane will then go ahead and schedule that and release that out to your agent pools or your worker nodes. These are the machines that's going to run your applications and your pods. Now, this is a lot to manage, in particular because you'd also be responsible for everything in that control plane because it's self-managed. You're responsible for hardware updates, for software updates, canonical upgrades if you're running, again, a Linux Kubernetes cluster, which chances are you would be. Now, in a managed control plane, meaning that a cloud provider takes care of that for you. This is how Azure Kubernetes Service works. Azure's managed control plane is managed then by Azure. So we remove some of that burden. Now, all you have to worry about as the user is to write your application, describe the way of the world you need it to be, send it off over to Kubernetes, either with Kubernetes apply or kube control, kubectl, whatever pronunciation. That's the binary you use to interact with Kubernetes. Or you would use Helm to install. Either way, you send that over to the API endpoint, and then Azure's control plane will go ahead and distribute that to your agent pool or your worker nodes. Now, I keep mentioning Helm. Kubernetes itself is a little over 6 years old, okay? So there's been a lot of changes, a lot of things that have kind of come out to help make it easier. An interesting fact is Helm is almost as old as Kubernetes. So it is the de facto package manager for Kubernetes. You can think of it like pip, like NuGet, like apt. It's just a package manager that was designed to simplify the simple, okay? It actually came out of a hackathon project in October of 2015 by a company called Deis that Microsoft later acquired. And now we have contributors from several major companies, all contributing to make Helm a success so that everyone who's using Helm, Kubernetes, Docker, the world of microservices can have a more simple time managing your YAML files or your manifest files. And of course, so you don't have to worry about tabs or spaces errors. Now, let's go and do a quick walkthrough using Visual Studio Code to kind of see some extensions that we can use or have in VS Code to help simplify this. How we can work with Helm charts, how we can work with Docker, and what exactly Helm charts or templates look like if you're new. Also, what do Docker files look like? Maybe we'll take a look and go line by line and kind of get a little bit more familiar with this. Let's check it out. So I'm currently in Visual Studio Code, and let's just take a look at a Docker file. You can see that I have lines here that says from. In fact, I have from on line 6, I have from on line 14 right here, and I have from again on line 24. This is what's called a multi-stage Docker build, because a lot of times what you need at build is not what you need at actual runtime. So this first block of code, 6.2.12, is actually building the React component of this Tailwind Traders application that we'll use throughout today's session. This next block of code, lines 14 through 22, is building the .NET Core component of this application. It's a hybrid front-end application, .NET Core and React. And then we're copying the output from those two stages over into this final stage where we're only using the runtime for .NET Core to actually run our web front end. Now, the cool thing is we can integrate right very easily within VS Code by using the terminal, and we could just do something like Docker build. And I had previously built this, so this would build really fast. We could also do the command palette and search for Docker, and we could see that we have some Docker commands. Now, these commands are brought to us because we have the extension marketplace. So you can see right here, if I search for Docker, here's my Docker extension. I can search for Kubernetes, And I have an Azure Kubernetes extension. This is also another really helpful extension when you're working with Kubernetes. You can also see I have local process with Kubernetes, which we'll talk about in a little bit. And we also have perhaps one of my favorites. We have the Azure, let's see, I would have to do @installed and then do Azure. I have the Azure account extension as well. Now you can see on the left-hand side here, here's where I have access to my Kubernetes clusters. I have a local Docker Kubernetes setup. I have Azure Kubernetes Service. If we go back over to our files, we can also take a look at our Helm charts, just so we kind of get some familiarity with what exactly Helm is. So we can drop down into web, and you can see I have a templates directory and a values file. Let's just click on this values file here. And you'll notice we have image, repository. Some of these have indents, right? Two spaces or one tab. And if we drop down on one of the templates and we click on deployment, you'll notice that there's a lot of references to values. That's because this is referencing that values file. So as opposed to having to manage multiple YAMLs files, that's one of the benefits of Helm as a package manager. It's simply a template engine that's going to then parse in the values that you specify accordingly right here in your all-up knobs and dials. All right, so I hope that was really fun. Now you might be wondering, again, if you got snapped by Thanos' finger, this is a superheroes talk, you might be wondering, that was really cool. I kind of am following all this YAML stuff and this YAML business, but I'm still not 100% certain what a container actually is. I understand that there's Docker, but I thought Docker was something different than Kubernetes, and all of those are really great questions. I am so glad you asked. First off, I'll hear a lot of people try to explain or compare a container to a virtual machine. And that's not really true at all, because it's not a virtual machine. It's not even a real thing. Instead, it's an application delivery mechanism with process isolation, right? Its only goal, a container's only goal, is to deliver your application and isolate the processes needed for your application. And it's based on several key Linux kernel features. So if you come from a traditional Windows background, certain words like namespaces, which I mentioned earlier, and C groups might be unfamiliar. C groups is what your process can use. That's hardware. That's things like your memory and your CPU. Namespaces is what your process can see. That's things like your mounts, and it's just things that your processes needs access to. Okay, an easier and more delicious way to think of a container is to compare it to a waffle. And here's why. Now, this picture on the screen is a little misleading because there's still butter and syrup. So let's take the butter and syrup off and imagine that it was just a plain waffle. How many of you like to eat waffles completely plain? And I know there's going to be just one of you, and more power to you. But for me, I like to have my waffles with as much fun as possible. I want whipped cream, I want blueberries, I want strawberries, I want pecans, I want syrup. It's no wonder why I have to hit the gym, which is even harder now in quarantine. But I want a whole bunch of stuff baked into my waffle because that waffle is going to be the delivery system to my stomach, and I want it to deliver value. Remember, the definition of DevOps, continuously delivering value. I want it to deliver value or happiness to my life. So if we think of the waffle in comparison to a container that is just a delivery mechanism, and all you're doing is putting the processes or the toppings, whatever you need to make that delivery mechanism valuable, that's all it is. Container is just a waffle. Now, let's do a quick recap on how Docker files work. We kind of ran through this when we were looking in VS Code, but let's make sure we fully understand how a Docker file is structured and what its intention is for. A Docker file defines the steps that you need to configure your container's environment. You use it to build your container image. You start with a base image. That's just the base that your process isolation or your application is going to need. You can set working directories, and then you can copy files from your current working directory from wherever you're building this Docker file. And we'll talk about that copy period in the next slide. You can build that over into that work directory you just specified. You run the commands you would normally run locally from your system. In this instance, we're running pip install, and you give it a requirements file. You can expose ports. You can set an environment variable for your port if your application has a process environment variable. You can set environment variables for anything, even build arguments if you want to be able to pipe something in at build time. And then finally, you would run your application exactly as you would locally on your system, Python app py in this example, but you just give it a command to run, and now your application is running in that containerized, encapsulated runtime environment. Now let's talk about how Docker build actually works. It's going to build the image according to the steps that you define. And you'll often hear something called Docker context. Context is the set of files in the specified path or URL. That's sometimes where you'll see the Docker build period, but people don't understand always what that period is. It can be confusing. So let's take a look at 3 examples. We're going to use an application called Tailwind Traders. Let's say that I'm in my home directory, Tailwind Traders website, and I run a Docker build source Tailwind Traders web command. That highlighted section is my context, which is why I can run this command and not need that period, because I'm already in Tailwind Traders website, and then my Docker files and my application files live in source Tailwind Traders web. That's the set of files in that path or URL. And then -T stands for tag, so that I can give my image a tag rather than just alphanumeric characters. Now this command will have the exact same effect as the command beneath it for Docker build -F. That's for you're giving it a specified file for your Docker file that has the set of instructions. And then what follows that is going to be where the set of files for those instructions live. In this instance, I specify in a very explicit sense that the file is source Tailwind Traders web Docker file. And then the .source Tailwind Traders web is the set of files or the path where everything from my application lives. Now, both of these 2 commands will have the same exact effect as this bottom command. The only difference is I have changed directories and dropped down into the source Tailwind Traders web. And now I can use the examples you'll find online, which is Docker build period, because now I'm in my PWD, or I'm in the current working directory where my Docker files and my path or my context files live. I specify the Docker file. This is helpful if I want to use multiple Docker files. Maybe I'm working on dockerfile.develop or dockerfile.net core 3.0, whatever I want to name it. I can have different Docker files and correspond with different paths for where those different versions live. This is helpful in development. All right, now I mentioned earlier that containerization is different from virtualization, right? A container is not a virtual machine, and here's why. There's 2 different types of virtualization. You either have your host operating system sitting on top of your infrastructure, and then your hypervisor sits on top of your OS, or your hypervisor sits directly on top of bare metal in virtualization, type A and type B. However, in both of those scenarios, you still have independent virtual machines. Your independent virtual machine is going to have its own operating system, its own dependencies, its own application deployments, and it's not immutable, right? It's not portable. VMA is going to differ from VMB and C and vice versa. However, in the container world, it's a little bit easier. It's actually a lot easier because you just have your host operating system on top of your infrastructure. You have a container runtime layer, which in this example on the right of your screen is Docker. We're using Docker for our container runtime. And then you run your containers with all package dependencies and your application right alongside it. So now that container becomes completely immutable, can't be changed, it becomes portable, and it becomes a lot faster, right? Because virtual machines are quite large. They can be 20 gigabytes plus. This can be a couple of megabytes. The smallest container image is 5 megabytes for Alpine. It's significantly smaller, which means it's significantly more fast. Now, let's just do a quick refresher on how container layers work in case you're still, again, Thanos' finger, maybe you're a little new. You can think of container layers like a cake. And here's why that's important to think of it like a cake. When you have your Docker file, you start off with your from, you maybe set a work directory, you expose a port, you do .NET build, .NET restore. Each one of those lines or commands is an image layer and it's read-only. Sometimes, and I've seen this happen more than once, I've done it, we accidentally forget that anything that's read-only gets baked into your container, just as it would get baked into a cake. So think of that in the sense of if you accidentally bake in a connection string, a password, an SSH private key pair, something like, and it happens, right? We've all done it. And so we want to be very mindful of what we're baking into our cake. Anything that happens on top when the container is running is read writes. So if we happen to have some sort of malicious code and there's something baked into our cake, that malicious code could theoretically gain access and do something compromising. So we really want to be mindful of how our containers are being built and structured. Now, we've highlighted on some of these, but we're just going to run through this again. Here are some big benefits of using containers. For one, you have repeatable builds and deployments, right? Because now I have something that's immutable and portable. I don't have to have it works on my machine, it doesn't work on your server. We don't have to have that argument. It works wherever I put it. I can build a container on my Mac, I can run it on Linux, I can run it on Windows, right? It becomes something that's more portable and repeatable, so it gives me an added sense of reliability. I also have a significantly faster starter time, right? Because we talked about how much smaller it is. Also, with reduced size comes a smaller attack surface, so it also offers a potential for greater security. You can also package your dependencies, as we mentioned, not you can, you do. You package your dependencies alongside your application. And this is my favorite right here. As we've mentioned, containers run everywhere. And depending on where you're watching this, I like to say in the States that containers are kind of like Oprah. If you have a Mac, you get a container. If I have Windows, I get a container. If I have an IoT device, you get a container. Raspberry Pi, you get a container. Everyone gets containers, and they all work. It's absolutely fantastic. Now, I want to talk about this Tailwind Traders application that we briefly touched on, just the structure of that Docker file, but I want to talk about how it works. So you have your little user that's going to go and hit the Tailwind Traders website. And Tailwind Traders, by the way, is a fictitious storefront where you can go and buy homed goods. You can buy, coffee tables. You can buy kitchen tables. You can buy coffee machines. You can buy garden gnomes. You can buy a lot of really fun stuff. And you would hit the web front end. Now, this is something that's deployed on Azure Kubernetes Service, so AKS. And there's 11 different microservices. We only have a handful of the ones that you don't see some of the mobile stuff happening in the background, but we have a handful of the ones that we're going to be working with today on the screen. So our web front end is a hybrid application. It's kind of a mix of .NET Core 2, .NET Core 3, there's some React in there. And then there's the backend framework, which has various APIs. You have a coupons API in Node, you have a stock API in Java, products API in .NET Core, popular products in Go, a profile API in .NET Core, right? We have a lot of different APIs. Now, the hard part is when we do start getting into this world of containers, from a developer standpoint, especially when we're just trying to understand Docker files and Helm charts and all of this, where do we go, right? How do we sit here? All I want to do is I want to debug this API, but I need to see it in the context of the larger application. And I'm still really new to this microservice world, so I'm not really sure how to debug this or have insight into this. This is probably one of the most common questions I get asked. By the way, we also have a products API and a shopping cart API. There's a bunch of different APIs. So right here over on the bottom left-hand corner, you can see I have my developer workstation. This is going to be what we're going to work with today. And I'm going to focus on the cart because I've just been informed that we have a bug in our shopping cart. Whenever somebody goes to try to buy an item, no matter what the item is, they get a garden gnome added to their shopping cart. And so I'm going to show you how you can use VS Code to debug your application, even your single API, if I'm only working on cart, which is written in Node, even if I would have to normally hit that web front end. So I'm going to actually have my own little isolated environment as a developer where I don't need a Docker file, I don't need a Helm chart, and instead I could just replace that cart API, not in a production scenario. I replace it in my own isolated environment with my own isolated FQDN to be able to start testing things out and fixing it. Let's check it out. So I'm currently working within the cart API, and I'm using the local process for Kubernetes extension, which allows me to debug on my local system without needing to worry about Docker and Helm charts. So let's go ahead and check it out. First thing, we can drop down and you can see I have a shopping cart model right here that we're going to be working with. Let's take a look at the problem. I'm going to go ahead and click on the little Kubernetes down here at the bottom, and I'm just going to choose to route over to my ingress controller. We're going to go drop something into our cart. You can see that I've already tried this a few times. We'll just drop this wooden table into the cart. We'll simply click on the cart. And it seems that every time I try to shop, I get a garden gnome added. So let's see if we can debug this without having to worry about Docker and Helm charts. The first thing I'm going to do is I'm going to use my same local debugger, my launch program, which would just launch this particular API locally on port 3000. Only instead, I'm going to launch it with Kubernetes, and I'm going to do so isolated. So what that means is once this starts up, it's going to redirect the service traffic, but it's going to isolate that service with my own prefix. So I'll be able to start working and debugging this in my own specialized environment, in my own fully qualified domain name that's not going to interrupt any traffic on the actual root domain name. All right, so you can see this line right here. It says the container port 3001, which is actually what we're exposing in our Docker file. And you can see that right here in Docker file, we're setting an environment for port, and then we're exposing that. That's now available at localhost 3000. So now that that's available, let's go ahead and click on shopping cart. And you can see I have an initial sync call. I'm finding email. I'm starting to query the Cosmos DB that we have in our application stack. And I have right here on line 51 an add item call or function that's actually, again, when I'm adding an item to my cart. So I'm just going to set a breakpoint right here on line 53. I'm going to click Kubernetes down here at the bottom, and you'll notice I have now my new isolated, fully qualified domain name with a prefix of Jessica D and some random numbers. I'm going to click that, and that's going to take me to my very own URL right here, right? We can see Jessica Dean 7091, and then this was the actual root domain. So this is going to be my own environment where I can start to see what's happening here, and I can actually hit a breakpoint. So I'm just going to add this microwave. And just like that, I hit my breakpoint, you can see right here. And now I can hover over this and I can actually see the detail of what's being sent. You can see here's the detailed product. Sure enough, it's sending a single red garden gnome. Now let's go over to our debugger and see the call stack. You can see the add item is part of it, process ticket, and then there's another add product, which is actually a different file. Now this appears to reference this shopping cart add item right here. If I scroll up a little more, I see the actual add product, and I see that I'm also supposed to have request, and it looks like myself or another developer had actually hard-coded a body call to test something, and unfortunately that got pushed into production. I don't know why we were choosing a red garden gnome, but I think we were checking to make sure that this function was working. So rather than having item equal to body, I want it equal to the request, to the body request. So I'm going to save, and just to be safe, I'm also going to comment out this other const, and we're going to go ahead save that. Now I will restart the debugger, and we'll close this cart controller. Let's go and double check. We'll leave our breaking point right now on our return. Let's head back on over here. We'll refresh, and we'll retry to add that item to our cart. And I left the breakpoint because I want to see what the actual call stack is. So we hover over this now. And if we click on our detailed product and drop down, I now can see that microwave is actually being sent, right? So it looks as though we've resolved that. I can click continue and see what happens. See, it looks like microwave has now been added. Let's go take a look at our shopping cart. And it looks like now we're finally seeing our microwave. We'll go ahead and clean this up. We'll clear out all our garden gnomes and our microwave. We'll do it one more time. There we go. Now I'll remove this breaking point here. Okay, well removed. Go ahead and refresh. Head back over to kitchen accessories, go back to coffee maker, click add to cart. And there we go. Now I see coffee maker red has been added to cart. So I'm fairly confident in all this, but how do I have my same team have the same level of confidence? And this is something that's really cool. The same functionality that is built into VS Code is actually part of just Kubernetes on Azure. So for example, if I check this into a special branch, I'm on Jessica Gnome Fix, and I'm just going to say Gnome Bug Fix, and I'm going to go ahead and commit, and I'm going to push. We can head on over to GitHub, and there's actually a PR workflow that will start once we open a pull request. So I'm just going to click open pull request. We'll make sure I'll move it into my repository. So I'll go from my Gnome Fix over into my main repository. I'll create that pull request, and a workflow will fire off. Now, the cool thing is what happens when that workflow fires off. Not only do I have an isolated environment, but there will actually be an isolated environment set up for this pull request. So everyone now on the team, whether they're a designer, whether they're a developer, whether they're operations, whether they speak code or whether they don't speak code, will still have the same level of confidence. You can see right here as it's starting to go through the build setup. It'll do a bunch of different things. It'll do Docker. It'll actually install via Helm. It'll set up routing labels. It'll handle everything as per this extension. And once it completes, we'll see our bot comment right here. There we go. You can see that the private version has been added. And if we zoom in here real quick, you'll see that now my prefix is actually equal to the name of my branch. So everyone gets the same level of confidence that I get from my local VS Code experience. All right, so that's probably one of my favorite demos to do just because it's so awesome. Again, it's probably one of the lowest barriers to entry because you don't need a Docker file, you don't need a Helm chart. Instead, all the code when you're working in the isolated environment redirects over to the code running locally on your system. There's actually no container involved, but you're still able to work with containers in Kubernetes from a traditional developer approach and have confidence in what you're doing. And more importantly, you get to share that confidence with the rest of your team, as we saw. Now, some helpful tips as you move forward in your journey. Again, this is a superheroes talk, so we're going to quote Gemma Simmons' Marvel Agents of S.H.I.E.L.D. The steps you take don't have to be big. They just have to lead you in the right direction. You don't have to leave here today thinking you're going to go master Kubernetes and Docker and you're going to write the next Helm operator or whatever. We don't have to go big, and we don't have to go jump and deploy Kubernetes. And sometimes Kubernetes might not be the answer. But if you are working with it, we have now learned some tools. We have the Docker extension, the Kubernetes extension, the local process for Kubernetes extension. We have learned small steps we can take to help lead us in that right direction. Also, ask yourself as you're moving along this journey, as you're building your Docker files, as you're crafting your microservices, is what you're thinking of adding in, is it going to add value? Remember, your end goal is, it's just a waffle, right? Your goal is to try to continuously deliver value and have that delivery mechanism. So ask yourself, does it deliver value? Or does this add unnecessary complexity to where there's not going to be any return? At the end of the day, it is just a waffle. So just keep it super simple. Some final recap points on some Kubernetes best practices, especially if you are moving into the Kubernetes world. We've focused on the value of building small containers, but it's also incredibly important. You can utilize multi-stage builds where often what you need at build time, for example, the .NET Core SDK, is not what you need at runtime. You can have the SDK compile your output and then copy that over and just use the .NET Core runtime at your actual run. That'll make your image significantly smaller. You can also consider your application architecture. Use namespaces, use Helm charts, utilize role-based access control. Not everything in your cluster or in your environment needs God mode. You can implement health checks. These are liveness and readiness probes that ping your HTTP for your pod that tells whether or not the pod is up and gets a 200 response or whether it's 404 and then it can report an error. There's some sort of crash loop back off, something like that, right? We want to implement health checks to where we know whether we're healthy or not. Another best practice is to set resource requests and limits. This is the bare minimum of resources or C group information, CPU, memory that your process needs. Your application probably doesn't need 2 gigabytes, right? The bare minimum might be 100 megabytes of memory and it maxes out at 512, whatever it might be. Set resource requests and limits appropriately. And then finally, be mindful of your services. Not everything needs to run inside your cluster. I'm a huge proponent for using database as a service, things like Azure SQL Server or Azure Cosmos DB, and you can link those easily over into your cluster. You can also not rely on load balancers. You can use proxies. Load balancers are expensive, both from a time management perspective and cost management perspective. So you can utilize various application routing methods to ingest traffic in through an ingress controller and then utilize routing in your cluster on the back end. Finally, my name is Jessica Dean. Thank you so much for hanging out with me. I'm here because, frankly, I love technology, I love community, and I love hanging out with engineers like you. I focus heavily on Linux, open source, DevOps, containers. Feel free to reach out to me anytime to talk about that, or we can talk about Disney, CrossFit, whatever you want. My last name is spelled with 2 E's, D-E-E-N, so there's no relation to James Dean, and you can find me on GitHub, Instagram, and Twitter. Finally, thank you very much. It has been my absolute pleasure to hang out with you today. Cheers.
There you go.
All right, everybody, we are back with .NET Conf Focus on Microservices. We got Labrina on talking about API communication and microservices. Take it away, Labrina.
Hey, everyone. So I'm Labrina Loving. I work at Microsoft, and today we're going to talk all about API communications with microservices, and we're going to do that using a couple of services in Azure, specifically API management and Azure Functions. So, quick agenda for today. We're just going to do a quick microservices refresher. I know everyone that's been listening to the conference now is probably an expert, but thought it'd be good we do a quick refresher. We'll kind of talk about some of the problems with microservices, and then we'll focus on why serverless microservices is a good idea. We'll talk through our true services we're going to focus on, API management and Azure functions. And then we'll do the thing that I'm sure you all came for, which is the demo, and do some resources and wrap up. So I know we've been talking a lot about microservices throughout the day, but just to level set, microservices are independent modules that are very small. They're small enough to take very single actions. So you really want to think about, when you're thinking about microservices, building a single focus, a single concern. They can be independently built, they can be monitored, refreshed, all independently. So you could have a team, a distributed team that's working on various microservices in different languages, using different tool sets, whatever works best for them. So microservices have autonomous scalability. That means that they can scale at different ways depending on the needs. So imagine that I have a couple of services, one that does a get very often, and then another one that does updates and delete, and a separate one that does delete. Imagine if I had those three services, the get service, microservice probably will get called the most. So it can scale up very quickly and then scale down, but our delete and our update might get called less frequently and less have less calls. So we can scale that as well. Isolating points of failure. So each of the services can be managed independently. So finding points of failure is a little bit easier in the microservice architecture, because each service will return their own set of failures, and you'll be able to see very quickly where failures lie. And as I kind of alluded to, what I really like about microservices is that often in very large teams, you have different developers with different skill sets. You might be bringing in legacy code that's in different technologies and languages. And with the microservices architecture, all of these tools and technologies can coexist within teams. And then that brings about the ability to get to market faster. So let's talk about the problem with microservices. So in a microservice architecture, each microservice exposes a set of very fine-grained endpoints. So if you look at my graph to the left, or visual to the left, I've got these individual microservices that each have their own independent endpoint. And then they're being called by a client app in the front end. Mobile, it could be a mobile, it could be a web app, it could be anything. The challenge here is that oftentimes this mobile app needs to call various microservices. It also might need to call microservices that are dependent on one another. So how do we handle chattiness across our applications? And then also, how do we handle things like cross-cutting concerns, like security or SSL offloading? And this approach with our kind of direct client to microservice communication, each of these microservices are handled independently, and it sort of brings about a lot more chattiness. The other approach, which is a lot more reasonable, is doing what's called an API gateway pattern. So in this way, we actually have a single entry point that's controlling communication to our various microservices. and acts as a facade. That way we can mock out different services as they become available. We can also do things like do cross-cutting concerns. So within my API gateway, I could have universal policies or universal tools for things like logging, for things like security concerns, all within the same kind of single pane. And that handles a lot of our kind of communication headaches. In a sense, this API management or API gateway acts as a facade or a reverse proxy that routes requests from the client application to the backend services. Okay. So we're kind of combining two really nebulous terms, serverless and microservices together. So serverless microservices, let's kind of break it down. So serverless is a really can be a confusing term. It can be read in that most people, when they think about it, they think, oh, hey, there's no servers. But indeed, there are servers, just like in cloud, there are tons of servers. So serverless actually means not that there aren't any servers, but it actually means that we focus less on servers and more just on the functionality. So it allows developers to actually focus more on just building functionality and less on worrying about things like compute. It basically abstracts away the servers, so you don't need to worry about compute or scaling or sizing or things like that when you're building out your solutions. And in addition, when we talk about serverless, we often talk about what's called event-driven. So building things in an event-driven approach gives us the ability to migrate some problems from very traditional approaches. It allows us to scale compute resources. It allows us to remove operations dependency. So oftentimes when deploying a microservice-based solution, there's usually a strong dependency between what our operations teams do for allocating our infrastructure resources and execution and incremental changes. So taking a serverless approach gives us the opportunity to use fully managed services and removes the necessity for all the kind of underlying infrastructure that's managed by your platform that would typically happen. And then the last thing that we kind of benefit from with serverless microservices is that managing services and communication and integrations are really common issues or problems in a distributed application. So how do we manage and monitor communications across a distributed application? So since each of these services kind of are performing a specific action, according to this single responsibility principle, more often than not, services will need to communicate with each other to achieve a goal. So we have this challenge of how do we make sure we can monitor each of those services together. So with an event-driven approach, with services discovery, you have a centralized and unified way of communicating with services and events. You can do things like publish and subscribe to events, as well as having things like triggers. So instead of something waiting, service waiting, it actually can be triggered based on a number of actions that could happen. And we'll talk about some of those services that help aid in that in a little bit. Okay, so the first main service that we're going to talk about that we're going to utilize in our solution is API management. So API management really helps organize the publishing of APIs, both within an organization, or if you're publishing a set of APIs externally to make them publicly available, it also aids in that. So API management provides a set of core competencies that ensure that you have a very single, centralized manner for managing APIs. So you can do things like have a secure infrastructure. So you have gaining access, preventing of denial of service attacks, doing thing by using things like reducing throttling, or you can set up securities in place like JWT token for validation. It also, as I mentioned before, supports having public-facing APIs. So you could have a universal pane for all of your public-facing APIs. You can have universal policies that support things like security. You can also do things where you can, as I mentioned before, support throttling. And then in enterprise organizations, you can use API management as a way to support having a centralized location for all of your APIs to make them easily discoverable for your organization. So how many times, and this happens even internally within Microsoft, we have so many services, we have so many APIs that are sort of all over the place and they're not easily discoverable to the organization. And API management can be a place where everyone publishes their APIs. They could easily be protected, and then also they could easily be versioned as well. So as new versions of your API roll out, you can actually have ways to version it, determine which version is available. You can support multiple versions of your API as well. Okay, so Azure Functions is really kind of one of our main services for building out serverless applications. Azure Functions allow you to run just small pieces of code in the language of your choice. So you can use C#, Java, JavaScript, Python, or PowerShell, or you can do both. So I've been on development teams where we had, for various reasons, we had functions that were built in C#, and then we had a couple of functions for other reasons that needed to be built in JavaScript, and they needed to coexist. So we definitely use a microservices approach and architecture for dealing with that. The thing with functions is that they are event-based and event-triggered. So functions are triggered in a number of different ways. So they can be triggered by an HTTP request, which is primarily what we'll show in microservices architecture in a bit. They can be triggered in a schedule. They can be triggered based on things like Cosmos DB updates or changes, blob storage, queues. What other ones do I have? Event Grid, Event Hub, Service Bus queues, and even Service Bus topics. So one of the things that I also really like about functions is that typically functions are designed to be stateless, meaning that they're designed to be called one time. They perform a small bit of code, and then they spin up, and then they execute the code, and then they spin down. What you can also do is you can actually use stateful Azure functions, which actually durable functions that actually can maintain state. So if you have a long-running event pipeline that needs to maintain state, and you want to be able to execute several tasks as that state changes, durable functions are a good choice for that. And we'll talk a little bit about that in the architecture that I'll show. In addition, Azure Functions provide integrated security, so you can secure your functions using Azure AD. And then there's tons of integration into other services within the cloud native ecosystem. Okay, so let's talk about a demo. One of the things that I have just started doing recently is I've gotten into podcasting, and I had been looking for a good podcast platform, and unfortunately, I really haven't found one. I mean, I found kind of parts and pieces, but I've never found a really good one that does all the things I really wanted. So I thought it'd be cool to actually start building out my own podcast using microservices and functions and API management. So let's take a look at the architecture that we're building out. And this is somewhat based on my own desires, but also very loosely based on some work that I've done at a couple of customers as well. So we actually have a podcast site that is running in App Services that is communicating and authenticating users using Azure Active Directory B2C. As we kind of talked about with our API gateway pattern, we're using API management as that single entry point for our web application to enter and call whatever services, whatever microservices that it needs. Then I've got several microservices that are hosted. And one of the things I'm doing is hosting it within a VNet to ensure a virtual network, to ensure that to be able to ensure that only certain services are able to communicate and I have true networking. Then I've got a couple of Azure functions that are my microservices. So I've got an episodes API, I've got a host API, and I've got a guest API. Then I've got some durable functions in the back end that are maintaining state as I need to publish an episode. So you can imagine if once you record an episode, that episode has to get uploaded. And then there's several processing steps that happen. We're doing things like translations and other things. So I'm using what's called a durable function here to publish that episode and get it ready to be distributed to our different podcast outlets like Spotify or Apple Podcasts. Then I've got another durable function over here that will do scheduling for guests. So then I've got some cross-cutting concerns at the bottom using Azure Key Vault for any secret management, and then App Insights for any monitoring that I need to do across all of these different APIs, which is really key here because as we were talking about, I've got a lot of services that are kind of working together, and I want to be able to monitor and make sure and have observability in all of those services. Okay. So let's take a look at just at a high level. I'm going to walk you through my Azure function that I have set up. I'll walk you through one. A lot of them, the other ones work very similarly, but I thought I would just kind of walk you through setting up the Azure function, how it would work, and then how we would deploy it. And then I'll show how it actually gets imported into API management so that it could be made available for our web application. So I've got an Azure function here, my episode function. I've got a function called episodes get. And this basically is just retrieving all of the episodes from our, I forgot to mention, our data store for this example is Cosmos DB. So it's retrieving all of our episodes from Cosmos DB. I've got a service. So I've got a model defined called episode. Let's go here. Yeah, so I've got a model defined called episode. It's just defining things like the name, the title, publish date, any show notes. Then I've got a service that's running in the back. That's an interface. Let's go to the concrete. That basically so I've got an interface defined for a service that defines all of the methods that I want to do, like get ID, and then things like translate. And then if I look at my concrete class for episode service, it's I've got a data service that's defined that basically is handling all the communication back to Cosmos DB. So if I take a look at that data service, here's my Cosmos DB service. That here's an example of the get. It's just a querying and getting my collection type. So I'll just do a quick debug just so you can see what happens when we debug our services in Azure Functions. And you can see the core tools are starting. And you can see it's defined a couple of services. So my get by ID, and then I've got an upsert one that I've defined. And then you can see I'm debugging locally. It's defined this on localhost port 7071. So I could try to right now run this. So I had some breakpoints set up. We'll get rid of those. And then should be coming back soon with my set of episodes. Cosmos DB might be gone. Let's see. Anyway, I think my Cosmos DB might be dead. Oh, also I'm missing that breakpoint. Why are we not running? Anyway. Oh, so here. So here's like just my set of episodes. So here's my set of episodes or that I've returned just using my API. So what I'll do next is just show how we would deploy, how we might deploy this. Oh. Well, so I am actually in my Azure portal. I've actually stood up already some app services. Normally what I would do is actually have use continuous integration and continuous deployment with something like Azure DevOps or GitHub Actions to deploy my code from Azure, from my source control into Azure. So here's my podcast episodes, Azure function. You can actually see here's my 3 functions that I've got defined, and they're here. So I could do things like code and I could test right in here. I could do things like monitor as well. So you could see some of the results that I've got. The important key that I wanted to show now, so now that I have my Azure functions deployed, I could then actually now use API management, as I said, as that single pane to single point of entry for all of my functions. So if I go into APIs, I've already imported my podcast episodes. So you could see here, I've got these already defined. I could go here and define policies, and we'll walk through creating a sample policy in a bit. I can do things like test it. I could add revisions. So if as my functions get revised, I could actually go in and make changes and maintain those revisions right within API management. The other thing that I really like about API management is that one of the techniques that we use sometimes is that you can actually create mock APIs. So I could mock, let's say my episodes set of functions are available, but maybe my kind of bigger API durable function for translating doing speech to text translation of my podcast isn't ready, because that's going to take a little bit more work. So I could go in here and create an API and then also mock that out while I'm still developing, which is incredibly powerful, because then that kind of allows the rest of the development team to keep working while we're kind of working in the back end on that one microservice. So if I wanted to add the other set of APIs, when I click Add New API, I'm presented with different ways I can import an API. So I can import APIs from OpenAPI. I can do import an API from Logic App or App Services. And then I can also, as I'm going to do from a function app. So then I can click and look for my function apps. I've got quite a bit out there. So here's my podcast host. So I'm going to import that one. And then have that ready. I didn't deploy that one yet. Okay. So cool. And then, as we talked about before, I'll switch back to I'll switch back to the PowerPoint. So, as I was mentioning before, one of the things that we can do with having kind of our single point of entry is that we can have authentication run across the entire our entire set of policy, our entire set of microservices, and so therefore I can offload that work from each individual development team that's developing microservices and move that work just at the API management, API gateway layer. So here's an example of just an authentication policy that I set up that, and you can set up through API management, that basically valid checks for a validation token based on OpenID config. I can pass in that and it will validate that, and it will validate that across all of my microservices. The opposite point, or the other option that I would have to do is that then I would have to use something in my Azure function to authenticate each function individually, or I can do things like add what's called a filter attribute that would filter each call at the function layer. But I prefer this if possible because it's just a lot cleaner and it kind of gets our developers out of that way. Yeah, so good. So just to wrap up, there are some really great resources to getting started with Azure Functions and with API management. There are some really good examples that I show that are based on the example that I showed today. One is the serverless microservice reference architecture, and another one is an example that my previous team built for a customer as well. Okay, so I think that's all of the content that I have. I don't know if there are any questions or anything. I'm happy to take those.
I was going to say we are actually out of time for questions.
Oh, okay.
So since we're right on, so thank you so much, Labrina, for taking the time. If you want to check out Twitter, I'm sure people are going to be asking those questions as they come along. So we are trying to get here our next speaker, Elton Stoneman, who's going to talk about evolving monoliths with .NET. So yeah, thank you so much, Labrina, for taking the time to talk to us. And everybody, will be right back with more .NET Conf Focus on Microservices.
You're live.
All right, everybody, we are back with Elton Stoneman talking about .NET Framework monoliths with .NET 5 and Kubernetes. Take it away, Elton.
Thank you very much. So hi, folks. Thank you for joining. My name's Elton. I'm a Docker captain and a Microsoft MVP. I've been working with containers since like 2014. But before that, I spent most of my career as a .NET consultant. And I would have been watching a conference like this today and thinking, like, this stuff's great. I totally get the advantage of microservices. But I'm going to work tomorrow with my big, ugly monoliths, and none of that stuff appeals to me. So This session hopefully is going to try and convince you that these patterns still apply to you even if you're working with an old monolith. So what I'm going to be talking about is taking these kind of big .NET framework monoliths, running them in Kubernetes, and then taking these microservice architectures and using them to evolve your architecture without doing a full 2-year rewrite of your application. So I've got a whole bunch of demos, got a few slides to kind of wrap things around. So the first thing I'm going to talk about is the approach. Now, I've been working with clients for the last few years, and a lot of people are really keen on this approach of, I've got these old .NET apps, they're my core business apps, so I want to keep running them, but I want to move them somewhere else. I want to run them on a modern platform. And then you get this kind of 3-phase approach, and I'm going to walk you through that in the next 25 minutes or so. The first one is the lift and shift, right? I've got my application running. I'm going to package it up so it runs in a container. I'm going to run that thing in Kubernetes. I'm going to spin up an AKS cluster that's got some Windows nodes and some Linux nodes, and I can run my 10-year-old application without any source code changes. And that's hugely beneficial. Now, people will tell you it's an anti-pattern, and certainly it's not microservices, right? There's a conflation between containers and Kubernetes and microservices, and they're not necessarily the same thing. Like, containers are great for microservices are great for containers, but you can run any old huge application in a container. You just won't get all the benefits of a microservice architecture. But by doing that lift and shift, and we'll see that in my first demo, you still get some serious benefits, and you're in a really good place then to start evolving that architecture. So phase 2 after the lift and shift is to kind of identify one of these boundaries that would make sense as a separate service and put a facade around it. So it's not a full-on microservice, because you can't always do that first time round. So it maybe doesn't encapsulate its own data, it doesn't own its own data, but you bring this kind of facade over some of the existing business logic, and that becomes your first kind of microservice. And then the final phase for that is to take the next step of making sure you do encapsulate that service. So it owns its own data, the monolith calls into that service. The only way to get the things you want from that particular part of the application is to call in through the microservice. I'm going to walk through all that stuff today. And this is just a kind of a very abridged list of why that stuff is important. So you've seen all the talks about microservices today. You've seen people talking about boundaries an awful lot, and people have different interpretations about that. And I think that's really cool. So the very first session, Scott and David were talking about the team boundary, this idea that these small components can be worked on by different teams and that you can distribute the work. And that's great. There are other kind of aspects of the boundary, but there are a couple of things that I think probably haven't been highlighted so much. But they really apply when I'm in this position of, I've got this old monolith, I want to do something with it. Why do I want to potentially move to Kubernetes and to microservices? Well, the first goal is I want a modern platform to run these things on. Like, I've got a bunch of Windows Server 2008 VMs in a data center somewhere, or I'm renting some machines from some non-standard cloud. I want to have a platform where I can run these things that's new, that's current, that's being evolved all the time and having new features, and it's portable. So I can run that stuff on my laptop as a developer. I can run it in my data center. I can run it in the cloud. It's the same thing everywhere. Really appealing to a lot of people to have a consistent way of deploying this stuff that's new. The new technology stack business, don't underestimate that, because as I'm talking with clients and people who are getting interested in Docker and Kubernetes, they get really excited by this stuff. And that's great, because I've been doing this for a long time, but I still get excited when the new release of Kubernetes comes out, when there's updates to Docker Desktop. If your team's enthused because they're doing some new stuff with new technology and new approaches, then happy team's going to produce better software. So don't underestimate that. And then coming back to that boundary point, so we've talked about team boundaries and the various levels of isolation that you get. It's not just about the runtime isolation. There's a boundary around release cadences. So if I've got these separate components, I can deploy them independently, scale them independently, and secure them separately. So if one of the demos I'm going to show you is making a part of the application publicly available as an API. Now, that's a secure boundary if it's within its own microservice, and there's no reason why, if somebody manages to break into that microservice, they can get to any other component. It's a security boundary around that particular application. Okay, so that's enough of the stuff. So I'm going to show you a bunch of stuff. All my demo code is all up in GitHub. That link in the bottom right there will take you to my demo samples that I'm going to walk through. The architecture of the first thing I'm going to deploy is the old .NET Pet Shop application. So it's a .NET 3.5 application. I got the code off of Codeplex and I put it into GitHub. I made one very small change, which you can read about if you want to, but fundamentally it's the same code that hasn't changed since 2008. So I packaged it up so it will run in a Windows container, and I've got an AKS cluster in Azure that's got some Linux nodes and some Windows nodes. Now, although this is an old monolithic application, I still want to do it properly with all the Kubernetes patterns. So the stuff that you heard Jessica talking about, I've got ingress coming in. So if you're not familiar with Kubernetes, I'm just going to kind of focus on the important parts here. So hopefully you won't get lost when we come to all the YAML specifications. I'm going to pick out the things that I think are important here. So the ingress pattern in Kubernetes is I have one thing where all the traffic from the cluster comes into this component called the ingress, and that routes it to different applications that are running. The benefit of that is that I have a single entry point, but of course other things can be put into that ingress. So I'm going to be using Nginx, which is a super popular, super performant reverse proxy. It can do routing, it can do caching, it can do sticky sessions, SSL termination, a whole bunch of stuff. So even though I've got my old .NET monolith that's sat on a Windows container in my Kubernetes cluster, I'm still fronting that with a brand new modern ingress approach. And my application itself, it's .NET 3.5. It runs on Windows Server 2019. But the way I model it, the way I spec out how my application is going to run, is with exactly the same Kubernetes API that I use for my brand new .NET 5 application, that I use for my Go applications. The API specification is exactly the same, apart from a couple of small things that I'll pull out. All the huge benefits that you get from Kubernetes, you still get with your monolith. Like, you haven't got all the flexibility. You can't scale up super quickly. There are other things that you can't quite do because you've got this great big lump sitting in a container, but you get a lot of the benefits of Kubernetes. Okay, so that's enough of the slides. I'm going to cut straight to my demo. So if you follow that link that's in the slides, you will get here on GitHub, which is my kind of cheat sheet for my demos. Everything that I'm going to walk through is all in here. So all these tons of YAML, I'm not going to go through it line by line because I'm going to painfully run out of time. But all that stuff's there if you want to investigate it yourself later on. In the Azure Markdown directory folder, that's everything I did to set up my cluster, which is just a bunch of AZ commands that create the cluster and add Windows nodes. Okay, so let's clear myself some space and open my terminal here. So I've already got my cluster running. If I look at all the nodes that are in my cluster, and if you're not familiar with this, the cluster is just a single entity that contains a whole bunch of servers that can run containers. I'm looking at those servers in Kubernetes are called nodes. I've got 4 nodes in my server. It happens that 2 of them are Linux, 2 of them are Windows. So it's I talk to it as one big unit, and it decides where to run the containers for me. Now, if I look more closely at one of those nodes, which happens to be one of my Windows nodes, Kubernetes has this kind of abstract label idea where I can apply any kind of key value pairs to all sorts of different objects. Nodes themselves have these labels that AKS applies for me. And there's a couple of things I want to point out. So one is it knows the operating system is Windows. So for this node, Kubernetes knows that it's a Windows node. And also it has this notion of topology. So these are in different availability zones in Azure. So kind of think of that as different racks within the data center. And Kubernetes knows that too. So as I'm telling Kubernetes to run my application, I can ask it to spread them around, to make sure they run on Windows nodes, to spread them across different availability zones. I can capture all that inside my Kubernetes spec. So as we're looking at the YAML file and you're thinking, like, there's a ton of stuff in here, that's why. You can do all these sorts of really cool things in a platform agnostic way. Okay, so let's have a look at this. First thing I'm going to do, I'm going to be deploying stuff, and then I'm going to walk through what we've got. So I'm going to deploy my ingress, which is the thing that listens for all incoming traffic. So it's going to run Nginx in a bunch of pods. Again, if you're not familiar, a pod is just it's the abstraction of the runtime in Kubernetes. It's the process abstraction that runs your containers. So it's going to start Nginx in a pod with a whole bunch of other things. I'm going to look very quickly at some of the definitions there. So inside here, I've got, this is a configuration file. So my Nginx configuration, it comes with some kind of standard config, but I want to add caching to my proxy so that I can cache responses that come back. And the way I do that is with this thing called a config map that just contains a whole bunch of stuff which gets injected into the container file system. So when Nginx starts, it builds up its configuration model. It includes these pieces that I've specified, and so I get a kind of custom config in. So I've got caching enabled in my reverse proxy. And the other thing I've got in my service definition, so this is a service in Kubernetes is the networking abstraction that receives traffic. This in here it's a load balancer, but because it's working in Azure, I've already created a public IP address in Azure. I know what the IP address is, and I can include that in my Kubernetes manifest. So when I deploy this, My AKS cluster knows my public IP address is there. It creates the load balancer. It wires everything up for me. So it's all just kind of super simple. So Kubernetes has this nice abstraction where it can, everything is kind of the same. Like your Kubernetes cluster is the same as mine, but there are integration points where the clouds can kind of take advantage of stuff like this. Okay, so those are the few things I'm going to point out. There's a lot more stuff in there, as you can imagine, but those are the kind of main points. So if I look now at the pods that are running, what I should see is I've got 2 pods that are already up and running. One is on node 1, one is on node 0. They're both Linux nodes, so they're up and running in Linux. That's fine. If I look at the service, what I should see, this is the IP address I requested. So that's bound to my public IP address. There's a load balancer there. It's distributing traffic across the nodes in my cluster. When they receive them, they come into my Nginx pod, and that's going to do stuff with them. Nothing yet because there aren't any apps there, but that's the ingress part. That was the green part in my diagram. Okay, so now I'm going to deploy the pet shop. Now, I'm not going to go through all the Docker files and stuff, but in the links here, it's in a separate repo. You can go and follow through, see how I've packaged up that .NET 3.5 app. It's just a pretty standard Docker file. There's not too much in there. That IP address isn't going to help me, so I'm going to deploy it now. And again, same thing. While this is all spinning up, we'll go and look at some of those things. There's a bunch of stuff getting created here because the modeling language in Kubernetes is super expressive, and you can do all sorts of interesting things. What I'm creating here are some configuration rules, some secrets, which again are like config, but they contain sensitive data. I'm creating my ingress rules that we're going to go through in a second. All those things are separate resources that all, as a whole, make my application. So if I close this down again and go and look at these files. So this is my configuration for my web application. So it's ASP.NET 3.5 app. It uses the XML configuration model. What I'm doing here is I've got a secret, so there's sensitive data in here with all my connection strings. So just like you could way back in .NET 1. Whatever, I've got my web.config file, and I can break sections of that XML into separate files, and that's what I'm doing. My Docker image is bundled with a web.config file with a bunch of common settings that expects to find a connection strings.config file with the connection strings in it. In Kubernetes, the connection strings config file comes from this secret, so it gets injected into the file system container, just like with the Nginx, but this happens to be XML, so my .NET app can read this. I've got these ingress rules, which are what tells the ingress controller to route traffic to my .NET web application, and it's slightly verbose, but the key thing here is I'm doing it based on a domain name. So any request that comes into my cluster, it comes in on that IP address. The ingress pod picks it up. If the host request is petshop.6i.com, it's going to send it to the backend website, which is my ASP.NET website. There's a couple of other things in here. The old Pet Shop app isn't really stateless, and it kind of needs you to keep browsing to the same pod all the time. So I've got sticky sessions enabled with this annotation, which just tells the ingress controller that for these routes, send a cookie back to the browser. When you get that cookie back, route the request to the same pod. So as I scale up, I'm keeping sticky sessions. Super easy to do with just this. Don't need to change my code, don't need to change my application at all. The other thing I've got here is another ingress rule, which says it's the same endpoint, so it's the same host, petshop.6i.com, but these are for the images. So there is no point asking a .NET 3.5 app to render a bunch of images when I've got Nginx that can do that for me. So what I'm doing here is I'm applying the cache for these particular routes. So when the requests start flowing through Nginx and the responses come back to Nginx from my app, the images get cached and then they'll get served from Nginx the next time, reduces a whole bunch of load going to my application. So it'll perform better for the real requests, which are the dynamic pages. Okay, and the last thing is the application itself. So this is the deployment spec. This is if you're not familiar with Kubernetes, this is just a big lump of YAML. And if you are familiar with Kubernetes, then quite possibly it's just a big lump of YAML. The reason I've got this stuff in here, and I'm really, if you saw Jessica's talk earlier, I'm really glad that I did this because I've covered all the best practices she said you should have. What I've got in here is I want to show you that this is a monolith, right? This is my 12-year-old application. All I've done is package it to run in a Docker container, but all those best practices still apply. So things like I've got in here my readiness probe, which says it's going to test the application inside the container, and Kubernetes won't send traffic to it unless it's ready to receive traffic. So it's just a nice little health check thing It helps my application be self-healing, and I don't need to do anything to my code for that. I'm just like pinging the home page every 20 seconds. I've got also in here, I've got my my resource requests. So that says my application, I'm expecting to use a certain amount of CPU and RAM, but I might be able to burst up to this if I need to, which just tells Kubernetes how to schedule it onto the right node and how to monitor it to see that it's doing what it should do. Things like the configuration all comes from those secrets and those config maps that I talked about. And these are all kind of good practices. And they work in the same way for my legacy application as they do for my new application. So I can take advantage of all those Kubernetes features. So like I said at the beginning, like this is not really the ideal because this container image is very big. It's a Windows image. It's got the based on the full Windows Server 2019. But I can still take advantage of what the platform gives me, which is a really nice kind of jumping off point. The last thing I wanted to point out here is I talked about those labels on my nodes, and this is where they come in. So Kubernetes doesn't know from my spec, from my container image, whether it's Windows or Linux. And I'm telling it here with my node selector, these things have to run on a Windows node. There's a bunch of other stuff there about affinity, which you can kind of explore at your depth. It's just about spreading the load around to different nodes, but they have to be Windows nodes. Okay, so those are the main things there. By now, that should all be up and running. So let's go and see. Clear that down. Oh, I've gone too far. Check my pods. So these are all in a separate namespace, which is just an isolation feature in Kubernetes. So I'm looking for my pods in my namespace. I'm running the database here. Let's say this is a test environment. Ordinarily, I would run a managed database and connect out. I've got 2 pods for my web application. And there's also, with the Pet Shop app, there's a WCF SOAP web service. I'm running that too, just to kind of prove that we can. So let's browse here. Or let's look at the ingress rules a second, just to make sure that everything's set up. That isn't going to help. So let's get my ingress rules. And what we'll see is they're all using that same IP address because everything is coming into my ingress controller. I can see the host and how they're being routed. Okay, so that all looks good. So let's browse and see if the thing works. It works. Cool. Okay. I'm sure like if we were here in person, I'm sure you'd all be clapping at this 12-year-old app that's running in AKS with no code changes. It was super fast to load. There was no kind of delay in loading up or refreshing it, and that's because of the health check, the container probe that's constantly pinging it to make sure it's up and running. Not only does that tell Kubernetes whether it's healthy and whether it should route traffic, but it also keeps the application warm. So it's using IIS under the covers. It spins up the worker process the first time a request comes in, but the first request was the health check. So it's super responsive. If I go and look at these things, like it works, which is a good thing. I can add stuff to my shopping cart. This wouldn't work if I didn't have sticky sessions because it would be load balanced and it would fail. I can go and browse these things. The other thing to show you, let's open the network tab, is if I refresh this a few times, what we'll see is there are 304s coming back, which is Nginx, helping the caching at the client side. And then also in here, if I refresh, if I do a control refresh a few times, get my network tab back up, and look at one of these images, we'll see that this was a cache hit. So that came from Nginx. It didn't touch my ASP.NET application. There's no need to serve a GIF from that. So this all comes from my cache. So I'm reducing the load that's going to my application. It's only doing the things that it needs to do. And when it does do those things that it needs to do, I've got sticky sessions enabled. And that's all from the ingress, which is standard Kubernetes pattern, works just as well for my monolith as it does for a brand new microservice. Okay, so the application works, so that's good. That's the first demo going well. The other thing we're going to look at is if I want to share my product list with my business partners, this is what I'm going to give them right now, which is a WSDL document that describes how to invoke my XML web service, which almost zero of my customers or business partners want to see. So the next thing we're going to do is look at this kind of service facade that I talked about right at the beginning. I've done my lift and shift. My app works, like, we're looking good. We're taking advantage of a lot of the features of Kubernetes, but it's still the same app. So switch back to the slides and look at what we're going to do next. Oh, too far. So the lift and shift, like I said, people are quite anti lift and shift, but I think it's a viable move. If you've got an application where you don't have the source code anymore, you've just got a zip file that works on a server somewhere. Taking this approach and moving it here, if you're not actively developing that application, there's no dev team anymore, being able to run it in Kubernetes and use the same tools and the same API language to define it as everything else is a huge benefit, I think. So I'm using all the features of Kubernetes, but it's still the same old application under the hood. So as it happens, we have got a dev team for this app, which is me. So we can now kind of take the next stage. So some apps might finish at the lift and shift stage, and some are going to carry on evolving. And the evolving part is the more interesting part. So the next stage here is I've still got everything that's currently running. So I've still got the ingress there that's bringing up the traffic and sending it to my pet shop app. I've got the database that's running in there. I've got a new thing here, which is my product service, and this is the microservice pattern that's coming in. It's not full microservice because it's still using the old database, but this is my facade. This is the first step in being able to break this thing up. And this is my new component, so I can do whatever I like here. I'm going to write a brand new REST API, so it's got a nice interface for consumers to use. It's going to be .NET 5, so I'm going to get all those super performance benefits that you heard about today, and it's cross-platform, so I can run it on Windows or Linux. And the benefit of that is, as I start with the lift and shift approach, if I've got a bunch of .NET framework applications, I'm maybe going to create my Kubernetes cluster with a couple of Linux nodes and a dozen Windows nodes. But as I go down this journey of migrating and evolving these applications, more and more bits are going to be .NET 5 that could run in Linux, which is a bit more lightweight, it's a bit cheaper in terms of running those nodes. So I'm going to flip ultimately, and I'll have 8 Linux nodes and 4 Windows nodes. But I can tell Kubernetes that these applications are cross-platform, and it doesn't matter whether they run on Linux or Windows. Like, ideally, run them on Linux, but if there's not enough capacity, run them on my Windows node, and then I'm getting maximum utilization across my cluster. So that's like a huge benefit of being able to do this stuff. Okay, so let's go and see how that looks. So back to my demo bits here. So my product web service, again, all this is in that same source code repo. You follow the links, you better see where it is. So I'm going to go and deploy this now. So this is my brand new component. It's my .NET 5 component. So let's go and deploy all that stuff now. And if I look at the same, I'm going to take the same approach to have a look at some of these pieces. Connection strings, again, same idea. It's a Kubernetes secret, so it's a secure thing that it's got a separate management UI from UX from config maps, so I can secure them independently. And it gives the app whatever it needs. So my Nginx had its own custom comp file. My ASP.NET 3.5 app had XML. This is JSON, and it works in the same way. It gets delivered in the container file system. It gets managed by someone independently, and it's just got my sensitive data in there. I've also got ingress rule. This is for my REST API, so I've got a different domain name. So I'm going to api.petshop.sixside.com. If I wanted to, I could use my ordinary domain name and just have a path to take it to the API. This is sending it to my pet shop product service. This is the new component. This is a REST API. It's a read-only API, so everything's cached, but only for a short amount of time. So I've got a 2-minute cache in here. So if I'm getting 10,000 requests per second, 2-minute cache saves a lot of work going to my application. So that's a nice thing to have in there. And then again, if I look at my web deployment definition, I've got all those same kind of good practices in here. I've got my readiness probe. I've got my resource requests and limits. I've got my configuration being mounted inside the container. All that stuff is exactly the same. This lump of YAML is very similar to my monolithic application. One thing that is different is down here is my affinity for my nodes. So in the Windows example, it had to run on Windows, so I just used a selector. Because this is a cross-platform image, it can run on Windows or Linux. So what I'm saying here with the slightly scary name of required during scheduling, ignored during execution field, is I'm saying that this application, like, it has to run on either Linux or Windows. I don't have anything else in my cluster. They're either Linux or Windows, but it has to be one of those. And what I would prefer it if it was Linux. So I prefer if it was running in a nice lightweight Linux container on one of my Linux nodes. But that's just a preference. And if there are Windows nodes with more resources, it's fine to run on Windows. So nice little feature that you can take advantage of the fact that your application is cross-platform, get the best use of your cluster resources. Okay, so that should all be up and running. Let's have a look at these now. So all my pods, my database, web service, these are the new ones, my product service. I'm running 3 of those. If I have a look at the wide view, I will probably see they're all on the Linux nodes because the Windows nodes are using more CPU and memory. So as the scheduler in Kubernetes decides where to run pods, I've told it I prefer to run on Linux. It's put them all on Linux. If my Linux nodes were maxing CPU, it would put one on my Windows node. So, that's a choice that the cluster makes for me. And if I check the ingress rules, I'll see some new ones from my API. So let's paste that in there. I've got my api.petshop.6i.com, same IP address. The ingress is going to take care of all this stuff. Okay, so let's go and browse to this. Now this one, even though this is the new application, this one does have a little bit of a warm-up because the health check is just going to a specific health endpoint that doesn't do anything. So I'm not warming up the connection to Entity Framework or anything like that. So the first time I call this, there's a slight delay, but now I've got my nice shiny REST API, and it's like a proper API. So I can browse to a particular product within here, and I'll get that product back. This is being load balanced because I don't need sticky sessions for this. So it's going to be load balanced across my nodes, my pods. So now I've got another cold start issue, but then when I refresh, this is all being cached now. So if I open my network endpoint, you would see that this is coming from the cache. So it's all kind of super fast. Okay, so that all looks good. So that's cool. But that is not really the end goal. Now I've got this facade, but it's still using the original database. It's not really a service that kind of owns its own destiny. But the one benefit of this is if I go and look at the images. So this is Docker Hub. This is where I've got my images stored. This is the image for my brand new component, and it's a cross-platform image. So if you're not familiar with this, basically under the name of this, which is the 2007, being July 2020, there are Windows versions and Linux versions. The Linux version is 65 meg, and the Windows version, if I hadn't clicked on it, is 145 meg. It's based on Nano Server. It's pretty slim. It doesn't really matter which one of those run because they're nice small components. If I look at the original WCF app, that's going to be a different story because that's a Windows Server 2019 application. So the one I'm running is this one. That's 3.5 gigabytes compressed. By the time that uncompresses, it's pretty big, and the compression is quite tight, so it uses a lot of CPU. The reason this is important is it hurts when I want to scale. If I want to configure automatic scaling for my pods, which I can do, they're working too hard, Kubernetes will have more pods. I can configure automatic node scaling with AKS. So if there are pods that can't run because there aren't enough servers, AKS will have more Windows servers. But when the Windows server starts, Kubernetes asks it to run a pod. It downloads 3 gigabytes. It unzips it to 10 gigabytes. It takes however long it takes, 5 minutes maybe to be up and running. Whereas the other one, 100 megabytes, we can be up and running in no time. So that's why that's important. That's one of the reasons why it's important. Okay, so let's go back to our slides here. So I've done that kind of first part of the evolution. I've got this facade. I got my nice API that I can give to the public, and they can now consume my application. They can get a product list and build their apps of it and do whatever they want to do. I'm using the same tools for my old application and my new application. So Docker to package it, Kubernetes to run it. I've got this nice, lightweight, performant, multi-architecture runtime that I get with .NET 5. And I've got the security boundary that I talked about. So if someone manages to find an exploit and they can run remote code inside my product service, they can't really do too much because I could configure it so that the database user can only read products, and you can't do too much more than that. But the last thing we'll do is we're going to look at now that we've got this encapsulation. I want the pet shop application to call my product service, so it doesn't get products from the database, and that's going to allow then the team who own the product service to do whatever they want. So they're not tied to using that database anymore. They can go and shift to something completely different. We're going to be using Cosmos DB. So the old monolithic application will now rely entirely on the microservice to give it everything it needs, and the microservice can do whatever it wants under the covers. Okay, so very quick demo for the last part. So the first thing I'm going to do is I'm going to do an update of my pet shop app, and all this does is I really need to get my copy and paste game up, don't I? So let's copy that again. Okay, so all this does is I've added one new assembly to my monolithic application. I haven't changed a whole bunch of code. The pet shop application happily already has kind of dependency injection. So I've given it another way to go and find out where to load the products from using that service. And then if I go and browse to it now, the app settings are in here. The big change I've made is I've told it to go to this service to find products instead of the database. So now that's going to be nicely encapsulated. So if I go back here, clean this up a little bit and go back to the home page. So this is now, it still looks the same, still works nice and quickly, it still does the same stuff, but now it's calling into my pet shop service, my new microservice, and I can tell that if I go and look at the logs for that service, we should see a whole bunch of stuff coming in. And that's being, the pet shop app now is now entirely relying on the product service, my new microservice, to get everything about products. So now the product team can now go and do the update they want to do, which is to move to Cosmos instead of this kind of internal SQL database. Okay, let's try that again. If someone can write like a VS Code extension that will take things from code blocks and paste them in the terminal to make my demo so much smoother. Okay, and then again, the change to this is really just a tiny configuration change to say it's already got the code to be able to use Cosmos. I've already preloaded the data into Cosmos, a copy of the data. So now it's going to be looking at Cosmos DB for the data. So let's go and check this out to make sure it actually works. If I do a refresh, okay, that wasn't so good. Cool. Okay, so that's looking good. Now, so I've still got all my products in here. If I go and open my birds list here, of course, what I haven't done is kind of scale up for anyone who wants to be like throwing tons and tons of load at my application. Let's go and go here. Okay, cool. So this is what I expected to see. It still works in the same way. Up in Cosmos DB, I wrote a tiny application that pulls the products from SQL and puts them in Cosmos DB. So I can go and have a look at the stuff in Cosmos. And if I want to edit things, I can go and edit them. So if I want to change Pelican to Pelicant. And if I go in here, and here's a joke for the old timers, I'm going to change Ant to Nant and click on update. And if I go back here now, we'll see something kind of interesting, hopefully. So if I go and look at the Pelican, there you see I've got Pelicant up here. If I go back to the list, it says Pelicant. If I go to my bugs, it says Nant. So the update is immediate. So it's come in through my API, and it's now flowing through into my application because the microservice owns its own data. I can do whatever I want to publish changes outside of the ordinary flow of the main application release. Okay, so just going to wrap up now. So let's go and go back to my slides. There we are. Okay, so that part 2 is really about having a real microservice. So I've taken effectively a chunk of stuff out of my old application, moved it to somewhere new, using a totally different data store, totally different technology stack altogether, and I've told the old app to use that. I had to make a small change to my monolith, like nothing significant, not a 2-week regression test thing. And I've now got a pattern that I can replicate for all of those boundaries. So, you know, the advantage of having a monolith to start with is you understand where the boundaries are going to be. You know, you can work those out based on, you know, what needs to be updated independently, what gets more traffic, whatever, you know, whatever criteria fit for you. You may find slight problems. So if you spend enough time looking at the pet shop, you'll find that it doesn't quite work correctly. But, you know, that's something you're going to come out with the fact that I've got a 12-year-old app and I'm trying to do as little work as possible to evolve it into something new. Okay, and we're done. So if all this stuff was totally new to you, there's a whole bunch of links here that are hopefully useful. That top link, DAC for .NET, I do like a whole day workshop. And all the content is online. You can just go and follow along with it yourself at home, and that starts from 0. So it tells you about how containers work, tells you how to wrap up .NET Framework apps and .NET Core apps and how to run them in Kubernetes, and it takes you from 0 to, you know, to be able to understand this presentation. I've written 2 books, Learn Docker in a Month of Lunches, Learn Kubernetes in a Month of Lunches. If you follow those links, there's like a giveaway. I've got a few copies to give away. If you don't win one of those, then there's a discount code from Manning where you can get some money off. And today's demos are all up there on GitHub. You can follow all that stuff through yourself, create your own AKS cluster, and see if the Pet Shop app kind of works for you. So I hope that was useful. My name's Elton. Thank you for joining, and I hope you enjoy the rest of the day.
Thank you very much, Elton. We unfortunately are out of time. We do have one question out on Twitter. So if you look at the .NET Conf hashtag, I think you can answer that for them.
Okay, cool. I will do
that. It was a great presentation. I was trying to looking at it. I was doing some quick searches on the internet, trying to figure out all the content. I love the style. Great job.
Okay, thanks very much. Okay,
thank you. All right, thank you, everybody. We have Carrie Payette coming up. We're going to be doing a quick change of speakers, and we'll be right back with more focus on microservices. All right, we're back more with .NET Conf focus on microservices. We have Carrie Payette talking about migrating .NET Framework apps to Azure. Take it away, Carrie.
Hi, welcome to .NET Conf Focus on Microservices. My name is Carrie Payette, and I'm here to talk to you about migrating .NET Framework applications to the cloud, and in particular, web forms. So let's be realistic here. Web forms is a huge player in the industry today, especially in large enterprise organizations. You can find these web applications serving critical roles. Just because you might have an aging fleet of applications, I want to make it clear that this doesn't exclude you from migrating to the cloud. These applications can be migrated to Azure and take full advantage of scalability, reliability, and security of the cloud. So let's go ahead and get started. All right, now listen up. Here's the story. You work for Wingtip Toys, and for those of you who've been around for a while, I'm sure that's to be a blast from the past. Anyhow, Wingtip Toys has been in business for over a century with legacy applications to prove it. Wingtip Toys has recently started a large shift to modernization, both to stay relevant in the competitive world of toys, but also to be seen as a company that's at the forefront of technology. They have multiple ongoing pilot projects ranging from IoT, analytics, machine learning, and you've guessed it, microservices. The pilot projects are really exciting and all, but the existing business doesn't run, nor does it currently depend on those fancy projects. Wingtip Toys has a vast portfolio of existing applications that are responsible for the critical day-to-day operations of the company. So truth be told, you can't just, snap your fingers and modernize your fleet of applications instantly, but that would be really cool. So you, as the VP of Modernization, your first focus is to get critical Wingtip applications off of aging on-premise infrastructure and into the cloud. So one of the most critical applications at Wingtip Toys is the e-commerce website application. So this application was initially built about 17 years ago using C# and ASP.NET web forms. The crew has done a decent job of keeping the framework versions up to date, and currently it's sitting at .NET 4.5. The on-premise architecture is made up of a SQL Server 2017 database hosting two application databases. ASP.NET Wingtips is responsible for holding ASP.NET specific tables, supporting things like identity and membership of the website. Wingtip Toys is responsible for the e-commerce specific data, so this is like the catalogs, products, pricing, and orders. The web service, Toybox Web 01, is a dedicated IIS box for the e-commerce website. What we need to do is get the SQL Server databases and the web applications up to the cloud. The desired architecture is to host the databases using SQL Azure and the website to be hosted in Azure Application Services. So you might ask yourself, well, how do we get there? So choosing a database deployment option really depends on the current state and versioning of your database, as well as how much control that you need to have over your SQL Server database engine or the underlying OS. So Azure SQL Database is a platform as a service option. This option is an always up-to-date version of SQL Server Enterprise Edition, and it's fully managed by Microsoft. While Azure SQL doesn't have every single feature of SQL Server, it's optimized for modern app development and offers both hyperscale and serverless options. So this option tends to require the most upfront work, but depending on the complexity and the features that you're using on your current database, really will gear to you how much work that you have to do up front. Another option is Azure SQL Managed Instance, and this is another platform as a service option. This is when you want to take your existing databases and lift and shift them, just essentially lifting and shifting your database infrastructure. So this option boasts minimal to limited changes required to get your current databases to the cloud, and this option will also support shared resources between the databases, instance scope features, native VNet support, as well as full access to the SQL Server. Now, your most flexible option is SQL Server on Azure VM, and this is an infrastructure as an offering option where SQL Server is run inside of a fully managed VM. So this means that Microsoft manages the VM and the OS. But what it also means is that when you're running SQL Server on this SQL Server image from Microsoft, you get OS level access, which again provides you that lift and shift readiness, and you get full control over the SQL Server database engine. The VM supplied by Microsoft is managed by Microsoft, as I mentioned before, means that the administration costs of this thing are reduced because you don't need to manage the VM, OS patches, or database updates. That's all handled for you. And as an extra bonus, if you're currently running SQL 2008, making the move to Azure will give you extended support. As for web applications, what you want to do is you want to determine your application solution. So you have a couple options. You can containerize your application, you can run it in an application service, and you can also go the VM route. So there's a lot of tools that can help us reach our destination, and we're going to go over a few here. An Azure Migrate project is a resource that's available to you through the Azure portal. It lets you create a migration plan, store assessments, and track where you are exactly in your migration journey. Azure Database Migration Services is a fully managed service by Microsoft available through the Azure portal. It works in conjunction with the Azure Data Migration Assistant, which I'm going to talk about in a minute. But what it does allow you to do is seamlessly migrate your databases with minimal downtime. So essentially doing online migration. The Azure Data Migration Assistant is what the Migration Services works with. It helps perform assessments of your on-premise databases and provides you with remediation details. So this means that it'll assess your database and it will tell you if anything needs to be done before your migration. So if you have any issues, it'll give you some remediation steps and you can perform those. So even if you are using Azure Database Migration Services that I mentioned in the previous point, the remediation does not get done for you. You actually have to physically do that remediation. So the Azure Data Migration Assistant, should you choose not to use the Azure Data Migration Services, it also allows you to perform things like the schema and data migrations with the click of a button. So it really makes things easy on you. The Azure App Service Migration Assistant is the web application counterpart of the Data Migration Assistant. So we have a lot of assistants here working with us. It scans IIS websites for any potential incompatibilities, and it also will perform the deployment of the website to an app service in Azure for you. So you can see there are 2 links there. I'll tweet those a little bit after the session, but those are available for you to download. All right, so now let's go ahead and let's do the thing. All right, so the first thing that I'm going to do is move that over. Is I'm going to open up my Azure portal. So inside of the Azure portal, there's, let me go to the home page. You can actually go ahead and search for resources and search for Azure Migrate. And Azure Migrate will come up. And what this does is, again, it allows you to have like that project view of where you are in your migration. And you can see here that even though today we're only talking about databases and web apps, it can help you set migration goals for servers, databases, VDIs, web apps, so on and so forth. So for us, we're interested in moving the databases over. So if I wanted to, I can go ahead and select databases. And the first thing that we want to do is say add tools. And it's going to ask us which subscription we're working in, and then we can create a migration project. So I can say Wingtips Web and hit next. And it's going to ask us to choose an assessment tool. And this first one right here is the one that I've been talking about, which is the database migration tool. So let's go ahead and select next, and we're going to use that same tool for the migration. And there we go. So now what I've done is I've added to my project a database migration step. So by using the tooling and using this website, you can see that we have our migration planned out for us. And these tools will work seamlessly with the applications that I'm going to show you here in a minute, which is the Data Migration Assistant and the App Server Migration Assistant. So similarly, inside of web apps, you can do the exact same thing. We can say add tools, and we have one to choose from, so it makes it pretty darn easy. And then we can select the next one and add the tool. So now you can see within our plan that we will have 2 databases that we're migrating, as well as a web app that we're migrating. So here's the assessment and here's the migration. Here's the database assessment and there's the database migration tools. Just so you know, I have a little bit of stuff pre-set up just for timing purposes and budget purposes. So when you actually do create the Azure resources through the tools that I'm going to show you, you don't really get a selection of what pricing SKU that you want to choose from. So I went ahead and created some so I can control my costs. So here you can see that I have a SQL Server, Wingtip Toys. We also have an app service plan, which will host our web application. So that's our Wingtip Toys app service. And we have the 2 databases that we're migrating, which is the ASP.NET Wingtips and Wingtip Toys. All right, so locally, I have an IIS server running. And you can see here's our, well, I forgot the G, so just, you know, forgive me there. But we have our Wingtip Toys right here, and it's currently running on port 8016. So if I bring up my web browser here, you can see that port 8016 is up and running, and I'm currently hitting my local database. So speaking of databases, here's our database. I'm connected actually to 2 servers. So here's my Azure server, and I can expand this, and you can see that we have Wingtip Toys here. If I expand the tables in both of these, why is that there? All right, I think I know what I did. So what I'm going to do is I'm going to delete those tables. I probably ran it without the connection string changed because I was doing a dry run before this one. All right, so and then we have my local database, which has my Wingtips database. Oh, that's what I did. I deleted the wrong. All right, well, that's great. All right. So the first thing that I'm going to do is we're going to run the data migration assistant. And what I'm going to do here is actually run this web application really quickly. So it creates my tables again that I apparently deleted in my local database. All right, so what I'm going to do is I'm going to create a new assessment. And for this assessment, we're going to give it a project name, and I'm not actually going to save these, so I can name it whatever I want. So let's go ahead and hit create. And then we're going to check for database compatibility and feature parity. Then we're going to select our sources. So I'm going to select from my local database and connect. And I'm going to select that we're going to assess both the ASP.NET Wingtips as well as the Wingtip Toys databases. I'm going to add those for assessment and then start the assessment. So it's going to go ahead and do its thing, and it says, all right, for my assessment, I just want you to know that the key, like the encryption key management, is not supported in Azure SQL Database. And that's okay for me, so I'm all right to go ahead and do the migration. So let me just go ahead and double check inside of SSMS here. So I'm going to go ahead and create a migration now. So my databases are coming out okay. Let me go ahead and select migration, and I'm going to go from SQL Server to the Azure SQL Database, and I'm going to migrate my schema and data. So let's go ahead and say create. I'm going to connect to my local database server, and we're going to have to do one database at a time here. So let's go ahead and do ASP.NET Wingtips and hit next. And then it's going to ask me to select a destination. And I want to select the Wingtip Toys destination. And then I'm going to enter my password. and hit connect. And it's going to ask me which database to move to. So because I kind of messed up my initialization here, I want to make sure that these databases are empty. So just bear with me here just for an unplanned moment while I delete these tables. All right. All right, so there's that one. And then let's do another new query here. And I'm going to drop these ones. All right, so that's a lesson learned. No matter how many times you prepare, there's always some things that can go wrong. All right, so now you can see that I don't have tables in these two databases. All right, so now I've now selected my now empty ASP.NET wingtips. I can hit next. And what it's doing now is it's actually going back and it's evaluating what exactly I have in my database to perform the migration. And I'm just going to migrate the tables over and generate a SQL script. Now, this SQL script is something that if you wanted to, you can go ahead and take manually. But what I really like about this tool is that it allows you just to deploy it right here. So let's go ahead and say deploy the schema, and it goes ahead and does it for you. It's completely hands off. So let's go ahead and migrate the data now, and here's the tables are all selected. Let's go ahead and start that data migration. And there we go. Boom. We now have our first database migrated. So let's go ahead and repeat that for our second one. So again, I'm not actually going to be uploading or saving any of this to my migration project for the sake of time, but let's go ahead and do this. So we're going to connect to our local SQL server here, which is here, and connect. And this time we're going to migrate our wingtip toys. Let's go ahead and hit next. And then, I'm not going to migrate there. I want to migrate to Azure. All right, so here's our SQL Server authentication. I get to enter my password again. And I'm going to hit connect. And we're going to migrate to wingtip toys. Same thing here. I want to migrate all the tables over. I'm going to generate the SQL script. It's going to go ahead and introspect the database and generate a script for the schema objects. Then I can click a button and boom, there goes my schema. And now let's go ahead and migrate the data. There we go. And now we're currently running, all of our data is up in the cloud. So if I actually refresh this here now, you're going to see that our database tables are over there. So let's go ahead and open up our application here. So I want to change this, and I'm going to uncomment these production connection strings, and I'm actually going to publish this to my local IIS. All right, so I'm going to right click on here, and I'm going to say publish web.config, and it's just doing a file deploy to the folder that is hosting, that my IIS is looking at. So I'm going to publish the web.config, and it's successfully published. So now I can come back to my web browser here, and if I refresh it, it's now going to be pointing my local web application up to the database in the cloud. So here we go. We have planes, cars, what have you. So that's great. So we're halfway there. Now, the next thing that we need to do is use the Web Application Migration Assistant to scan our web application and see if there's any incompatibilities to migrating this up to an application service. So to do that, we're actually going to open up another tool, which is our App Service Migration Assistant. And what this is going to do is connect to my IIS server, and it's going to pull back all the websites that I have. And I want to do the Wingtip Toys one, so I'm going to select that one and hit next. And it's going to go ahead and scan my Wingtip Toys website for any incompatibilities. And wait, oh, we have one, right? So here's an error, and it says this error will block any automatic migration using this tool. But if you want to, you can go ahead and either continue and send the assessment results up to the migrate project, or I can go ahead and remediate that myself. So the error says that the bindings were found on the following unsupported ports, which are 8016. So I know how to fix that one fairly quickly. So let me go ahead and go into IIS, and I'm going to edit the bindings, and I'm going to change this to a standard port, which is port 80. And I'm going to hit OK, yes, and close. So now if I browse to this application, it's going to be running on just localhost hitting the default port 80. So there we are. So I can actually restart this assessment now. So let's go ahead and go back to choose a site, select our wingtip toys again, and let it perform that assessment again. And now you can see that, woohoo, we have success. So let's go ahead and hit next. And now it's going to ask me to log into Azure using a device login. So I'm going to press this button, and it's going to copy this code to my clipboard and open a browser. Open down here. I'm going to paste that code in. Hit next. Make sure I log in with the correct account, and now I can go back to my tool. All right, so it's going to say I can select an Azure Migrate project. Now I did create one, but for sake of time, we're just going to skip this for now, but that's how you could report your migration steps up to that project for that overall view. And then I'm going to go to the .NET Conf resource group, and the destination website, I can call this Wingtip Toys Web. And then I want to use my existing Wingtip Toys application service, and we can skip the database setup because we're actually already pointing to our SQL Azure database. So let's go ahead and select Migrate, and it's going to go ahead and do its thing. All right, so while that is happening, I want to show you that, okay, we're good. We've got our databases up, our web applications on its way. What else can I do to take advantage of the cloud? So one of the things that I've also set up is GitHub Actions to do a continuous deployment to our web application. So what I've done is I've created a GitHub action, which essentially says on any push of changes to the master branch, I want you to go ahead and build and deploy the web application. So it'll actually pull out down my code, compile my code, and create a build and release it to my web app, in Azure. So here you can see that it's checking out the code, setting up MS build, restoring NuGet packages, performing the build, creating the folder to publish the information, and then deploying to the Azure web app. Now, one thing that we need here is this Wingtips publish profile. So as soon as our actual web application is done, and it is, we can actually go, well, we can hit go to your website, but the next thing that we can do is open up our Azure portal and get the publish profile now. So I'm going to go ahead and refresh my resources now, and you can see Wingtip Toys has now been established. And then I can select here to get my publish profile. And then I'm going to open this file, and I'm just going to copy this information. And what I'm going to do now is it sees it's requesting it from a secrets context. So I'm going to go back to Wingtip Toys. This is my Wingtip Toys repository. Go to Settings and go to Secrets. I'm going to update this. Paste that in there. Update the secret. And now I'm ready to go. So if I open up Visual Studio now, and I want to make a change, well, first I better see if, yeah, here's our wingtiptoys.web.azure.com, and you can see that my data is coming back because we're currently pointing to the Azure connection string. All right, so let's go ahead and make a change so we can watch this pipeline workflow work, the GitHub Actions. So let's go to our default page, and we can say this is the epicest. That's a word, trademark, Carrie Payette. So I just add, this is the epicest right here. I can go ahead and save that. and I'm going to commit my change to the master branch. And again, whenever, oh, I don't want that one. Unstage that selected one. I'll say hello.net conf. And I'm going to push this to master. So that workflow is going to be triggered on master. So it's going to go ahead and push those changes. And now if I bring up GitHub and go to the Actions tab, you're going to see that we have our hello.net conf workflow running. And then each of the steps that I showed you is going to actually show up here. So it's setting up the job. It's running the checkout. It's going to set up MS Build and do all the steps that I talked to you about. So while this is happening, I don't know if there's any questions or commentary. I'm willing to take them now.
Hey, Carrie. Yes, we actually do have one question.
Sure.
And that is, to containerize your app, should we keep only one database instance container accessed by multiple instances of the web app? And also, how would you scale that database?
Well, that's the thing, is you probably want to put it into SQL Azure and then just have your applications pointing to it. And this way you can take advantage of those, of the features of SQL Azure itself, like the management, and like, again, depending on the SKU that you're looking for, like SQL Azure is like the most fully managed one. If you do managed instances, you get a little bit more control. So I would recommend doing it separately. So containerize your web application and then point it to like a SQL Azure database. So you're taking advantage of that infrastructure.
Gotcha. Then there's a follow-up question in that one as well that says, should we keep multiple instances of a container of app plus database together? And if so, then how do we sync data across all the database instances?
Well, again, that's where you want to have it be separate. So if you wanted to have like clustering available to you, you can do that on like in Azure. So that's like, you've got two different things happening here. You have your web application and you have your databases. So if you wanted to have different databases for different websites, you would just set up those instances separately. If you're just looking for like geo redundancies, you can actually set up like failovers and fallbacks and replication essentially across two different SQL servers in different regions.
Got it. Perfect. Thank you.
All right, so now that this is actually deployed, if I return here and go to our website, you should see that it's going to be the epicest ever. So you can see within here that we've completed all of our steps in our workflow. And we're going to give it a second. Again, I went for a very, very cheap app service. So we're going to give it a second to warm up. All right, there we go. This is the epicest. All right. All right, so that is what I had for you today. If there's any more questions, feel free to ask. If not, thank you so much for participating. You can reach me on Twitter at Carrie Payette, on Twitch, Coding Bandit, proud team member of the Live Coders, and you can see my blog at codingbandit.com.
Thank you so much, Carrie. We don't have any more questions. I think people were just, watching what you were doing there. So obviously, go to Twitter and check out the .NETConf hashtags. So in case we have something there, you can answer it, and we can go from there. Again, thank you so much for taking the time to present to us. We have Shane Boyer coming up next on .NETConf, Focus on Microservices. We're going to go at a quick break, and we'll be right back.
You're live.
All right, everybody, we are back live for .NET Conf Focus on Microservices. We got Shane Boyer talking to us about building and debugging microservices with Kubernetes and Visual Studio. Take it away.
All right, thanks, Javier. Just want to make sure you got my screen right, so I'm going to go ahead and share this. Let me put it on slideshow. All right, we're good? All right, perfect. All right, so I don't know about everybody else. So welcome in whatever time zone you're in. It's approaching 8 p.m. My time. I'm not sure about you. I'm exhausted. There's been so much stuff going on. I feel like I need Kubernetes for my brain. It's thunderstorming where I'm at. My neighbor is currently mowing. I'm pretty sure you're going to hear my dog bark. So if that puts anything into perspective, we got a lot to cover. And there might be some distractions. There could be some failures. Welcome to development in 2020. So expect very, very low expectations here. So I do want to talk to you about building and debugging microservices with Kubernetes and Visual Studio. We've seen a lot of stuff happen today, all the way from Brendan talking about what microservices was to Kelsey asking us what was the meaning of life. So I think that pretty much covers a really good conference so far. But I'm going to start off with, I think the question that a lot of us saw on many, many slides throughout the day. And that is, what is microservices? I think it's a question that everybody asks. I think everybody has their own definition. I'll give you mine. It is a kind of culmination of a lot of what a lot of the speakers said today. But the questions are kind of, what are they? How big should they be? And I joke, like, they're supposed to be small, right? I mean, it's micro. What tools do we have to kind of build and deploy and test and kind of manage all of this? And I think the bigger question is, should we just jump right to them? I think Brendan mentioned in his talk, like, are we just checking a box on a resume or a CV? So I think all of that, I hope you got a lot of those questions kind of answered throughout the day. If you missed some of those talks, certainly get a chance to look at them in the post recordings after we put them out there. So what I'm going to jump into right now is kind of my definition of what microservices are. And I think you saw some variations of these slides, so I'm glad they grabbed them from me. First off, they are around independent deployments. And improve scaling and resourcing of the utilizations per those services. They allow for our teams to be, smaller and focused on that one particular service and the deployment of that one service. And they also avoid single points of failure. Now, what does that really mean? That means that hopefully that one service, if that one service fails, it does not take that down the entire application. If it's a mail service or a messaging service or a notification service, it's okay for that one service not to work in the broad spectrum of the entire application. It should not bring down the world. I think we've all experienced at some point that, hey, my one connection to one external dependency failed, my whole app doesn't work. We just get a 404 or a 500 or something like that. And then we're getting calls. Hopefully that developing a microservices kind of architectural pattern eliminates some of those types of situations. And all of this really increases our velocity. One of the patterns of microservices is putting them in containers and allowing us to constantly do the CI/CD and deployment regardless of what the app is. Elton did a great job of showing how we can take a legacy app, a 12-year-old pet store application, putting it in a container and throwing it on Kubernetes. And by doing that, it allows us to put it in a Docker container and make changes to that app slowly, but allow us also to push it out to a cluster at a fast pace. Monolith applications, very slow-moving type of velocity. This allows us to increase that velocity. And again, puts isolation around that one particular application, but also allows us to move forward on some future application development and some of the newer technologies while not impeding the application as it stands right now. Julie did a good job in her presentation around DDD and talking about the kind kind of boundaries of microservices. And I think this is a very important point when it talks about what are they and what should we put in them. And I think that also talks to how big should they be? And that's really up to you and your businesses. If I have something that does just products, I think, is it okay to say this just gets my products and just manages my services for my products? Great, then that is your service. It might have a database or a subset of databases or just tables. But you have to decide what is the boundary around your service. As far as how they communicate, they commonly communicate over the network using HTTP or REST services, gRPC, as James talked in his presentation. Super fast binary communication. That's really great when it's within a cluster because it's super fast. Don't have to worry about being human readable services as they're going across the wire. It's a great use of that service. Or event-driven messaging, as Clemens used in his presentation, about just throwing messages around in queues and such. And then just at the very base of things, how do we package these up and get them ready for deployment? It is containers and using Docker type technology. So what I want to do first is jump right into demos. I think we like to see demos and see this stuff work. And the first thing that I want to start with is just what does Visual Studio offer us at the very base level of getting started with a microservice and also just Docker containers. We could jump right to Kubernetes. I think we should, but I'm going to show what does Visual Studio offer when we're talking about just maybe just an API, maybe just a web application, and at the very low level, kind of baby step into what our tooling right now offers us when it comes to getting started with microservice development. I think sometimes we jump kind of right into the pool with both feet without really understanding what is available to us. So let's jump into a quick demo. And what I'm going to do, I apologize for looking up. I've got a screen above my camera, so I'm not looking to the sky for thought. I'm actually looking at my demo. So let me, I'm going to open up just real quick. I just did a file new project. This is the weather template that's in our API. It should be pretty familiar to anybody who's done kind of file new project in .NET. And what I've got here is on the right here is just a web API. And I think if I F5 this, everybody has seen this. We've got some random weather results that's going to come through in our web API. So what I'm going to do to this is I'm going to right click, not deploy, because I've got some friends that would yell at me for doing that. I'm going to come down and go to add, and there's an option here called container orchestrator support. So what I'm going to do is I have some options now. I can choose Kubernetes and Helm. I'm not going to do that at this point because we're going to go later on in the project to show some of those things. But I'm going to choose Docker Compose and hit OK. It's going to ask me my targeted OS, and I'm going to choose Linux here, so I want to use Linux containers. And what this is going to do for me right away is it's going to inspect the application that I have, and it understands that I'm using a .NET Core application. It automatically adds a Docker file for me. It understands that I'm using Core 3.1. By default, it chooses Buster Slim, which is that Debian base image for Linux. And it adds that for me, which is great. Then it also creates a Docker Compose file for me and adds my project to use that particular file. So if I F5 right now, it would fire that up. That's not super impressive at the moment because it's just a single file. But what I'm going to do to this here is I'm going to go ahead and add an additional project. So let's add not a website. We're going to add a new project. And we'll add a new web application. We'll just call it web front end, I guess. Sounds good. Hit create. And we'll choose a web application. I will choose yeah.
You're still showing PowerPoint.
Oh, you know what? I don't hit escape. My mistake. Did I only share? Sorry about that, guys. You know what I did is I only shared PowerPoint. Are we good now? Yes, no?
Yeah, there we go.
My mistake. My mistake. I'll actually walk through that whole thing because I had to do it for another project. So what I did is I right-clicked this project here. I did add, and I chose container orchestration support. So I'm going to do that for my web front end. I'm going to click add. I'm going to choose container orchestrator support. And I'm going to choose Docker Compose and hit OK. And choose Linux. And for my web front end application, it adds that Docker file as it's thinking. There we go. It adds the Docker file for me. There's my Buster Slim Debian-based image. And it adds that Docker Compose project. If I go to my Docker Compose, there was my web API project that I was speaking to earlier while you're looking at my beautiful slide. And now it's also added that web front end project for me in my Docker Compose file. So just so I can wire these up, I'm going to go into my web project, and let's go over to Pages. Let's go to the index file. And just on my on-get, let's add some pretty code here. And we want to call it Web API. That's what we want there. And let's make sure we get all that there. Perfect. And then in the index, I want to make sure that I'm actually showing my message that I'm writing out there. Pressures of typing while everybody is watching. And like Elton says, our snippets don't work all the time. There we go. So now what I'm going to do is in my project here, I'm actually going to hit the URI via the DNS that Docker Compose sets up for me automatically. Now, let's make sure I save all this stuff. The other thing that it does is when I right-click and add that Docker Compose orchestration for me, in my debug option, now it gives me this Docker Compose option. So if I go ahead and F5 this, what it's going to do is spin up both of these containers for me as we're running and waiting. It's created our web API. Oh, Barry would be very happy. Yes, I want to do my SSL. I will trust my certificates. It's going to ask me again for my other project. There we go. Yep. Yep, we do. Okay. So now it's going to run those, and I should launch our application here in a second. Perfect. And of course, it launches on my other window. No, don't destroy those. So here's our web API. Perfect. And one of the things I want to show in Visual Studio, if I can get my Visual Studio window back up, there we go, is down in Visual Studio now, we have a Containers tab for my web API that shows me all of the ports that are running. I'm going to try and do Zoom. Let's see if this comes up. I always fail at Zoom. There we go. You can actually see the environments and the ports that are all running inside of the container itself. Now, I can't get out of that. How do I get out of this? There we go. So if I go to ports, here's the ports of my web API running. I can see all the logs that are currently running out of that actual container. And another awesome thing is I can actually go into the container itself and look at the app files that are running inside of the container and actually see those files running, which is really great. I can go to my web front end, go to the ports that are there, and if I click on this port here, it'll actually launch the application. Was it running in running there. Let's go to the other port. Let's try our SSL port. And that one is failing. Probably got my cert wrong, but that's okay. But we can hit web front end. There it is. Sorry, I was running 2 instances of web front end. There's our application, and it's actually hitting our web API. But now I'm able to see everything that's running inside of the actual container. Better yet, if I go into my application here, I can actually hit breakpoints on the web front end. And if I go to my weather forecast controller and then hit breakpoints here, go over to my application, and we hit refresh. It's waiting. We hit our breakpoint on the front end. If I F5 this for the request, we hit our breakpoint on the back end as well, running all inside the container, all inside of Visual Studio, which is pretty cool. All right, so those are some of the tools that we have just inside of Visual Studio, when it's great. And we're just continually hitting our breakpoint, F5 a lot of times. So that's a really good feature, just when you're talking about working with containers and those microservices inside of Visual Studio and .NET, all right built in to Visual Studio, which is super great. But let's go back to the slides. But let's take a larger example. So here's an example of a more realistic microservice application. This is a bike sharing web application. And as you can see from this particular application, there's a lot more moving parts. We've got multiple types of databases. We have a React.js front end. There's .NET Core gateways. There's Node.js. There's Golang. A lot of pieces moving in here. Now, I might be responsible for only one of the parts of this particular application. For me as a .NET Core developer, maybe on a larger team, I might only be responsible for something like the reservation engine or maybe the API gateway. Now, there's a lot of benefits to microservices development, but there's also a ton of challenges. How do I test and debug my one particular service that's here? What if my machine is not capable of getting all of these services running due to maybe like RAM constraints? Maybe I have a limited laptop. How do you satisfy all of the dependencies during development time so that you can be confident that the code that you're running and writing will work as expected in the context of this entire application? If I make a change to my reservation engine, how am I sure that I'm not going to affect the billing service, the front end application, the user's service, and things like that? Maybe I do know how to run all of these languages. Maybe I've got friends that are close to me that we're collaborating on this in a really good environment. But if I do know how to run all of it, and I can get it all running on my machine, maybe I have a monster 32-core machine. It causes distractions, and it leads to tracking issues in other items, and it gets me away from the task at hand. So as our teams were discussing with customers on what's the best way for doing this, we started to look deeper into better ways to kind of focusing developers on doing just that particular task. Now, one of the ways we looked at this was from a development approaches perspective. Now, I could just write my code locally. We've seen some examples of that throughout the conference today, and just firing everything up in containers. And I could do mocks and stubs and do Docker Compose like I did in the previous example. And that's great. I can see all of my changes immediately, see them in a specific environment. And that's fast, and my local development cycle is pretty quick. But the fidelity to a deployed environment, I'm really not sure. I can't get a good level of confidence on how fast, how that's all going to work in my deployed environment. I might feel okay, but say if it works on my machine in containers, it's probably going to work in a deployed environment. As we start to add more and more components to the particular application, as you saw in the diagram, if that scales to, we add customer services and accounting services and things like that, I obviously can't get all of that stuff running on my machine and have a great deal of confidence that I'm not going to break the build. And the ease of use of all of that, maintainability and a concept count, obviously, there's not a great deal of success to that. The next option is remote. We have a product called Azure Dev Spaces, GA last May, that allowed us to write code locally and kind of do some file syncing and push and work in kind of an environment, develop locally, push, and see those things happen on a sync basis. And Scaffold is another tool that's very similar to that. This allows us to satisfy some of the fidelity when it comes to seeing how that runs in a deployed environment, and see how, as we scale those number of application components, we really don't have to deal with that. But when there's problems, when things break, which is where I like to focus on a lot of customers, that really starts to break down. Deployments fail, file syncings fail. We get caught up in that, in the knowledge of things like Helm charts, deployment concepts, that really, we lose our focus on productivity. And that inner loop development velocity can really slow down, even though things like scaling issues are solved. So there's a trade-off. Where we kind of got to from that is a hybrid approach. And this allows us to write code locally and satisfy those application requirements by connecting to a deployed environment, to a specific service, writing the code locally, and then running everything in that deployed environment. And this kind of gives us the best of both worlds. Ease of use. All I really have to worry about as a developer is just writing my code for that specific service and being able to test all those other dependencies in that deployed environment. When I say deployed environment, I am not talking about production. Please quote that. I'm not talking about working on code in production. This is a deployed environment like a development cluster. This allows you to write and run and debug your code locally, but again, leverage that deployed environment. It's easy to use. The only thing you really need to understand is how to access the cluster. What is my kubectl configuration, and have that running, and that's great. And what this is called is, what we're calling is local process with Kubernetes. It allows you to run and debug that code in your development computer while still connected to the cluster with the rest of your services. In the example of that bike share microservices application, where you've got a ton of interdependent services and databases, again, trying to replicate that all on your local machine is super hard, or could be very hard if you don't have the knowledge of how all that works. It allows you to focus just on the one service. Additionally, building and deploying your code to the cluster for each code change over and over and over again can be slow, time consuming, and also difficult if you're trying to kind of debug or connect debuggers to it. We've got what I'll show next here is in Visual Studio, also in VS Code, we've got extensions that allow you to basically connect to your cluster and debug and write your code locally, but also as requests come in, as you can see on the slide here, we will route those requests to the service that you're working on with all the other ones that are actually in the cloud in your cluster. It works with the existing applications that are deployed, and then when a session starts, basically by hitting F5, we will work with the DNS on your machine and make those connections to the cluster and replace the running service when it starts. So again, looking back at the bike share microservices application, what we're going to do, the request comes in, goes to the front end application, and I'm only going to be responsible, as I mentioned, for working on something like the reservation engine. The request will come into the front end, goes to the API gateway, it'll hit the bikes service, and then when the request comes into the reservation engine, it'll actually get routed to my machine. I can actually debug the code, walk through it, and then continue on, and then the request will kind of be routed back out. And that allows that microservice code to run just on my machine and kind of give me just the ability to write just the code that I'm interested in writing on, and not really have to worry about how all the other application runs, let those other teams focus on their work. So let's see what that looks like. So what I'm going to do, first off, is make sure everything is running up in my cluster. So if I look at my current AKS cluster in the cloud, you can see here that I've got the web, the billing, all the databases for Mongo and SQL and everything else, reservation engines, et cetera. It's all running currently up in my AKS cluster right now. So that's awesome. I'm also going to check my services to make sure that my IP address is all good up there. And okay, we're good there. All right, so I'll close that out. Let's go to Visual Studio. Let's stop this service. We don't need you anymore. And we're going to go over to app. So what I've opened up is just the reservation service here. And over in my, I believe it's in my bikes helper, yeah. What I'm going to do is I'm going to reserve, check the reserve bike message here and just debug this logging message and make sure that the request ID and everything is getting logged properly. So what I'm going to do is I'm going to right click and look at the properties of my project. And in the debug here, my profile is local process with Kubernetes, right? So when I hit change, I've already set mine up. It's going to select a subscription. I've got my subscription up in Azure. I've got 1 million of them, so I'll check that one. It's going to say what Kubernetes cluster do I want to work on. What's the namespace? And I have my own namespace here called dev. And it's going to ask me what service do I want to work on right now. And I'm going to choose my reservation engine. And then it says what launch profile that I want to choose. And that's the launch profile. And then this is the ingress that gets set up as a part of our product here that I'm going to launch my browser. That's the endpoint that I'm going to hit for my initial request. Basically, that's the launch URL that gets launched when I hit F5. So I hit OK there. We're going to go back to our bike helper, make sure we've got, yep, that set here. So I'm going to hit that. I have a couple of windows I'll drag over here. So it's connecting to our service right now up in AKS. There we go. And it's going to say, we need to make sure it's okay for us to mess with your DNS. Say, yep. And yeah, go ahead and make the change. It's fine. This might take a little second. There we go. And let me drag this window over here. This should kick up and show all of our services running. So there's our bikes helper, our billing helper, there's the Mongo services running. This is coming, this is actually standard out that's coming from our cluster. And there's our key management service. And there's our reservation engine. And yeah, all right, there we go. And here's our actual current ride. Should be able to hit the actual front end. There we go. So it looks like I've got a bike already there. So I'm going to return my bike. Did I click that right? Oh, confirm my return. Yeah, everything good. All right, so I should be able to, let's rent that bike there. For some reason, we're not hitting our breakpoint. There we go. All right. So now I've hit my breakpoint on my local machine. It's routed it down here, and I can go into my locals. And I've got my request ID. Look at the origin request. And I'm able to just kind of debug, and I can just F10 through this stuff, which is awesome. And if I look at my reserve bike URL, there we go. So now that's HTTP bikes API. You can see that right here in red. That's not localhost. That's actually the container DNS that's looking for it in the cloud. So that's actually come from the endpoint in AKS. It's routed down to my machine. And for this particular service, I'm able to debug this and then go ahead and F5 through it. Looks like I hit, there you go. And then it goes right back up here and it says you've rented the women's cruiser owned by Fannie Melton. Awesome, thanks so much. And I'm able to return that blank. And all those other services are actually currently running in AKS. I can confirm the return. It was an easy pickup, awesome. Right, and it's actually got all of these other services running all within the cloud. I can choose another one if I like, hit that rent bike, and able to hit that breakpoint in the cloud again, which is super awesome. All right, let's go back to the slide and present. All right, so we were able to connect to the cloud and debug that service all in Kubernetes. I did not have to fire up all of those services in containers and run them on my local machine. We have the same capabilities within VS Code if that is your IDE of choice or your editor of choice. One of the other future things that we're working on right now is increasing your confidence in the pull request. So as I'm making code changes in that reservation service, typically it consists of code diffs, limited to team members who only have the context, and also minimum visibility. We're calling this kind of PR flow 2. So what I can do now is make a code change, check that in, and through GitHub Actions and through dev spaces here, it'll actually generate a specific URL to my pull request in that context and create a place within the PR there for somebody to come in and review the entire application running in the context of my pull request. So they can look at it, run through that, test things visually, and make sure everything is great, and be able to do that merge prior to actually taking effect. So it allows them to review the code in my context of making that change as if they were running the code on my machine with that kind of specific URL, which is really great. The roadmap of where we're going with this, where the team is going with this, is local Kubernetes support, being able to run this same type of extension on Docker Desktop, Minikube, kind. Doing some developer-specific routing, kind of working in isolation. The PR flow V2 that I just talked about. Pod identity, service endpoints. We don't currently support service mesh right now, but they're also working on that. And that's what I've got right now. I appreciate you joining the day. It's been a long day for everybody. It's a long day for me. I've got a lot to consume myself. There's some links to the 2019 and Docker tooling demo, as well as the local processing Kubernetes walkthrough there. If you have any questions, reach out to me on Twitter now, later, any day with the hashtag .NETConf. And I appreciate your time today, and as always.
Hey, we have a question.
Perfect.
I got it up showing right now and say, are these microservices debugging tools available in the VS Community Edition? Since we have different flavors of Visual Studio, is it across the board, or do I need a special flavor of it, or how does that work?
Yeah, that's a great question. I believe the Docker tools are available in Community Edition. I pretty much run Community Edition most of the time. In fact, let me look right now. I am running Community Edition right now. I run Community 2019 Preview. So everything you saw today, I was running in 2019 Preview.
Perfect. So that means that you can just download it and then have the tools installed and be off to the races.
Yeah.
Perfect. Well, that was literally the only question that we had. So
perfect.
So that's good. You did it. Yeah, great job in the demo. Actually, there was a comment I would say from Cecil saying that you need to use the HTTP client factory. So that's just yes. Him.
I knew somebody was going to pick on me for that. And I meant to mention that as normal non-Hello World demos, you would use Client Factory for making a call, but yeah, in my 25-minute demo, I didn't have time to do that.
Right. So tip of the hat to Cecil for looking at that. It's like, wait a minute, we can do better than that.
Tell Cecil I'll be sure to review his Dapper demo and poke at him for that. So thank you.
That's right. And this is why we are all good friends.
Yes, exactly. Thank you.
Perfect. That's it. But yeah, thank you so much for joining us. I think we're going to have our wrap up here, Jeff.
Yeah, I think it's about time.
Perfect.
Oh my
Sweet.
goodness, what a day!
I know. It's. I think I've had like 20 of these already, just drinking water nonstop.
Yeah, yeah, it's been a full day. My goodness. How many total sessions did we have? 12?
12 total sessions. Yes.
My gosh, it's so good to get front to back, great content, experts, folks that help build some of these technologies, like Burns, like David Fowler, have Kelsey Hightower come in and give a talk, have Shane Boyer help us right there at the end. Really great stuff.
Yeah. Well, the interesting thing about it too is like we had time zones across the globe. Like Shane and you are Eastern, so it's like 8:30 p.m. your time by now. I'm Central. We have Beth Massey and Myra all are in the Pacific Coast, like making sure all of the questions are being put on Twitter. So it's just a lot of work to make this happen. And like I mentioned throughout the entire conference, like you've been the OBS DJ, making sure that everything works behind the scenes to make sure that we have a great show.
Yeah, 15 sessions we're being told, and thousands of viewers from all over the world. Just phenomenal. Always love doing these .NET Conf events.
But we're not done with this event yet, right, Jeff?
No, we're just done for today.
Yes.
There's more, because we've got a full workshop tomorrow, only on Twitch, but you're going to be able to tune in and you're going to be able to see Robert Vitor talking about getting started with microservices, how to architect your applications, get things into Azure, get into containers. Really complete workshop that we're going to see tomorrow.
Yep. And the best part about it, we're also going to be putting that same viewer for the Twitch in the website. So it's not like you have to go to Twitch and log in or anything else. You can just go to the website here, focus.netconf.net, and view it right there. And tomorrow we have another special thing happening. You know what that is?
Well, okay, we announced .NET Conf in November. But, I mean, there's something else tomorrow? What else is tomorrow?
We have the call for content opens tomorrow for .NET Conf 2020, which is big because it's our 10-year anniversary of doing .NET Conf, which is huge, huge, a milestone that we have.
And look, everybody knows how to speak and give sessions from home. Mm-hmm. Everybody's talking to our cameras, and we've got cool microphones set up. And we're all set. Everybody knows how to give talks now from here. So let's do it. Submit your talk. Get in for .NET Conf this November.
Yep. Yeah, we have 3 full days worth of content for .NET Conf 2020. So if you go to www.netconf.net, that's where we will have information for the call for content. It's over papercall.io. So if you already have an account there or you want to sign up, it's pretty straightforward. We want it. We're going to get all this. We want all those proposals coming in. We're going to evaluate it. We're going to be doing just like this 30-minute sessions. So it's you don't have to talk about all the things. You can talk about one specific thing for like 20 to 30 minutes.
Absolutely.
I know.
Get in. We want to hear about. Right, we want to hear about Blazor. We want to hear about .NET 5. We want to hear about mobile applications, F#, C#.
Right. Yeah. So, and when it's the big conference, we covering all the breadth of .NET. For these ones, for the focus ones, we've been only specific to like microservices, Xamarin, or Blazor, right? Because we just want to be able to talk about that specific technology set. But once we get above that, it's all of it, even Azure, right? It doesn't even have to be .NET on Azure. That'd be great to get more of that content. So, but yeah, so I'm excited for the conference, for the workshop tomorrow. You're going to be being OBS DJ again for that one.
Absolutely. Yep.
Getting everything going. So yeah, but thank you so much, everybody, for taking the time and joining us all day today. We are actually going to be setting it so you can rewatch the content, right?
Yes, we're gonna kick off a replay right from the beginning of the day so that you can get in and catch up if there was stuff at the beginning of the day that you missed.
Or folks that are already asleep because time zones, they can wake up and they can continue watching all the content for the remainder of the day.
Absolutely, right here on Twitch on the Visual Studio channel.
Yep. Yep. And I think we'll be updating the website to show that as well. So it'd be nice to kind of have it all there together.
Absolutely.
Perfect.
All right.
Thank you, everybody. I hope you had a wonderful day of content, and tune back tomorrow for the workshop.
All right. We'll see you later.
See you, everybody. Bye.